it is my absolute honor. I am Anu Yadav and it is my absolute honor to be your anchor for this notable international conference. Now we are going to start the plenary session of day 3rd of APM 2025, 16th International Conference on Advancement in Petrochemical Sector and Empowering Sustainable Development leading to Viksit Bharat. I believe this session is going to be more informative and interesting. It's my great pleasure to invite Dr. Joseph and Benjay, Director and Head CIPET IPT Bangalore. Give them a big round of applause. Now I am handing over this session to our respected chairman. Mike.
Very good morning, Professor Dalai. Hello? 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 Professor Ajay? Hello? Hello? Professor Ajay?
Yes, good morning. How are you?
Yeah, good, sir. Good morning, sir. Welcome to the conference APM 2025. So, on behalf of the organizing committee, I will welcome you, sir. So, Professor Dalai is a distinguished professor in the Department of Chemical and Biological Engineering at the University of Saskatchewan. He has served as a Canadian Research Chair 2001 to 2024 in Bioenergy, Head of Chemical Engineering, and as Associate Dean, Research and Partnership in the College of Engineering. Professor Dalai worked as a Special Advisor to BP Research, signature areas of energy and mineral resources. Dr. Dalai research focus on biomass conversion technologies, novel catalyst development for gas to liquid technology, biodiesel production, hydrogen, and SANG gas production, hydro processing, value-added products from biomass, and pollution control. Dr. Dalai has published over 700 research papers, mostly in heterogeneous catalyst and catalyst process in international journals and conference proceeding. With his 150 plus researchers and many national and international collaborators. He has got several patent applications. His groundbreaking research has led to over 49,500 citations of his work. Height index of 109 and I-10 index of 497. He serves as editorial board of several prestigious journals. Professor Dalai has received fellowship from different societies such as Royal Society of Canada, Royal Society of Chemistry in UK, International Association of Advanced Materials, American Institute of Chemical Engineering, Chemical Academic of Engineering, Canadian Academic Engineering, Chemical Institute of Canada, Engineering Institute of Canada, Indian Institute of Chemical Engineers, and Indian Chemical Society. Professor Dalai is also a Fulbright Fellow from USA, DIAD Fellow from Germany, and JSPCS Fellow from Japan. Professor Dalai has received several national and international awards. Recently, he has received Indian Institute of Chemical Engineers DRC Lifetime Achievement Award, Canadian Society of Chemical Engineering RS John Memorial Award for Outstanding Contribution to Chemical Engineering Profession, Royal Society of Canada's Marcellus Ramaskia Medal for Outstanding Contribution to Environmental Science, University of Saskatchewan George Ivan International Award, and University of Saskatchewan District Research Award. So on this, welcome you, sir. Over to you, sir. Please proceed.
Thank you so much for a very, very generous and kind introduction, sir. And I'll just share my screen and then I'll start my presentation. Can you see my screen?
Yeah, yes, sir. Please.
Okay, thank you again. Thanks to Dr. Shishina, the DG of CIPET, and also the organizing committee for kind invitation to speak to you this evening or this morning. I'll be talking about the novel conversion technologies of waste plastic to hydrogen. My co-authors are Madhya Harabi, which my PhD student, and Satyapal Chri, which my postdoctoral fellow. So the work is mostly done by them. So I will introduce the topic on this waste plastic utilization for hydrogen production and the research we are doing, and discuss on the results in about 20 minutes, and then conclude my presentation and also mention about the take-home message followed by acknowledgement. So if you look at this slide, globally more than 360 million tons of plastic is manufactured per year, and that is contributing to more than 84% to 5 different industries. Packaging industry consumes about 36% of plastic every year, construction 16%, consumer product 10%, industrial machinery 1%, textile 15%, transportation 7%, electrical 4%, and other 11%. And when you look at the life of the plastic from the packaging and consumer products, the life is about 2 to 5 years. The textile and electrical and electronic components, plastic components last from 5 to 10 years. Transportation sector lasts for 10 to 20 years. Industrial machinery 20 to 30 years, and building construction material up to 40 years, 40 to 50 years. So you can see that all these different consumer products have a fixed life, and what happens after the life is over for these plastics? That is the real question. And when you look at the environmental issues, it has a large implication to environment. So they are basically after their life. Some of them are recycled, but mostly taken to the landfill, causing serious environmental issues. And by 2050, if this trend continues, more plastic waste would be in the ocean than we have fish in the ocean by weight. And approximately, more importantly, more than $100 billion are lost every year solely due to the disposal of waste plastic. So this is basically, we are looking at waste to wealth, waste to energy. Let me switch to the global energy scenario. The graph that we see on the left side, we find that 80% of the energy is coming from the petroleum, natural gas, and coal. And with the expectation of high quality of life by everyone in the world, and also followed by population growth and quality of life, quality of utilization of energy. There would be more increased expectation of energy production and usage, and we see that that trend might go up. But when you look at the Paris Accord and other accords, we want to reduce the fossil fuel usage and increase the usage of the renewable energy sources. And if you look at the pie chart in the right, it shows the emission. China, United States combined, they emit more than 50% of the carbon dioxide in the world. So I think different countries consume different amount of energy. Therefore, they emit different amount of CO2, but it has a long-term environmental negative impact. So if you look at the rise in carbon dioxide in the left side, now it's about 423 parts per million. And that also has a direct impact on the temperature rise over the planet, as all of us do know. And that is shown in the graph in the right side. And when you look at the global fossil fuel consumption, different countries have different amount of energy consumption, and per capita consumption is also very different, as you see in the slide in the right. But nonetheless, all of us are responsible in using the energy and also polluting partly the environment. So what is the issue with the use of fossil fuel? The one thing is non-uniform distribution, as I showed in the previous slide, higher emission of oxides of sulfur, nitrogen, and carbon that leads to accelerated global warming and also leads to depletion of resources. And also it leads to increase in the global temperature, as you see in the middle of this page. And also the overall greenhouse gas emission, about 81% is carbon dioxide, 10% is coming from methane. And we know that methane has 20 times more greenhouse gas effect than carbon dioxide and more dangerous than carbon dioxide. And when you look at the consequences, so this leads to global warming, acid rain, soil erosion, deforestation, poor work, air quality, and most importantly, it harms the human and biological, human and animals or biological resources. So now what we can do with the more plastic pollution and energy crisis? Can we kill two birds with one stone? This is what we are looking at when you want to utilize waste plastic for hydrogen production. So the waste plastic valorization can minimize the environmental damage by plastic, and upcycling of plastic to high value fuel and chemicals will create wealth from waste. And also the production of hydrogen from plastic would lead to negligible pollution of sulfur and nitrogen compounds. And also it can help to substitute partly the hydrogen coming from conventional source. And of course, you can look at the alternative fuel for reducing the greenhouse gas emission. So when you look at the advantages, the plastic upcycling, we can incinerate to produce heat, for example, and also we can use the primary recycling process or secondary recycling process to produce recycled plastic. But with the repeated recycling, the plastic strength and the quality and property are reduced. And also, if you look at the use of plastic in the right side, it can support many value-added products, carbon material, a new polymers, composite material, valuable chemicals, liquid fuels, and hydrogen. And in this research, we are more focusing on the hydrogen production from waste plastics. So let's look at a little bit about what research we are doing on the conversion of plastic to hydrogen. So we are looking at basically three different technology. One is the supercritical water gasification technology that we have focused in this research. I'll be talking about this, and steam gasification for producing hydrogen, and also microwave assisted technology to produce hydrogen from waste plastics as well. So what is supercritical water gasification technology? So when you look at the page diagram in the right side, where we have the plot of the temperature versus pressure for water for different phases. We have a triple point, then we have a normal boiling point. Then we have also the critical point. The critical point is at 374 degrees C and 218 atmosphere. And when you heat the water to beyond this condition, the physical and chemical properties such as the ionic properties, density, dielectric constant, viscosity of supercritical water are greatly different from either extreme state of the gas phase or liquid phase. And the advantages of using supercritical water gasification process for hydrogen production is that it can dissolve complex hydrocarbon like plastics. It has a better solvation property for organic compounds, and it can reduce the mass transfer limitation between reactants. It also produces no toxic byproduct, and also can give hydrogen rich synthesis gas product. So when you use the supercritical water for hydrogen production, it can be used as a solvent, and so here it basically can dissolve plastic in no time, and also it can work as a reactant. It can also work as a promoter as well. So in the supercritical water condition, it basically reduces the mass transfer limitation, and it acts as a solvent for organic material dissolving complex hydrocarbons like plastic. It provides a medium where gasification reaction can proceed rapidly, and also water at supercritical condition state can facilitate hydrolysis reaction where polymers break down into smaller molecules, and a reforming reaction where hydrocarbons are converted to synthesis gas. And at supercritical state, water as a solvent, reactant, and promoter, uh, it acts in such a way that facilitate hydrolysis and reforming reaction. And also, if we use a catalyst, it can accelerate the chemical reaction. And this can also, there are many challenges of using supercritical water gasification. It can, due to the severe condition, it can lead to the leaching of active site, and also it can look at loss of surface area of the material. It can lead to pore blockage, and also it can reduce the active site by creating large crystals of, which prevents the or lowers the reaction. And in addition to that, the supercritical water is highly corrosive in the presence of salt, chlorine compound, and acid intermediates from plastic decomposition. And also the special corrosion resistance material such as Hastelloy, Inconel, increase cost of our reactor. Catalysts play a crucial role in increasing the hydrogen yield, but they suffer from coking, reducing catalyst activity, metal sintering at high temperatures, leading to loss of activity, surface area, and catalyst poisoning by chlorine, sulfur, and other contaminants present in plastic waste. And achieving high conversion efficiency depends on process condition. Optimize this condition for different plastic feedstock is complex, and gasification often requires high energy input, affecting overall efficiency. So these are some of the advantages and drawbacks of the using supercritical water gasification for producing hydrogen from waste plastics. So now let me talk about the supercritical water gasification of plastics, that part of our work. So in this research, what we did is we produced the TOD1, which is the Technical University Delft. At Delft, it's a proprietary material. It's an amorphous material with a 3D interlinked mesopores, and it has a pore size range 3 to 20 nanometer, which is larger than that of MCM 41, MCM 48, and SPF 15, and it has larger pores that make the diffusion limitation absent. For large molecules, it facilitates the reactants for of larger size molecules to react, and it is also thermally and hydrothermally stable like mesoporous ZSM5. So this material is synthesized by reacting with the tetraethyl orthosilicate, tetraethyl ammonium hydroxide, and aging through solvothermal process, and followed by calcination at about 600 degrees C for 4 hours to create this material. Once this material is created, we put 5% of palladium, rhodium, and silver, creating three different catalysts for this particular reaction. And when you look at the characterization of this material, the X-ray diffraction study shows the rhodium is more or less uniformly distributed on the surface, preventing or eliminating the peaks for this material, unlike the palladium and silver on TUD1. And the middle one shows the mesoporous structure of material with the isotherm 4, as you see in the middle one, and the one in the right shows the physical property of the material, that third one has a surface area of 510, the pore size about 12 nanometer, with the pore volume about 1.5 cc per gram. With the impregnation of 5% rhodium, palladium, and silver, the surface area went down to some extent, pore size went down as well, and the pore volume was down a little bit. But with the rhodium on third one, we see that there's not much change in the physical property of the third one when you loaded 5% rhodium on this material as compared to those of palladium and silver. So when you look at the SEM micrograph, we find that with the loading of rhodium, silver, and palladium, the physical structure of the material did not change substantially. And then we used a batch reactor to do the supercritical water gasification of plastic. It's a high pressure power reactor. The temperature, pressure, and reactor volume are listed in the left side. And then the temperature was varied from 440 to 520 degrees Celsius. Just to remind that the temperature, the supercritical water condition is 373 degrees Celsius, and the pressure is about 22 megapascal. And we use the model feed, the polypropylene, and also use the mixed plastics for this reaction. So when you look at the hydrogen generation with the no catalyst, for example, no catalyst, no hydrogen, and with the rhodium, we found that the amount of hydrogen was increased to 17.4 millimoles per gram, and the amount of polypropylene was 5 grams, catalyst load 10%, water 50 ml, and then the feed to water 1:10, initial nitrogen pressure, temperature, etc. They are all given in this particular slide. When you look at the effect of temperature, we find that with increasing temperature, the amount of hydrogen yield went up, and with the catalyst dosage from 2.5 to 5 to 10%, we find that 2.5% work better, because beyond this there is a issue in mass transfer problems, having more catalyst in the smaller reactor, and also with more water, we find that from say 10% was ideal, and more than 10% we found that water has a somewhat more negative effect on the total hydrogen yield. So this basically shows the kind of the optimization that we did for creating hydrogen from the waste plastics, for example, the polypropylene. So when you look at the polypropylene and mixed oxide with the feed, we find that with the rhodium on TUD1, the polypropylene from the hydrogen from polypropylene about 50 millimole per gram, and for the mixed plastic went down to over 60. And then we also did some the recycling of the catalyst, and we found that it's somewhat decrease in the activity with the time because of the pore plugging and during this the reaction at more severe condition. We also did the EDS and mapping for rhodium TUD1, and I find that the rhodium is more or less very uniformly distributed on the TOD1 support. So when you look at the comparison of activity of supercritical water gasification with those of polypropylene and mixed plastic, we find that we can produce about more than 1,000 liters of hydrogen from polypropylene at optimized condition, and also about 1,370 liters of hydrogen from the mixed plastic. That's liters per kilogram. And why the mixed plastic give more than polypropylene? Because of the synergy between different components present in mixed plastic, leading to more somewhat more hydrogen production. So if you look at the comparison of what we find in the literature, we find that the supercritical water gasification of the waste plastic to hydrogen is quite a promising technology. And now let me talk about the steam gasification of pyrolysis oil from plastics. So in this research, what we did, we took the commercial gamma alumina, we put 10% of nickel, iron, cobalt, copper on this material to produce, and calcine at about 600 degrees C for 4 hours to create 4 different catalysts. And we did this, first did the pyrolysis to get a liquid from the polypropylene, and then we passed it through a fixed bed reactor along with nitrogen and water to steam gasify this material, and then we have a moisture trap and a condenser to condense this liquid and then analyze the product. And also the gaseous product. And then when you look at the energy efficiency for this particular material, then we find that the energy recovery is about 80% with the one from nickel on alumina as compared to other two materials, and it looks quite promising as well. So this is kind of research ongoing and looks quite promising as well. So let me conclude my presentation. So as I mentioned, we are producing more than 360 million tons of plastic a year, and about $100 billion are lost every year due to disposal of plastic. And I'm sure this is also a huge issue in India as well when you want to come to plastic recycling. And what I demonstrated that noble metal based catalyst such as rhodium TUD1 exhibited superior catalyst activity at supercritical condition, and we can get over 1,300 liters per kg of hydrogen from mixed plastic at a low temperature of 520 degrees Celsius, owing to the higher dispersion of metal on the support. And the enhanced catalyst activity could be due to the synergistic effect leading to rapid plastic degradation. And also when we look at the gasification efficiency for the steam gasification work, we find that nickel alumina catalyst works better as compared to other metals, and this works better at low gas hourly, liquid hourly space velocity and high water to oil molar ratio, so that it maintains the improved catalyst stability and durability. And also we find that higher molar ratio of water to pyrolysis oil prevents the coke formation during the reaction, and also it enhances the gasification efficiency of the process. So what is the take-home message? The take-home message is that disposed plastic waste should not be seen as a waste, but it's a resource for producing clean hydrogen. Integrating the plastic valorization with the plastic recycling will have a significant economic and environmental benefit. Production of hydrogen from plastic leads to a sustainable approach for meeting the growing hydrogen demand at present and in future. This could avoid major environmental pollution caused by plastic and benefit the environment, industry, and society. So there are some of the references here that I used in this presentation. We have these are founders over years that are working with us on different projects, including the hydrogen from waste plastics. So this is my research team at the University of Saskatchewan with many people from many different countries, and just wanted to thank you for your attention, and I'll be very happy to have any discussion or they need any clarification on what I presented. Thank you again for your attention. Thank you for the opportunity to present part of our work on this innovative area that requires the disposal waste at the same time producing clean energy that we need every day in our lives. Thank you.
Thank you, Professor. One question from audience.
Good morning, sir. This is Dr. Sushant. Sir,
Good morning.
in your XRD study and this BET analysis, you have shown rhodium and other things. There is no significant changes in pore size. What is the reason behind it?
Actually, this is not very uncommon. What happens is when you load 5% metals on a support, depends on how the metals are being located inside the pores of this material. If the larger pores consume these metals, then average pore size will decrease. If the metals go to smaller pores, the average pore size will increase. So what it shows, the material is kind of more or less uniformly distributed in large and small pores. So the average pore size does not change.
So, another thing
Is
is
that
there,
bit clear?
yeah, oxidation state of rhodium.
Yeah, yeah.
It means for that changes.
Actually, we have done some XPS work. I don't have the result handy. But what happens with the rhodium when you look at the hydrogen production, it would reduce the rhodium oxide to rhodium metal form on a continuous basis, which is the active phase. But if you ask me how much rhodium 0 and plus 2, etc., are present, I will need to get back to you on that. I don't have that information handy right now.
Thank you, Professor.
Good question. Thank you. Thank you.
Thank you,
That's
Professor.
good.
Hello. Thank you, Professor, on behalf of organizing team. So once again, we thank you for the valuable presentation. Thank you, sir.
Thank
Thank
you.
you so much.
Thank you.
So now we are going to move on next talk. Good morning, Professor Ashok. Hello. Hello.
Good morning. Good morning. I just turned my microphone.
Good morning.
on.
Welcome, Professor.
Thank you.
Professor Ashok Vasdeva received a PhD from Virginia Polytechnic Institute, State University. He is awarded on honoris causa doctorate from Riga Technical University, honorary membership of Academic of Sciences of Moldova, and gold medal for his leadership in nanotechnology from the National Polytechnic University of America. Currently, he is CEO, CRO, and Executive Director of for Strategic Research with the International Clear Water Institute of in Virginia, USA. So like many more things, uh, he is the author editor of 21 books and he has published over 350 articles in scientific journals, book chapters, conference. He served on the editorial boards for several international journals and he is an active member for various professional organizations. Welcome, Professor. Was this over to you, sir? Please.
All right. First of all, good morning to all of you. I guess you can hear me well. And in addition to organizing committee, I would like to thank Professor Sina for his support, his motivation to continue to organize APM conferences. And of course, my apologies for not being there this year in person. So this morning for you, it's close to midnight here in US. I'll present one part of our research on Internet of Things devices, more specifically, material consideration for energy harvesting. So let's see. Okay, I just wanted to see how it continues to move forward. So let me give you the rationale for the presentation. And of course, you see at the bottom of the screen an outline of the presentation. So I'll spend a few minutes. Whenever there is a direction for new research, of course, we need to have rationale. And that being that because of there's a significant progress in the Internet of Things devices because of the fact they are used pretty much for all the application. And half part of my research is on defense and security. And IoTs are contributing a lot to security. So sort of gives me twice motivation to work not only from the material aspect, but from the security aspect, which I'll not discuss, but sort of tangentially mention. There is a significant need for generating off-the-grid source of energy using lightweight batteries and energy harvesting materials. And so this is what my presentation is going to be on energy harvesting material after I have gone through some of the motivation for this study. So this presentation outlines ongoing investigation into optimizing material to provide energy and also serve as onboard sensors. Again, outline being that I'll point out that IoTs are facilitating our connected world, exponential technologies and Internet of Things, both of them are progressing very well. There is a mechanism called cyber physical system. It's essentially a course. It teaches students how they connect internet and the devices in the form of sensors together and how we can use collectively. There is also a mechanism on the side which I'll mention very briefly. It's called Internet of Behavior. It's extremely critical to understand IOB in context of IoT. So I'll sort of briefly mention, because that's not the main focus. Main focus is on materials, but nonetheless, I want to emphasize importance of that application of IoTs and IOBs, power generation strategy, material consideration, figure of merit, and as backup, I have a couple of slides in case time should permit. I'll mention use of artificial intelligence, machine learning, deep learning, big data, etc., and material synthesis and device design. If not, I'll close at the figure of merit. So, okay. So as all of us know that we live in a highly connected world using your cell phone, not only you can communicate, but you can also control lots of devices. We have capability, we have drones, which we can fly remotely using our Internet of Things devices, using cellular phone. We could control the temperature of the house remotely. We can open garage and so forth. So all these IoTs are used for very large application. So, and this slide simply shows different types of pressure sensors, 6-axis inertial measurement unit, and accelerometers. Most of our cell phones have pretty much large number of these functionalities. And of course, depending upon application, you have more functionalities, and all of these require power. And that's what makes it bulky. What we are trying to do is using energy harvesting devices, we could reduce the size, we could increase functionality, not only in connected device, but even off the grid. So that's being one of the application. Although in past 10 years or so, there has been significant progress, as is shown in this slide, such as the reduction in power. Using these devices, accelerometer noise has reduced, its stability has increased in terms of gyroscope and other functionalities, size reduction, full-scale range. In red, there are two mechanisms. I may not have time to finish, but these devices also add to artificial intelligence and machine learning, which comes through embedded finite state machine and machine learning core, and also a process called bone conduction. But then again, I just wanted to mention in the passing, I will not have time to go into these. So this slide simply shows functionality of IoTs. They are used for transportation, power grid, traffic systems, SCADA systems for controlling our water, energy, data centers, and of course using computer, using your devices, you have quite a bit control over all of these devices. So because of its large functionality, it obviously gives a lot of motivation to see if we could reduce the size, increase the power capability of these devices using different types of materials, which I'll mention in the presentation. So very briefly, again, I just wanted to mention, because this is a course which I teach, it's about cyber physical systems. It's a multidisciplinary course. It teaches how the physical processes and the software connect these devices as integrated network system of systems so that we can control these devices. It's an interesting course. And of course, because of the large use of IoTs, obviously this course has importance. This slide simply shows a outline of the course where we have application space, we have a feedback space using a network, using scalability. We can of course continue to see tremendous amount of application in terms of economic and societal potential of this system, which obviously continues to expand, as I mentioned in the previous slide. And of course, with the use of artificial intelligence, which is nothing but an algorithmic learning process, we can increase their more functionality. So again, without going into what's AI and how does it relate, it all consists of tremendous amount of data. And of course, that needs to be stored. For that, we need power. And as mentioned, artificial intelligence in so-called edge computing, we need tremendous amount of power. And that's where our part comes in to provide power to these devices using material. And that's what I'll be discussing. So these are the slides I just wanted to show, share with you to show the motivation into this research. In the passing, I also wanted to mention something called Internet of Behavior. This process refers to behavioral analysis gathered from the Internet of Things devices, our cell phone, or devices. They continue to monitor our behavior And of course, for that, we need storage. So Internet of Behavior plays a very large role in optimizing these devices. So that's the reason I wanted to mention in the passing that IOBs are also connected somehow to the what we are going to be talking about in terms of material optimization. So that's what we are going to discuss in the following slide. And of course, this shows the spectrum of application going from military to health and medicine, agriculture, transport, and so forth. So let's now return to the topic after having looked at the motivation. This slide shows simply conventional sensors versus the desired, what we would like to have. I've been working on thin and thick film processing for a very long period of time, and in making sensors, these are mostly resistive, piezo-resistive, capacitive, piezoelectric, and so forth, using thick and thin film processing. But now the desired characteristics are we need to have flexible, lightweight, resistive, piezo-resistive, piezoelectric, and again, lots of characteristics which I've shown in the slide, including tunable characteristics. And some of these devices we prepare using processes called electrospinning, sol gel, spin coating, 3D/4D printing, and I'm sure most of the people in the audience, they use these types of processes as well. So what we are going to discuss is what types of material consideration we would like to have so that we can optimize characteristics for IoT and IOB types of devices. The first being whether it's ferroelectric or non-ferroelectric. Most of the application which I'll discuss would be based on ferroelectric. Then in terms of piezoelectric materials, we use a combination of not only natural, but also ceramic, synthesis, and also composites. So I'm going to show you some of the materials using combination of 3 different types of materials: ceramics, synthetics, especially polymers, and composites as well. Also, we could do optimization in terms of figure of merit, which I'll point out just a little bit later. And based on that, we can then design this material so that once we obtain the power, it's for a certain application, such as for mechanical source, as is shown in this slide, how much power do we need in case it's a light source, the power which is needed, and so forth. So this sort of gives us design consideration as to what materials to choose for what specific application. Again, going into design consideration, we try to select whether it's a polymer or a composite based on flexibility, based on its density, based on mechanical quality factor, and so forth. So we can choose a specific material for a specific application, depending upon what the application is and what the energy requirements are. Using 3D printing, using electrospinning, I'll show you some of these processes. These are some of the configurations, such as cantilever, such as circular diaphragm, similar types of transducer. So we can prepare pretty much all of this configuration using combination of the processes, which I'll show in the following slides. One of the processes which we have used extensively is electrospinning. I'm sure most of you know, whether it's a blended, coaxial, emulsion type, depending upon specific application, we can choose appropriate additives or dopants into this material so that we can prepare membranes based on a specific application. Of course, we use different types of polymers, additives such as PVDF, and few more to design specific application as desired. This is something which we have done for quite some time using different types of membranes which have capability not only of chemical and biological sensing, but also pressure sensing membranes, which are used pretty much for tactile sensing. On the left, you see e-textile, which is used by the Native Soldier Center. And of course, we provide different types of membranes which go into the soldier's outfit for some of the application. The communication application still we are working on, but pressure sensing membranes we have developed. We have made chemical and biological sensing. So these are all embedded into those types of outfits. Again, this is 3D 4D printing, again, for making different configurations, which I had shown before. This slide simply shows different configuration. The one which we use most of the time is the fused deposition, although stereolithography, digital light processing, and polyjet photo printing are also used. But this one we use for very specific device design. This is a combination of electrospinning and 3D printing. It's a high rate deposition, but the Taylor's cone is collapsed with a circular ring application of electric field on the ring, which is shown in this slide, and that we can design very specific devices using this configuration. We also have a combination of 3D printing and electrospinning, where we could continue to switch back and forth between 3D printing and electrospinning to make different types of device configuration, as is shown in the right panel of this slide. Again, these are some of the process which I'm sure most of you use in terms of sol gel, spin coating, electrospray deposition. So we have tried all of these. It depends on what the specific application is. If we can add those materials in specific quantities, and of course they have to produce those specific characteristics. So these are a spectrum of processes which are used with collaborators for making these types of material. But then again, as I mentioned, that we add different types of composition to make sure that they have desired characteristics. One of the material which we use is PVDF because of the fact not only semi-crystalline, but also it has piezoelectric characteristics. And some of the characteristics are presented in this slide, which I'm sure one can find in handbooks. But more important thing is its non-centrosymmetric phase, which provides piezoelectric characteristics. And of course, it has the direct and inverse piezoelectric effect, and that's the one which we use for pressure sensing types of mechanism. But at the same time, the beta phase, which is actually responsible for the piezoelectric characteristics, is not very strong. So we use different types of ceramics, which I'll show you in the following slides, to make sure that we have a strong pressure sensing or piezoelectric effect. So these are some of the measurement apparatus which postdocs and my students use at different laboratories to see also using FTIR and Raman if they have the beta phase. If not, what can we do to increase the beta phase? But more importantly, we want to add materials as additive in these processes so that it has higher longitudinal piezoelectric strain coefficient, and that obviously would provide a higher piezoelectric effect, which I'll show you in the next slide. So these slides simply shows several materials, piezoelectric materials, So in a series of processes, we have tried to add, especially the ones which are circle on the left where it says piezoelectric materials, and try to see if by adding those, we can enhance the piezoelectric effect or so-called the beta phase in the film. Again, these are lots of experiments which are conducted just to see if we can enhance the piezoelectric or the beta phase in the films. Following the addition, we then make devices and try to look at different characteristics. And based on that, we try to calculate the figure of merit of these devices and some of the characteristics which we have measured as a function of temperature are shown in this slide, such as pyroelectric coefficient, dielectric constant, voltage responsivity, detectivity, and energy harvesting efficiency or capability. This equation, which is simply based on energy of a system, so treating a pyroelectric or piezoelectric harvester as a CR or LCR type of a circuit, we look at the energy, and what you see on top is the equation which talks about the energy of the system. It's divided into 5 different components. One is the material properties, structural design properties, external force, working frequency, electric load, time, and of course, the dielectric constant obviously relates to the temperature. So we try to calculate based on what I have shown in the previous slide, and then we try to plug into this particular equation. At the present time, this is manual process, but of course, once we have more data, we want to see, based on the material configuration, how we can increase the energy of the system. So then again, once we have a higher piezoelectric characteristic, we can see if a given configuration in terms of its material configuration would provide us a higher energy of the system. So in conclusion, what I presented is the parametric dependence, which provides us with the suitability of material for specific application. Temperature dependence on the dielectric constant and resistance will allow us comparison with theoretical values. Advances in IoT, that's critical and essential. AI-based decision support tools, once we have these devices which have a higher energy to support IoT functionality, that will provide us capability for the AI-based decision support tools, integration with the new platforms, especially with the IoT and IoBs, paradigm shift in using different technological innovation, and convergence with different other fields, and of course, creation with new opportunity. So I think I sort of gone a little bit quicker. So I just want to show you 2 or 3 slides as how these devices would give us artificial intelligence capability. So what we have added in addition to our sensors is something called a finite state machine modality. FSM is simply an in-sensor behavioral model, which is composed of finite number of state and transition between the states. So that modality we have added with the sensors, and it's able to generate interrupt signals activated by user-defined motion patterns. Something else which we have added is something called machine learning core, which is a sensor classification engine based on the decision tree logic. What that means is once you have data, based on that, you could program a device to learn how to use the data and then, of course, make appropriate decision. So these are 2 capabilities which we have added into the devices to make them more intelligent types of sensor, and that's how it contributes to artificial intelligence as well as the so-called edge computing or the machine learning. So with that, let me thank all of you for your kind intention. And of course, if you have any question, I'll be happy to answer. Thank you.
Yeah, anybody want to ask any question? Anyone want to discuss? So I think no questions, sir. Thank you,
Okay.
Professor Ashok. Thank you so much.
You're welcome.
Huh? Hello, Professor Sabu Thomas.
Yes, yes.
Good morning, Professor. Yeah, hello. Sir, on behalf of team APM 2025, welcome you, sir. So, brief introduction about Professor Sabu Thomas. Professor is a director of Center for Nanoscience and Nanotechnology, Mahatma Gandhi University, Kottayam, Kerala. He is also currently the chairman of Trivandrum Engineering Science and Technology Research Park, Trivandrum, Kerala, India. He was the former vice chancellor of Mahatma Gandhi University, Kottayam, Kerala. Professor Thomas is a highly committed teacher and remarkably active researcher, well known nationally and internationally for his outstanding contribution in the polymer science and nanotechnology. He has published over 1,600 research articles in international referred journals, also edited and written 250 books. His Height index is 150 and total citations are more than 1 lakh. He has supervised 130 PhD theses. He has received many international and national awards and recognitions. He received his honors from Haswa, from Europe universities, and honored professorship from Siberian Federal University, Karnak, and Satya University. He is a resident of Russian Mega Grant with the SFU. He is in the Stanford list of best 2% top scientists in the world for 4 consecutive years. Under the leadership of Professor Thomas, Mahatma Gandhi University has been transferred into a top university. Welcome you, sir. Over to you, sir, please.
Very good morning. Can you hear my voice? Can you hear me? Can you see my slide? Can you hear me?
Yes, sir.
Can you see my slides?
Yeah.
Very good morning. Thank you for the kind words of introduction. I was supposed to come for the APM meeting in person. Unfortunately, I could not make it due to the busy schedule back at the university. Dear friends, I'm going to talk about new opportunities on sustainable materials. I'm going to talk about how we can make sustainable materials from agricultural waste. That's the core of my talk. And before that, I want to show you a very important slide. If you look at the Paris Agreement, one of the important documents for the Paris Agreement is to keep the global temperature increase below 1.5 degree. This is one of the important requirements for Paris Agreement, vision document of Paris Agreement. And dear friends, we want to keep the temperature below 1.5 all the time. The only way is we have to follow the path of circular economy. That means you collect the raw materials, you make the product, you reuse and recycle the product. This is a closed loop structure. So today I'm going to talk about how we can achieve circular economy by following renewable materials. One of the ways of attaining circular economy, and I'm going to talk about how we can utilize biomass for advanced functional applications. Dear friends, 1.6 billion tons of biomass materials have been produced across the globe. Biomass from municipal solid waste, biomass from forest plantation process, biomass from animal processing waste, marine processing waste, quite a lot. And if you look at the plant biomass, like sugarcane, bagasse, wheat corn, rice bran, corn cob, they are all very exciting materials. And I have a beautiful chart how much of materials are being produced worldwide. Wood cloud is number one, then bamboo, cotton, lint of biomass materials. If you look at these friendly materials, job, that's very important. They're renewable, they're underutilized. I can list a large number of properties in favor of them. How do you classify them? You can extract from the stem. Good example is jute. India has jute, particularly northeast. Flax, canaf, other fibers. India of coconut, east of India, coconut. Now, friends, let me know the price of this material. Take a cotton index of 100. You will find coir, wood, straw. They're all quite cheap materials. How about the mechanical properties? If you look at the mechanical properties of materials, the mechanical properties are very good, like tensile strength, modulus. They are lightweight, so the specific properties are fantastic. They can be glass fiber. What's the chemistry of this material? Essentially, they are cellulose. You can see beautiful hydroxyl group on the surface. Then you have lignin. Then you have chemicellulose. So cellulose, lignin, chemicellulose. Look at the hierarchical structure of the plant. This is a plant cell wall. It's a microfiber, and nanofibers. Okay? And I'm going to talk about these nanofibers today. I'm going to talk about nanofibers today. How we can extract nanofibers from plant fibers. Nanofibers are very good. They have got a good water holding capacity, highly crystalline, high strength, low density. They have fantastic properties. How do you look like? If you examine the nanofiber under high resolution electron microscope, dear friends, it looks like this. Entangled structure of fibrous material. You can produce them by various techniques, high pressure homogenization, grinding, crushing, steam explosion process, acid hydrolysis. High pressure homogenization is a good way of producing nanofibers. Super grinding, cryo crushing, high density ultrasonication process. They're all variety of techniques by which you can make. Now let me show you what we do in my laboratory. My PhD students collect the agricultural cellulose. Look at this. Then we get a slurry. You go for acid hydrolysis, produce steam explosion. And finally, dear friends, we get suspension of nanofibers in water. It's a very simple protocol. If you take a drop of this and dry and examine under high resolution electron microscope, you see what you see. Now, I want to show you our production setup in the campus. This is the waste fiber. We subject them to steam explosion, bleaching, acid hydrolysis. We see finally what we get. Nanofibers. I want to show you some nice pictures from my group. Nanofiber is made from pineapples. Nanofiber is made from pineapple leaf fiber. So we have made nanoscopic fibers from all the agricultural mass available. And we look at the fiber morphology, structure properties. Dear friends, these nanoscopic polymers like polyethylene, polypropylene, polystyrene, natural rubber, SBR rubber are not good. So you have to do a lot of surface chemistry on the surface of this fiber. Chemical oxidation process, carbonization reaction, cellulation reaction, polymer crafting. So several reactions could be performed on the surface of these fibers. Today I'm going to talk about the application of these materials for a variety of fields: wound healing, water purification, sensors, EMI shielding, variety of applications we can use them. Let me now look at the water purification area. So what we have done is we looked at the commercial membranes. Commercial membranes have been given a coating with the nanocellulose, a hydrophilic coating. We found that if you give a hard coating of commercial filters with nanocellulose, the efficiency goes up remarkably. The efficiency of this goes up remarkably. The efficiency of this goes up. This is nanocellulose. We react with the melted acid, we introduce no microscope at the surface of nanocellulose. So we have done a little bit of chemistry, and then what we did is we tried to separate out crystal violet. We tried to separate out crystal violet. This is the commercial filter. Crystal violet is a dye being used by the textile companies worldwide. But dear friends, if you coat with the nanocellulose, the efficiency goes up. If you coat with the chemically modified nanocellulose, you see the efficiency still goes up. So we found that coating with nanocellulose, efficiency of catching that. Look at this is the violet aromatic dye, and when you coat with the nanocellulose, the crystal violet dye forms a electrostatic interaction with the particles. See, look at this. This water has a lot of suspended particles. And then we filtered the water, and we found the suspended particles. And this is the way we made a model system in pure water. This contains 50 to 100 nanometer size iron oxide particles. It's black in color, no transmitters at all because of the scattering. We filtered this water. Look at this, all the iron oxide particles were stopped on the top surface of the filter. And this is the bottom part of the filter, which is CPVDF. See, nanocellulose is able to catch all these suspended particles. So once you coat the commercial filter with nanocellulose, the whole size becomes so small. So we can remove most of the 100% transparent. That means one can utilize this membrane for removal of dirt and impurities. Now, let me show you another interesting slide. Nanocellulose could be utilized for removal of heavy metals. Chromium 6 could be removed. You can see the kilogram absorption is 90 milligram per gram. Okay. So chromium could be removed. Similarly, nickel, cadmium, lead, And we have a beautiful comparison here. This is the macrocellulose, rice straw fiber. Probably we all know that our ancestors used to utilize rice straw, wheat straw for purifying water. They make the bed of wheat straw and then purify water. Ancient times, people used to do that. They were pretty good nanoments. Can look at 90, 95, close to 99% efficiency. The red is nano. So they have a good capability to trap heavy metals. We can also remove bacteria removed by Sisa solution. But if you want to remove viruses, they're very small, they're very tiny. So then if you want to remove viruses, you react with the polymelamine. Introduce massive amine group on the surface of nanocells. Once you have positive charge amines on the surface of nanocellulose, you can have electrostatic interaction with the viruses because viruses have negative charge. So dear friends, we can remove bacteria and viruses, but viruses you have to do a chemistry. And look at this slide. The logarithmic removal of bacteria close to 6. Logarithmic removal of viruses. The Hermes phase. Nanocellulose gel is highly porous. So tissue regeneration is so fast, so rapid. You can have a very rapid
हमारे बीच हमारे आदरणीय अतिथि माननीय श्री असीम अरुण साहब पहुंच चुके हैं। मैं आपसे अनुरोध करूंगा कि आप मंच पर अपना स्थान ग्रहण करें सर। माननीय असीम अरुण जी कन्नौज से विधायक हैं और वर्तमान उत्तर प्रदेश सरकार में समाज कल्याण, अनुसूचित जाति कल्याण एवं जनजाति कल्याण मंत्री हैं। आपका जन्म बदायूं उत्तर प्रदेश में हुआ था। वर्ष 1994 में आपने भारतीय पुलिस सेवा में अपनी सेवाएं प्रारंभ करी थीं और अनुशासनात्मक सेवाओं में अपना योगदान देते हुए आपने बहुत सारे उल्लेखनीय कार्य किए हैं, जिसके लिए आपको बहुत सारे अलंकरणों से नवाजा गया है, जिसमें कुछ हैं पुलिस मेडल फॉर गैलेंट्री अवार्ड, गैलेंट्री, प्रेसिडेंट्स ऑफ इंडिया पुलिस मेडल, प्रेसिडेंट्स ऑफ इंडिया मेडल फॉर मेरिटोरियस सर्विस, यूएन मेडल फॉर सर्विस इन कोसोवो। ये कुछ ऐसी उपलब्धियां हैं आपकी जो ये बताती हैं कि एक प्रशासक के रूप में, एक अनुशासन नियंत्रक के रूप में आपकी सेवाएं कितनी अनुकरणीय हुई है। उसके पश्चात वर्ष 2022 में आपने समाज सेवा का संकल्प लेते हुए राजनीति में कदम रखा और वर्तमान शासन मैं हमारे संस्थान के प्रमुख और हम सबके मार्गदर्शक आदरणीय प्रोफेसर शिशिर सिन्हा साहब, महानिदेशक सीपेट से अनुरोध करूंगा कि वे पुष्पगुच्छ से हमारे पारंपरिक पटके से माननीय मंत्री महोदय का अभिनंदन करें और हम सबकी ओर से एक स्मृति चिन्ह आदरणीय मंत्री महोदय को प्रस्तुत करें। सर। बस 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 एक जैसा कि मुझे बताया गया है कि माननीय मंत्री महोदय के पास समय की अत्यधिक कमी है, अतः मैं आदरणीय महानिदेशक महोदय से अनुरोध करूंगा कि आदरणीय मंत्री महोदय का अभिनंदन करते हुए उन्हें उद्बोधन के लिए आमंत्रित करें। सर।
जैसा कि मंत्री महोदय ने जो है बहुत हम लोगों का उत्साहवर्धन किया, और जब मैं मिलने गया था माननीय मंत्री महोदय से तो उन्होंने कहा मैं आऊंगा अवश्य। पहले तो उनका मन था कि पहले 2 दिन में आए, लेकिन तो मैं ज्यादा समय नहीं लूंगा। मैं सर को आमंत्रित करता हूं कि अपने विचार व्यक्त करें।
बहुत बहुत धन्यवाद। 16वें अंतर्राष्ट्रीय सम्मेलन APM 2025 बहुत तेजी से आगे बढ़ रहा है और मुझको आपके बीच में आकर के बड़ी खुशी है। सभी लोग का मैं स्वागत करता हूं, वंदन करता हूं। खासकर हमारे अनेक शिक्षाविदाएं हैं, हमारे प्यारे छात्र हैं, शोधकर्ता हैं, उद्यमी भी इस कार्यक्रम में शामिल हैं। आप सबको मेरी ओर से वंदन, बहुत सारी शुभकामनाएं। बहुत अच्छा काम आप कर रहे हैं। खासकर मंचासीन डॉक्टर शिशिर जी, डॉक्टर श्री विवेक जी, चाहूंगा दोनों लोग के लिए जोरदार तालियां बजाएं। अच्छी नियत से काम किया जाए तो कैसे तेजी के साथ हम लोग परिवर्तन ला सकते हैं, इसका उदाहरण सीपेट है। मैं इस संस्था को बहुत लंबे समय से जानता हूँ, बहुत गहराई से नहीं, लेकिन जब मैं पुलिस की सेवा में था, कोई प्लास्टिक की चीज़ खरीदी जाती थी तो हम लोग टेस्ट करने भेजते थे और बहुत समय लगता था। तो मालूम होता था क्यों भाई लगता है सीपेट में इतना समय लगता है। लेकिन अब मैं देखता हूं कि हमारे काम की गति बहुत अच्छी हुई है और उस काम से ज़्यादा महत्वपूर्ण जो हमारे युवा साथियों को, शिशिर जी, विवेक जी, आप आगे बढ़ा रहे हैं, ये भविष्य के लिए सबसे बड़ा योगदान होगा। आज का कार्यक्रम, सबसे पहले मैं क्षमा चाहता हूं, मुझको 10 बजे पहुंचना था और जो ट्रैवल टाइम निकाला उसमें 5 मिनट मार्जिन भी था, पर नादरगंज का जाम काफ़ी कुख्यात रहा है। मैं 3.5 साल एटीएस को हेड करता था, तो आपने एटीएस का बोर्ड देखा होगा, आगे एटीएस का ऑफिस भी है, तब भी इतना जाम लगता था, आज भी उतना ही जाम लग रहा है। नहीं, ताली वाली बात नहीं है ये ये क्षोभ वाली बात है। लेकिन इस जाम या ऐसी कोई भी जो समस्याएं हैं, आज हम विकसित देश की बात कर रहे हैं, हमारी थीम में विकसित देश की यात्रा भी शामिल है। अब अगर स्पेसिफिकली मैं पेट्रोकेमिकल सेक्टर की बात करूं तो बहुत कुछ अलग कहा जा सकता है, जिसका मैं विशेषज्ञ भी नहीं हूं, लेकिन मूल सिद्धांत की अगर मैं बात करूं तो सबसे पहले हम लोग को एक प्रॉब्लम सॉल्विंग एटीट्यूड विकसित करने की जरूरत है। समस्याओं का हल निकालने वाला समाज हमको बनना है। जैसे अगर नादरगंज के जाम की बात करूं तो लखनऊ में ही आप देखते हैं कितने जगहों पे ट्रैफिक पुलिस ने वर्तमान व्यवस्था में ही एक ऐसा ट्रैफिक फ्लो का पैटर्न बना दिया, बैरियर लगा के, डिवाइडर लगा के, कि ट्रैफिक धीरे धीरे ही सही लेकिन चलता रहता है। इसका मतलब कोई ट्रैफिक कर्मी है, कोई अधिकारी है जो समस्याओं को हल करने के लिए काम कर रहा है, प्रॉब्लम को सॉल्व कर रहा है, और केवल क्षणिक समस्या को हल कर दिया ये प्रॉब्लम सॉल्विंग नहीं है, जिसको प्रधानमंत्री मोदी जी बार बार हमको याद दिलाते हैं। समस्या को हल करो और उसको ऑटो पायलट पे डालो, मतलब सिस्टमैटिक प्रॉब्लम सॉल्विंग। अगर उसी समस्या को रोज हल करना पड़ता है तो वो केवल क्राइसिस मैनेजमेंट है। लेकिन अगर हमने ऐसा उपाय किया कि ये समस्या तो होती ही नहीं अब, तब हम लोग सही मायने में सफल हैं। तो मूल सिद्धांत के रूप में विकसित देश का मतलब मेरे लिए ये होगा कि हम सब, जो छोटा बड़ा कार्य क्षेत्र हमारा है, जो छोटी बड़ी जिम्मेदारी मेरे कंधे पे है, आपके कंधे पे है, उसको प्रणालीगत हल, सिस्टमैटिक हल हमको निकालना है। हम जब विकसित देश की बात करते हैं तो हर एक के मन में अलग अलग विचार आ सकता है। बहुत से लोग सोचेंगे हमारी सेना सबसे बड़ी हो जाएगी, हम सबसे बड़े पावरफुल मिलिट्री पावर हो जाएंगे तो हम विकसित देश हो जाएंगे। कोई कह सकता है कि हम अर्थव्यवस्था की दृष्टि से हमारी जीडीपी नंबर 1 हो जाएगी तो हो जाएंगे। कोई ये भी कह सकता है कि हमारे यहाँ विषमताएं नहीं होंगी, सामाजिक न्याय बहुत अच्छा होगा। ये सभी बातें सही हो सकती हैं, लेकिन हम वहां तक पहुंचेंगे कैसे? और पहुंचने का रास्ता, जैसे मैंने बताया, सिस्टमैटिक प्रॉब्लम सॉल्विंग के आगे करना क्या है? पहली चीज, हम सबको मिल करके ऐसा काम करना है जिससे भ्रष्टाचार पे हम लोग पूरी तरीके से रोक लगा पाए। जब तक करप्शन को हम अपने डीएनए से बाहर नहीं निकालेंगे, हमारी सारी योजनाएं निश्चित रूप से फेल होंगी। और तरीका उसका क्या होगा? ये तरीका कि हम सब तय करें कि ना अगर मैं पैसा लेने की पोजीशन में हूं, ना मैं लूंगा और ना मैं पैसा दूंगा। जिस देश के प्रधानमंत्री जी साफ साफ बोलते हो, ना खाऊंगा और ना खाने दूंगा। जिस प्रदेश के मुख्यमंत्री योगी जी एक सन्यासी के रूप में हमको मुख्यमंत्री मिला है, उनकी निजी संपत्ति क्या है? जो उनके शरीर पे कपड़े हैं बस, और कोई उनकी निजी संपत्ति नहीं है। और वो कपड़ा भी वही रहता है, कभी 50 रुपए की एक चप्पल पहनते हैं और वही कपड़े उनके रहते हैं। ऐसे माहौल में अगर हम लोग ये प्रगति ना कर पाए तो हम बहुत बड़ा अवसर खो रहे होंगे। हम सबको मिलकर इसमें योगदान करना है। और दूसरा, जो काम करना है उसको पूरे परिपूर्णता के साथ करना है, परफेक्शन के साथ करना है, जो कि आप लोग कर रहे हैं। किसी प्रोडक्ट की मैं बात करूं, जो मुझको इतना सुंदर पटका पहनाया गया है, मुझे बताया डॉक्टर साहब ने कि ये रिसाइकल्ड प्लास्टिक स्पेट बॉटल से बनाया गया है। ये एक नमूना है परफेक्शन का और सर्कुलर इकोनॉमी का। मैं बहुत धन्यवाद देता हूं, बधाई देता हूं कि ऐसा सम्मान कई बार मिलता है, ऐसा पटका भी मिलता है, लेकिन ऐसा पटका जो परफेक्शन के साथ बनाया गया हो और सस्टेनेबल भी हो, सर्कुलर इकोनॉमी को ताकत देता हो, ये बड़े गौरव की बात है। और यही हल है। मैं देख रहा था जो चर्चाएं हुई हैं उसमें बायोफ्यूल्स के बारे में चर्चा हुई है, ग्रीन हाइड्रोजन के बारे में चर्चा हुई है, किस तरीके से हम लोग ट्रांजिशन करेंगे, इसके पॉलिसी इंसेंटिव्स क्या हैं, इसके बारे में चर्चा हुई है। ये सभी बहुत खुशी की बात है। आने वाला समय, खासकर मैं युवा साथियों से कहूँगा कि चुनौतीपूर्ण भी है और बहुत सारे अवसर लेकर के आने वाला है। चुनौतीपूर्ण इसलिए क्योंकि आप देख रहे हैं कि आज प्रतियोगिता का दौर बहुत तेज है। आपके बगल में छात्र बैठे हैं, छात्रा बैठी हैं, उनकी प्रतियोगिता भी है और देशों की प्रतियोगिता भी है। एक नए टैरिफ वॉर के दौर में हम लोग प्रवेश कर रहे हैं, ऐसा हमको दिख रहा है। हम उससे बचना भी चाहेंगे, लेकिन दुनिया में जो परिवर्तन होते हैं हम उससे बच नहीं पाते, हमको उसके लिए तैयार अपने आप को करना होता है। इस प्रतियोगिता के दौर में केवल सफलता की एक ही कुंजी होगी, जो हम काम कर रहे हैं, जो हम प्रोडक्ट बना रहे हैं, वो इतना अच्छा हो, इतना सस्ता हो, इतना सस्टेनेबल हो कि वो दुनिया के अच्छे से अच्छे मानक पूरा करे, जिस ग्राहक के पास में, जिस उपभोक्ता के हाथ में पहुंचे, वो संतुष्ट हो। अगर ऐसा हम करने में सफल है तो फिर कोई हमको रोक नहीं सकता, हमारी सफलता निश्चित है। और वो मैं अपने सीपेट लखनऊ में होते हुए देख रहा हूं। शेषर जी, आपको बहुत सारी शुभकामनाएं। विवेक जी, आपको भी बहुत सारी शुभकामनाएं। और मैं जल्दी पुनः आऊंगा, अपनी बात कम कहूंगा, बच्चों की बात खूब सारी सुनना चाहूंगा। खासकर जो स्कॉलरशिप विभिन्न योजनाओं के तहत मिलती हैं, वो ठीक से बच्चों को प्राप्त हो रही कि नहीं, कहीं कोई समस्या तो नहीं है, क्योंकि समाज कल्याण विभाग उसका एक महत्वपूर्ण अंश है। और भी विभाग देते हैं, पर नोडल विभाग के रूप में मेरा डिपार्टमेंट उसको देखता है। तो बहुत बड़ा परिवर्तन हम लोग आगामी वर्ष में करने भी वाले नीतिगत रूप से। लेकिन अभी कॉन्फ्रेंस पूरी हो जाए, फिर एक दिन आप अवसर दीजिए, बच्चों के साथ चर्चा हो, बच्चे बताएं। हम कौन होते हैं बच्चों को बताने वाले, तुम्हें क्या करना है, बच्चे बताएंगे हमें क्या करना है, तो बेहतर होगा। इसके लिए हम लोग काम करेंगे। और एक और क्षमा भी चाहूंगा, क्योंकि 11:30 बजे कैबिनेट की मीटिंग है। कार्यक्रम में आने का वादा कर चुका था। पहले मुझे लगा कि मुझे शायद आपसे माफ़ी मांग लेना चाहिए, लेकिन मुझे लगा कि नहीं, ऐसा ठीक नहीं होगा। शायद मैं ट्रैफिक के बीच में दौड़ के पूरा कर लूँ, तो मुझे आप लोग शुभकामनाएं देंगे कि मैं 11:30 बजे तक पहुंच जाऊं लोक भवन तक। ट्रैफिक की समस्या को क्षणिक रूप से हल करते हुए और परमानेंट हल निकालने की कामना करते हुए बहुत बहुत आभार, धन्यवाद। सभी को बहुत सारी शुभकामनाएं। आपका दिन शुभ हो, खूब अच्छी चर्चाएं आज हो।
कन्नौज की नगरी, इत्र की नगरी का प्रतिनिधित्व करते हुए आपने अत्यंत कम शब्दों में हम सभी को अपनी विद्वता से महकाया है सर, और आपके इन आशीर्वचनों के लिए बहुत बहुत धन्यवाद। और आपने जैसा कि बताया, कैबिनेट मीटिंग चल रही थी, शेड्यूल्ड है, और उसके बीच से आप समय निकाल करके आए, उसके लिए आपका बहुत बहुत धन्यवाद, बहुत बहुत आभार सर। पुनः हम आपकी प्रतीक्षा करेंगे। उनका पीएस होगा। पूर्व निर्धारित सेशन के बीच में इस कार्यक्रम को आयोजित किया गया, जिसकी वजह से हमारी तकनीकी समिति जो यहाँ है, जो ये सारा तकनीकी सेशन करा रही, टेक्निकल लेक्चर्स करा रही है, हमारे जो चेयरपर्सन हैं जो इस सेशन को करा रहे हैं, उन सबको व्यवधान उत्पन्न हुआ। उसके लिए मैं मंच से आप सभी से माफ़ी चाहता हूं और अनुरोध करता हूं कि आपका जो टेक्निकल सेशन है उसको आप कंटिन्यू करें। मैं पुनः अनुरोध करूंगा इस सेशन के चेयरमैन आदरणीय बेन सिंह सर से कि वो अपना स्थान मंच पर ग्रहण करें सर।
Our next speaker are absent, so I will take a break for 15 minutes. So enjoy a break and some refreshment. But do remember, we have more insightful discussion ahead. So kindly be back in your seat after 15 minutes to continue our session on time at 11:15 a.m. Thank you. दीदी से बात करो.
Welcome back all the dignitaries after the tea break in day 3 of APM 2025. To continue the session, let me once again welcome our chairperson of the session, Professor Joseph R. Bensing. Kindly take your chair, sir. I request our chairperson to further continue the session with an online presentation. Over to you, sir. Thank you.
Dr. Raba, hello. Hello.
Yeah, good morning.
Yeah, good
Hello.
morning, Doctor. So, welcome on behalf of CIPET team for the international conference as a keynote speaker. So, Professor Dr. Raba received his PhD in chemistry from University of Paul Sabatier in Douglas, France. He is currently a research director at the Institute of Electronics, Microelectronics and Nanotechnology, University of Lille, France. His research interests are in the area of functional material, surface chemistry, photophysics of semiconductor, metal, nanostructures with emphasis on biosensors, nanomedicine, photocatalysis and electrocatalysis. He has published many research publications, wrote 43 book chapters, and co-editor of 10 books in subject related to the nanotechnology, material chemistry, and biosensor. He has 15 patents in his area of work. Welcome, sir. Over
Thank
to you,
you.
sir. Yeah.
Thank you. Thank you so much. Okay. Would you share my talk, or I have to do it from my
Yeah, your
computer?
presentation you can share, sir. Yeah.
Because I just sent the file, so if not, yeah, I don't. Can you let me share, please? Otherwise. It's okay. You can see my talk?
Yeah, yes, sir.
It's okay?
Yeah, okay. Put it in the presentation mode.
Okay,
sir.
thank you. Yes, it is on presentation mode, yes. Good morning, everyone. First, I would like to thank the organizers for their kind invitation. So, when I go through this talk, I think I will just give you an overview of the last work we have been doing in the group regarding how to recycle polymers to make either added value materials or fuels. But first, let me just tell you exactly what I'm coming from. So, I work at this Institute of Electronics, Microelectronics and Nanotechnology. It's typically a technological platform. There are only 5 in France, and you can see here it's the north, east, west, south, east, and southwest. So the institute is about 500 people, about 200 permanent staff, and the others, of course, are PhD postdocs and visitors. So for those of you who do not know where is the institute, is just here in Lille. It's very close to Paris. It's an hour away by high-speed train, but about 30 minutes only from Brussels. It's completely the north here of France. Indeed, in the group, as has been indeed said previously, we work on functional materials, and we have 2 different applications here separated in 2 parts: bio, nanomedicine, biomedicine, and energy related materials, and particularly for CO2 photo reduction, which also I will give one of the examples how we can reuse indeed or recycle polymers to make fuels. So here just some key facts about the plastic waste. So the most important aspect is really, when you look at this, plastic alone accounts for about 3.4% of the overall global greenhouse gas emission. Not only this, but also when you look at the amount of plastic here, it will keep increasing more and more, and especially during the COVID. I mean, when people leave, we have to wear masks and lab coats and everything in the hospital. So, but it's still, I mean, there's a big need because it's cheap to produce plastic. So the overall here, it will increase, but it really steadily over the prediction over the next 2050. So, and on top of this, there's hardly only about 9% of the whole overall plastic waste is recycled. So then it's really posing problem. What you're going to do with this plastic ending up in the environment? And you can see most of the time all the plastic bags or the bottles actually from water we drink, and this will affect indeed the aquatic environments. And I will show an example just in next slide indeed how does that affect the living species. So when you look at the management overall in the whole world, and you can see typically whether it's in the developing or developed countries or underdeveloped countries, it's roughly the same. I mean, there is not much difference between these two countries in terms of recycling. It's about only 9% of the plastic is recycled, and about 22% is mismanaged. So that's really a big issue. On top of that, most of the plastic is landfill, but when you handle plastic this way, you don't know exactly what's happening in the next 40, 50 or 100 years from that, whether it's decomposed, it's leaching to the soil, and then reaching the contaminating the soil, also reaching the rivers and drinking water. So that's really problematic. But in any case, when you look at this, it's really something, there's a lot of effort, either scientifically but technologically, to handle the plastic. So that's the example I said previously about the plastic. You see this is coming from polystyrene macroplastic, and this is our actually living species, are just the rotifers, mostly used in aquaculture. Just the message you have to take, I mean, these rotifers are able, whether are from fresh or marine origin, they can actually ingest the macroplastic, and on top of that, they will make nanoplastic out of it. So what you learn from that is that indeed, if rotifers will ingest the plastic, macro and make nanoplastic, and these rotifers, at some point, they will be given to the fish larvae to grow the...
Sir, slide is not moving.
Sorry?
Slide is not moving, sir.
Now?
No.
It's not? Oh, why it's not moving? That's a question. Okay. Like this?
Now okay, sir.
Oh, it's just when I put in the, let me check then how I can, okay. And now? No?
Yeah, okay.
It's not moving?
Okay.
It moves?
Change next slide, sir.
Yes?
No, not moving. No.
Okay, so if I display in the, okay, then I just go through the, okay, I will do it like this. Okay, so, what I said here indeed, that the this small rotifers, if they can easily ingest macroplastics, and out of the macroplastic they can make nanoplastic. And this you can see clearly here from the fluorescence images, that initial macroplastic here, it ends up here in terms, you see it becomes very small nanoplastic. And Consequently, when the fish larvae is fed with these rotifers, then they will transfer the nanoplastic into the fish larvae, and the fish larvae will grow and becomes a fish. It ends up on your table one day or the other, and you end up eating indeed macroplastic or nanoplastic through just the food chain. So this is really the big issue, and indeed, given the time that now more and more countries are moving towards fish as a source of proteins because of the animal protein has become more expensive. So one day or the other, indeed, we will end up having a lot of, and we are actually requesting to eat fish. So, but potentially if nothing is done about this plastic handling, we will end up eating fish with plastic, which could be also harmful for our health. So I will just give some examples, or the main actually techniques used today for plastic waste management. As I said previously, the one which is really the mostly used and widely used over the world is the landfilling. So in terms of energy, this doesn't require any energy, just because you drill a hole and then you just fill in the with plastic. However, it have a big environmental impact, because we don't know exactly what's happening to this plastic in the next 20, 30, even more than that, because the plastic will be only slowly degraded, and then it will be released into the soil and water. And the big issue also with this, that the plastic is not any more used, so there's no added value out of this plastic. One of the most, actually I would say today, interesting aspect is this mechanical recycling. So because then what you do when you do this, you just make composite materials, and mostly are used in construction materials. So in terms of energy, it requires only low energy. It's not expensive, no environmental impact because you reuse, but there is low added value material because we use exactly the same material, you just crush it to smaller pieces. Now, typically, which one I think that, well, of course, this is the incineration. You just, this is so easy. You have this CC bond breakage here. High energy required, has a big impact on the environment because you generate CO2, which is really bad, but also no added value. But you can reuse indeed the energy generated through this technique. The techniques I will mostly focus are functional. I will not give in examples of the chemical, but mostly on functional upcycling of the polymers here. So the energy required is really slightly, I would say it's an average, it's not very high. Also for the price, no impact on the environment because we will reuse the plastic, and you have a high added value because you can generate actually materials that can be used for other applications. This is another technique, but here you need to break the CX here bond through either catalytic techniques. But in terms, it's expensive because you use typically noble or non-noble metal complexes as catalyst. It has an environmental impact because you actually move or you break the polymers into small molecules, but it has a high value added because potentially you can regenerate the monomer, then you can use it for either making a new polymer or for either as a fuel or a chemical for industry. So here, exactly the advantages and disadvantages, but this I just actually previously summarized in the previous slide, but in terms of these techniques, which are mostly chemical approaches, the chemical upcycling actually, they have advantages in terms of you generate new molecules, you have added value, but also you can easily upscale. Disadvantage of this technique is you have high input, energy, temperature, pressure. You have to use, as I said previously, transition metal or noble metal catalyst, which are expensive, or sometimes also aggressive chemicals, acids or bases, and it's low tolerant for contamination. The other technique, which is recent, which is completely new, it's probably only a few years, it's really nice because it has, you typically only deal with the surface, you only modify the surface of the plastic. So in terms of that, you just control the properties on the surface. So you don't make any decomposition of the polymer. So you don't need most of the time, any metal-based catalyst. It has a high added value and also a lower input energy because you just deal with really chemical reactions on the surface which do not require a lot of energy. Well, some of the disadvantages of this technique is that you can, especially when you do hydrolysis of the surface, you can release some of the microplastic. And sometimes also you have to use acid or bases, which are a bit aggressive. And in certain cases also you have first to start with a mechanical technique. So given that, because it's only this with the surface modification, so you can control the wetting properties. You can use then the generated material as an absorbent in construction, in catalysis, food packaging, antibacterial. So you can really make a functional material from just the surface modification, like any surface functionalization of any material known indeed. So the first example I will give you here, it's using with the PET, just polyethylene terephthalate here, it's the water bottle plastic. So what we did, you just cut this in small pieces, you hydrolyze, and when you hydrolyze this, you add zirconium tetrachloride here, and we can grow a moth directly on the plastic. Then coming just with a LED laser, easy, simple, cheap laser, and then you can write it directly and transform this moth on plastic to zirconium carbide graphene directly on the surface. And indeed, with that, you make a material which actually displays a high conductivity, good photothermal conversion, and good mechanical stability. Okay? So the how and why you can really grow moth on this plastic bottle, because when you hydrolyze the PET on the surface, you generate this terephthalic acid. And this is indeed the precursor for the moth preparation. That's the reason why indeed you can easily build or synthesize moth directly on the surface of PET upon hydrolysis. And indeed, as it is a precursor with this zirconium, it gives this moth. Okay, this is known in terms of synthesis, but that's what we did that on the surface of the PET. So we optimized the conditions for the hydrolysis to generate indeed this acid on the surface. So when we find indeed that you need about 75 degrees C, that's the temperature of hydrolysis, for 5 minutes, that's where you have the highest amount of acid groups on the surface. And then indeed, what we did then we add this zirconium tetrachloride, and we were able to generate the moth directly on the PET substrate. We looked at the different characterization. It's amorphous forcingly, but what's interesting is that indeed in the FTIR, you can see here that there is an absorption here of the PET with the moth. The reason it's important for us because we use a LED laser which absorbs about 400, so it's important that the material absorbs in this range to be able to transform the moth PET to zirconium carbide graphene. Okay? So this is just indeed, we looked at the zirconium on the surface, and we can find indeed in the morphology, you can see there are small particles on the surface, which means indeed confirming the formation of the moth on the surface. This could be also easily here confirmed through XPS analysis. You see the appearance here of zirconium, which is indicative indeed of the formation of the moth on the surface. Afterwards, I would not go through the different optimizations we have done through this LED laser. We just exposed the moth PET surface here to the LED. It's a very small LED laser actually. At 404 nanometers, if you remember well, because we need absorption, and here it's about exactly where we have a small absorption of the moth PET here. That's the reason we use this LED laser. And then indeed, we can see, we can transform something which is almost here, this surface, to, which is almost transparent, to something which is completely dark here. It means that formation of graphene and zirconium carbide. So we had indeed about here, this is the thickness of the PET MOF. It's about 6 micron, but after laser writing, directly laser irradiation, we have like a layer of about 145 micrometers generated directly on the surface. Interestingly, now you have something which is black. It means it absorbs from the UV to the infrared. Importantly, you can use this as a photothermal material, because you can see when you irradiate this with a laser, you can heat up to 75, depending on indeed of the laser you use. They're all LED lasers, of course, but you see the most effective one is the one at 660. It's somewhere here. You can reach nanometers. And why is that important? Because indeed photothermal materials, they can be used for many and various applications in biomedicine or in energy or environment related fields. Mechanically, this is very stable. You can mix it with the sand and then for 24 hours here, and you can see the morphology, there's nothing changing. The same with the conductivity or the sheet resistance before and after the test. This is very conducting, so you can use it for here lighting power light emitting diodes. So you can see from a plastic which is completely inert, you can make a conducting material you can use here for lighting diodes. Okay. The next example, I think I have 5 minutes. It's okay. Example I will go is just now instead of PET, we used polyethylene. Of course, this is known examples for more than 10 years. What you can do here, if you have a CO2 laser, you can directly write graphene on this polyethylene. Then with spin-coated PDMS, you peel off, and then you remove this actually graphene generated on the polymer, and you make a flexible devices very easily because it's PDMS. You can see here, you can twist it in different direction and the way you want it, and it's really very nice and easy. These are just the characterization, of course, to show that the graphene type, because you have this the D and the G band in the Raman spectrum, but also you have the carbon typical sp2 carbon, which means what you have generated, it's indeed this graphene-like material. Then we applied a gel, just to have a gel electrolyte, and we made a supercapacitor, very nice. It's all solid state supercapacitor, which has a really good stability up to 6,000 cycles here, and also mechanically it's very stable. You can bend it for about 1,000 cycles without losing any of the energy or real capacitance. Then we put this in series, and with if we have these two micro supercapacitors in series, we can power here a small calculator, and we can operate that for about, I think, I can't remember, 30 seconds or 20 seconds. So you can see again here from just a material, you can make a flexible energy storage device. Last example, and here it's electrochemistry, how we can recycle this PET and make a fuel out of it. So you know certainly an electrolyzer, it's water electrolysis, you generate hydrogen here, and you generate oxygen at the anode. So what we did now, we hydrolyzed, I will show you how we did this. What we wanted, if we can, combine CO2 reduction at the cathode to generate formic acid, and a precursor here coming from plastic hydrolysis, which gives ethylene glycol and oxidize that to formic acid. Then you have an electrolyzer cell that can generate formic acid at the cathode and the anode. And the cathode, you use a CO2, which is a pollutant. And on the anode also, you hydrolyze the PET to ethylene glycol, also which is a plastic waste, you generate another fuel. So it's really, in this case, you don't need to separate, you don't need any distillation because you have one fuel. And formic acid, of course, you can use it for fuel cells or as a chemical. So I will not go why it's really important industrial application of formic acid, but we can talk indeed if you have any questions about that. So we made indeed this bulk RGO as a cathode, and copper cobalt oxide RGO at the anode material. And then what you do, you just hydrolyze chemically, an acidic hydrolysis of PET, you generate this terephthalic acid and ethylene glycol. Terephthalic acid is not actually electrochemically active under our conditions. So what you do, you just oxidize ethylene glycol to formic acid. So this is the overall reaction. You reduce CO2 at the cathode, you oxidize the ethylene glycol at the anode, and you generate 5 equivalent molecules of formic acid as the overall reaction. So this is just, I would go a little bit faster on this because I'm a bit late. I have 1 more minute. This is how we made this material. It's a bismuth phosphate we transform on bismuth carbonate. And what you can see, this is the CO2 reduction, and you can have really something which is really stable about 22 hours with the formic, with the Faraday efficiency almost approaching 100% here. It's above 97% for the CO2 reduction. This is then the copper cobalt we used for ethylene glycol oxidation. This is the characterization. And again, you can see indeed that you have a Faraday efficiency, which is above 80% at 1.5 volt here. And what you can see also on this, which is really important, if I use the same catalyst to generate either oxygen or to oxidize ethylene glycol, I gain in terms of energy. So not only I transform plastic to, or ethylene glycol to formic acid, but also I gain here in terms of energy. So you really double gain in terms of energy, but also of using two waste, CO2 reduction and ethylene glycol coming from plastic waste hydrolysis. So yes, when you make then a full cell here, you can really generate the formic acid both really at the anode and the cathode with overall Faraday efficiency, which is about, I think if you look here, you sum up between 150 or 160% at both, if you sum up the anode and the cathode. To confirm this, we have used indeed an NMR spectroscopy. Here you can see before electrolysis and after this is hydrolysis. What you see here is the A, which corresponds to ethylene glycol, and the TPA here is the acid coming from the hydrolysis of the PET plastic. But what's important here just to follow this at about this ethylene glycol about 3.5 here ppm. So when we do the electrolysis, indeed you can see with the carbon-13 the formation here of formic acid, which confirms indeed that during the electrolysis what you generate only formic acid. But sometimes indeed if you keep this, you can have an over-oxidation from some of the carbonate, which coming actually from the over-oxidation of formic acid. With this, I think I just want to make a very short conclusion, especially for when you use plastic for making functional materials or added value materials. You have to be sure that the functional materials has to have at least a higher added value than the parent material. Otherwise, there is no point to recycle something to make a material which actually has a lower added value material. It doesn't make any sense. Also, is it possible to recycle the upcycled material? Because otherwise, then you stop. The ideal, indeed, to cycle, generate, to cycle, to recycle, either for infinite. Otherwise, indeed, at some point, it will be a balance whether it's really worth or not of recycling. It has to be cost effective. You have to limit, indeed, the polymer leaching during functionalization. Also limit aggressive chemicals and develop, indeed, mild functionalization schemes. With this, thank you for your attention. If you have any questions, I would be really happy to address or to respond to that. Thank you for your attention.
So anybody want to ask any question? Anyway, no question. Thank you, Dr. Raba.
Thank you.
So for the wonderful session. Thank you so much on behalf of team APM 2025. Okay. Thank you. Our next speaker, Sri Nishant Joshi, IAM Ahmedabad. So he is going to talk financial strategies for sustainable growth in the petrochemical sector, advancing Viksit Bharat 2047. Welcome, sir. So, Nishant Joshi is a finance and accounting professional with over 13 years of experience in finance, accounting and auditing. Currently, he is working as an internal auditor at Indian Institute of Management, Ahmedabad, where he oversees financial compliance, risk assessment, internal control. He holds MBA in finance and a postgraduate diploma in human resource. Additionally, he has completed specialized certification in forensic accounting and fraud examination from West Virginia University, enhancing his expertise in fraud detection and financial investigation. So, he is an ex-CIPETian. I welcome you, sir. Over to you.
So first of all, I would like to tell you about two things. There are two things in this. That is, the one thing is about the sustainability, and other thing is about the Viksit Bharat. The government's target for the Viksit Bharat is 2047. But I think there is one lapse I am seeing in the policy making, so that I want to tell you about. Everyone is talking about our GDP, that how much GDP we will achieve, 5 trillion, 10 trillion. But no one is talking about the per capita income. What will be the per capita income? For example, this bottle is 10 rupees. If we increase the price for 10 to 20, automatically this will increase our GDP. But whether this will increase the per capita income of this population? So first thing in the Viksit Bharat, government should encourage to increase the per capita income of the population. This is very necessary. The milestone can be achieved by 10, 15, whatever the trillion, whatever we want to achieve, it can be achieved. But if really we are not improving our low income group people to middle income group, or middle income group to high income group, then the Viksit Bharat achievement is only will be on the paper but not on the actual things. So now I am talking about the petrochemical things. So petrochemical thing is the backbone of our economy, because it is a very high intensive project. So it will generate a good amount of GDP, and it will generate a good amount of employment also. And the petrochemical sector are not only it is related to the Praklis, because I have seen in the so many APMs that only technical things are given importance in this type of conferences, but not the non-technical type of things. Because in the cricket, if we hire all the batsmen, then we cannot win the match. We need batsmen also, bowler also, and all-rounder also. So this time, just in the previous APM, I told sir that you should include the other field also, not only the technical session, but little bit non-technical session also. So this time he told that yes, I will include the non-technical session, and then again we will include more and more field in this. So I would like to thank Professor sir that he has initiated this thing. Now, what are the financial challenges are there? First of all, it is a very high capital incentive things. We have to invest very much capital, because the lots of big machineries are required. So many raw materials type of things is required. Another thing is that there is a strict regulatory compliance and cost. We have seen that government is giving so many ESG reporting now, doing the mandatory for the companies. For that ESG reporting, they have to prepare so many reports. They have to incur so many costs. So we should tell to government that the compliances should be not stricter, it should be relaxed. Then and then only the industrialists will take initiative to do any innovative things. Third is the market volatility in the crude oil pricing. We have seen the Russia-Ukraine war. Because of the Jai Kishan ji and the PM Modi sir's diplomacy, yes, we got the good less amount of crude oil and from the Russia, but otherwise it has impacted lots of economy in the Europe also, in the USA also. So the market volatility, another is a very big financial challenge, and the third is the challenges in ROI. As I told that it is very high capital incentive projects, the ROI is very far, that is after 5 years, 6 years, 10 years. So this is one of the very big challenge. Now what will be the solution for this? Green bond and sustainable financing. As of now, green bond are only for the big players, not for the retail investors. So we have to do such policy that retail investor also can take part in the green bonds. Because of this green bond only, you can achieve your target of Viksit Bharat or your net zero emissions. The second one is PPP model, public-private partnership. In everywhere, we are now government is implementing the PPP model, because central government has very not big resources. So private player has to take part in this process. The third is government incentive and tax benefits. Here I want to tell that government has implemented the PLI scheme, but PLI scheme is not very much implemented in the petrochemical sector. As right now government is implemented in the semiconductor sector, the government should implement the PLI scheme to the petrochemical sector also. And some subsidy should be go for the raw materials also. The next is about the digital transformation. Digital transformation, I would like to think that there should be the AI driven analytics should be there. For example, in the I was just doing the research for this, the Saudi Aramco has a AI driven predictive analysis. So that type of AI predictive analysis should be there, so we can reduce the volatility, and the investor can see the what will be the supply and demand with the help of the AI. The next is the circular economy waste reduction. It's so many speakers have talked about this technical part, so I would not go into deep in this. Now technological advances that I have told you about, the AI driven predictive analysis. Another one is the blockchain supply chain management. Government is investing in this type of thing. Still it will take some time, but it has to be done very quickly. The Dow Chemicals outside, you can take the case analysis of Dow Chemicals. They are using this blockchain supply management. So because of that, they have saved millions of dollars for them. So I would urge that industrialists should do some investment in this blockchain analysis also. Another one is renewable feedstock technology, that is the bio-based material, and the automation and smart manufacturing. So it will reduce the human errors, productivity, and saving cost. Now what will be the role of policy of government? I told you about the ESG compliance and sustainability report. Tax incentive for green investments. If you are investing in the green bonds, there should be some tax incentive, because we have some sort of mentality of such taxpayers. If we are doing some tax benefits to the taxpayer, so they will do their investment in the green bonds and green investments. So automatically this will increase your investment in the green things. Another one is the global collaboration. For example, Indian partners with global organizations like UNIDO, that is United Nations Industrial Development Organization for Green Projects, and the R&D things, that is investment in biodegradable plastics, low emission refineries, and alternative feedstocks. For example, ONGC right now, he has invested in ONGC Green. NTPC also had started the NTPC Green. We have seen the IPOs of NTPC Green right now. ONGC Green is also coming with the IPO. So government is slowly starting in the green initiative, but it will take, if we are going with this pace, then we will be left behind. Government has to do a lot more investment in this, so we can achieve our target very easily. Global knowledge action partner, financial literacy for industry stakeholder, enhancing renewable feedstock infrastructure, and scaling up investment. Now here the Reliance net zero refineries aim to revolutionize the petrochemical sector. The future of the petrochemical industry is like scaling up for green investments and developing infrastructure for renewable feedstocks. So companies must allocate a larger portion of their budgets to sustainable projects and innovative solutions that aim with global environment goals. Financial literacy program for industrial stakeholders, including executives and policymakers, will help in better risk assessment and strategic decision making. And global collaboration with developed nations can offer valuable insight and access to advanced technology, improving India's competitive edge in the sustainable petrochemical market. So, a strong regulatory framework coupled with financial incentives will drive long-term sustainability in economic growth. In the conclusion, I would like to tell you one thing about that. The petrochemical industry must adopt the financial strategies which that ensure both sustainability and profitability. Because if we are going only for the sustainability and if we are ignoring the profitability, this will also not work. It should be both parallel. It should be with sustainability but with the profitability. In the closing statement, I want to say that a financial sustainable petrochemical sector will drive India's self-reliance and global leadership in the green manufacturing. So, sustainable financial strategy are not just optional but necessary for the petrochemical sectors. So, thank you so much. This is just a glimpse. I will prepare a full detailed research paper on this and that I will produce to the professor, sir. Thank you so much. Thank you.
Miss Open, anybody want to ask? Please, sir.
I want to ask only one question.
Yes, sir.
Can you give a specific example for AI-driven predictive analysis?
That I have told you.
Technological advancements.
No, that I have told you that Saudi Aramco has applied. It is a case analysis available on the Google. How they applied the AI-driven predictive analysis. Because of this AI-driven predictive analysis, they have saved millions in the downtime cost, whatever right now incurring with the industrialists. They have saved millions of rupees.
How is better than patent analysis?
Which analysis?
How is better than patent analysis? Patent.
Part analysis is part analysis. Yeah. PERT, no, you are saying part analysis.
Patent is the patent.
Patents analysis. No, AI-driven analysis is much more better than the patent analysis in the technology, sir.
Can you give one example?
That is what I am telling you, sir. The AI-driven analysis gives the exact thing in the supply and demand, what will be the supply and what will be demand. It is not available in that much accuracy in the patent analysis, which is in the AI predictive analysis. The paper is there available. When I will make the full paper, I will give to you. But paper is available, it is there, sir, on that topic.
Okay, thank you, Nish.
Yes.
Your second slide.
Yeah.
You said the crude oil is a volatility.
Yes, sir.
But in India, we are mostly going to alternate fuel also.
Yes, sir.
It is self-dependent on maybe CNG based.
True.
Other, and upcoming is the hydrogen cell, which will come later on in the India.
True.
So the Viksit Bharat is not only depending on the crude oil, so that is the means government is focusing more on that also. That's I wanted to add here.
Yeah. We have seen the biofuels are available right now, but more than 20% we cannot add in the petrol. So it is the limit up to 20% only. More if we want to add more biofuels in the engine, then we have to change the all diesel engines and all other things. And we have seen in the President Trump has also withdrawn from himself from the Paris Accord. He is the main financing country and he is withdrawn from the Paris Accord right now. It will impact the other economies also, sir. So crude oil, in 5 to 10 years, we cannot remove the crude oil from our things, sir. We have to go with the crude oil also a little bit, sir.
But the latest thing is happened. Now ethanol contribution is recently, the last week news is that it's increasing and the composition of ethanol is government is putting in this crude oil little differently. So as you said, the Viksit Bharat by 2047, it's depends, but not on the crude oil itself.
True, sir.
Yeah.
True.
Thank you.
Sure.
Thank you, sir.
So thank you for the very unique presentation.
Thank you.
So I just have a small query. Like, can you comment on the status of the current this carbon credit trading scheme? Like, how far it has been, taken up in the government, and what exactly, how big a role it is going to play in the future, this whole objective of Viksit Bharat thing?
It will play a bigger role because we have seen the Europe countries have imposed carbon tax on most of the countries. So this, because of this taxation, our products is getting a little bit high. It will come, sir. Actually I don't know what is the exact status of the cardiac tradition, what are the training, but it will come soon in our country, and most of the training programs already started, even in our IIM also, in IITs also it is started. In IIM, sir, the executive of the IOCL, executive of the different petrochemicals companies are coming, so our professors are teaching them. So it is going, sir. The pace is slow, it is admitting the pace is slow, but it will definitely go fast.
Thank you so much, sir. Now I would request our chairperson to kindly present him a memento as a token of appreciation. Kindly give him a huge round of applause. Thank you so much, sir. So valuable words.
Thank you, sir. Thank you.
Internal auditor from IIM Ahmedabad. Thank you so much, sir.
With this, our keynote lecture sections also ended. So now we are move on to the invited lectures. So our first lecture is going to give Dr. Sandhana Krishnan from CSIR ANAL, National Aerospace Laboratory, Bangalore. So Sandhana Krishnan is a polymer chemist with a doctorate degree in polymer chemistry. He has expertise in development of different variant of polymer precursors for high functional carbon and silicon carbide fibers. He has been involved in the process development activities of several grades of carbon fibers for the first 20 years with his present employer. So that he has also developed analytical methodologies for characterization of carbon fibers and their precursors in all stages of carbon fiber manufacture. His current interests include polymer-driven silicon carbide fibers. So over to you, sir.
Thank you, Dr. Ben Singh, for your kind introduction of mine. Good afternoon. First of all, I thank the organizers of APM 2025 for their kind invitation and present my work in this August platform. Basically, this work is a continuation of my previous presentation in APM 2023 and APM 2024. So those who have come to that my presentation in those conferences can be easily follow this work also. My topic of presentation is on solvent fractionation and purification of carbosilane mixers obtained in an extended pyrolysis polycondensation process. Basically, these polycarbosilanes are ceramic polymer precursors. They are a very rare kind of polymers which is commonly not available for import in this country. So there is a huge restriction on import of this material from the developed nations like Japan and United States of America. So 5 years back, with the funding from Department of Science and Technology, we initiated this program. So we have grown to the level of technology TRL level 6. So with this introduction, I will go into the presentation. Please, next slide. Yeah, this is the outline of the presentation, but most of us may not be knowing about this polymer, so I will give an introduction. Second, why this polymer is required, what are the applications in extreme thermal environments, then how they are useful in the fabrication of ceramic matrix composites, then we will come to the precursor synthesis process, then how I purify this polycarbosilane into the highest purified form, because this material is very highly expensive. A kilogram of this material costs around 3.5 lakhs to 4 lakhs. So it has to be given very purest form, as well as that this material will be used in high-end applications like gas turbine engines and aircrafts. So naturally it has to meet very strict requirements in the aerospace industry. So we have to develop the very perfect methods of delivering it in the purified form. So next we will go through the effects of selective solvent fractionations of this polymer material, effect of selective solvent fractionation of polymer in different solvent pair. So what are organosilicon polymers as ceramic precursors? Maybe most of you may be heard of this material, but anyway I will, it is my duty to tell what are the salient features of this material. This is high molecular, low rate and weight loss on heating. High portion of cages and rings in the polymeric structure. Viscoelastic properties are tunable to corresponding process method. Mostly ceramic polymers are very brittle in nature. So you cannot make ceramic materials into microfilaments or filaments with diameter less than 10 microns. So they are very fragile. With the feather touch, they will break. Their tensile strength is almost 10 MPa. It is like your son papdi. Like if you touch this material, break. So how to make this fiber? It's a wonderful challenge. Only 2 countries in the world has mastered this. Only United States of America and Japan. Mostly 80% of the products comes from Japan, which they don't even give 1 kg of this fiber to India. So we are putting our all efforts to realize this dream. So these are some of the structures of polysilanes, polycarbosilanes, polysilacenes and polyporosilacenes. These are collectively called as ceramic polymers. So where we endure, when we are having this aircraft brake discs, they require this material as a resin matrix. This is required in a large amount of quantity. So this is where the current requirement in India. So we are, to meet the requirement, we are into this process. So where we meet the extreme thermal environments in aeronautics and space. For example, if you are traveling from Sydney to Dallas, this travel time includes more than 20 hours of continuous travel. So this is a long haul flight where the engines will be subjected to surface temperature of more than 800 and 1200 degrees Celsius, where carbon-carbon composites cannot withstand such temperatures, where we need this polycarbosilane derived silicon carbide fiber reinforced with polycarbosilane matrix. So using such materials, we can prepare the nose cones of space engines as well as the critical components in gas turbine engines, where hot section needs almost realizes almost 1200 degrees Celsius. So these are the other several products that can be realized based on carbosilane based materials. So coming to the synthesis process, this technology is mostly controlled by Japanese based companies, especially the persons who are responsible for the development of this technology, Makoto Kumada, Seiji Ejima and Gerhard Fritz, then currently Ishikawa. These are the key persons, only these 3-4 people only know this technology. So over and above, so the yield of the process is very low. So when yield of the process is low, naturally the cost of the process becomes very high. So the technology, as progress in technology is happening over period to improve the yield from 20% to 80%. Currently in CSIR NAL we are getting the yield up to 70%. So this is the overall process. So here you take the precursor material, that itself is another polymer called polydimethylsilane. So we pyrolyze it, take the pyrolyzed vapor into a column reactor where we do some catalyst assisted polycondensation and recover the polymer in 3 forms: solid polycarbosilane, liquid polycarbosilane and another polycarbosilane material. So 3 forms. This is the overall picture what it happens. This is a pictorial representation of the polycondensation process taking place in the high pressure reactor, where we are employing the temperature from 400 to 540 degrees Celsius, pressure to 20 atmosphere to almost 75 atmospheres. Reaction time is almost 3 hours to 8 hours. This reaction is conducted under the atmosphere of 100% argon. So you can get, depending upon the process condition, you can get in the liquid form as well as in the solid form. So these are the products you can get in the liquid form depending upon manipulation of the reaction conditions. So this we get So you know that 1 Dalton is equal to 1 gram per mole. So basically carboxylanes are oligomers. So converting a oligomer into a polymer is a very challenging task, where we have improved the number average molecular weight from 750 to greater than 350 number average molecular weight. So this is these are the different forms of solid state polycarbonylene obtained through the manipulation of the reactor processing conditions. So this is a purified form of polydimethylsilane and polycarbonylene. This is readily usable into usable as ceramic matrix resins. Okay, this is the infiltration. How to infiltrate, that's a liquid form where it can be directly infiltrated into these various carbon preforms or ceramic fiber preforms. So this is the actual structure of the polycarbonylene. So the polycarbonylene are characterized by the presence of silicon hydrogen direct bonding. So this is the FTIR spectrum of oligomeric and polymeric carboxylane, where you can see the silane functionality around 2100. This is a very specific character of polycarboxylanes. So as I told, no, since it is very expensive and it requires to meet the stringent conditions of aerospace applications, we have to purify it to the highest possible level. Because in the synthesis of polydimethylsilane, we use large amount of sodium and potassium. So there's a trace amount also, it is very dangerous because sodium is prone to fire. So we have to remove all those. Even in the ppm levels, it will create problems in the composite fabrication. So we have to purify. So to purify the polycarbonylene, we have used a 3 set of solvent pairs. One is hexane and methanol, and hexane and acetone, and hexane and ethyl acetate. So we have a special apparatus like that. Using that, we have precipitated, selectively fractionated the polycarbonylene into several fractions varying in molecular weight. So first we fractionated, then from the fractions we extracted the liquid phase, then filter it, then dry it, then we get the different polycarbonylene fractions. Okay, what is the effect of fractionation on the polymer structure? So here you can see that the before fractionation and after fractionation in different solvents. So absolutely there is no basic structural change after fractionation. So the peak at silicon and hydrogen is intact. In fact, because of the fractionation, the strength of the peak corresponding to silane at 2100 has improved a lot. So this is a proton NMR spectra which complements the results from FTIR. You can see the silane around 4.3 to 4.45 ppm. Chemical shift, this is from proton NMR spectral data. So again, these molecular weight details are mostly obtained from Mark-Wein's equations. So using that we can measure the reduced viscosity. The reduced viscosity of the polymer solution is directly related to the structure. So as we fractionate, this is a polymer, synthesized polymer from the reactor. So after the fractionation, the molecular weight has increased. You can see from the curves or the straight lines corresponding to PCSB and PCSC, which are much more than which have higher reduced viscosity than the original synthesized polycarbonylene. So this is so after this fractionation, how the molecular weight has improved. Many of us might have done this gel permeation chromatography technique, where see here you can see that the evolution curves of synthesized polycarbonylene, you have the bimodal peaks, right? Here you see that there is a 2 peaks are appearing, one at 7.6 minute and another one at 8.32 minute under one particular conditions. If you go to another reaction condition, same very prominently bimodal peaks appears, one at 7.32 minute and one at 8.31 minute. This very clearly states that you have got a 2 kind of polymeric molecules that should be separated into 2. So after fractionation, so you see the graph. So it has become unimodal. And accordingly, the retention time has decreased, meaning that molecular weight has increased. So, in gel permeation chromatography, bigger molecules elute first, then the small molecules. So, accordingly, you can see the shift from 8.86 to 7.75 minutes. So, this I have just a comparative chart, how the fractionated versus the asynthesized polymer. You can see that the overall curve with the 2 average peaks 7.32 to 8.3 and become 7.8. So, this is a very clear indication that polymer has been purified. So, we checked the purification with some other techniques like EDAX method and melting curves. Melting curves normally shows that melting point is from 200 to 206 degrees Celsius for all polymers. Similarly, the sodium chloride levels almost nil in all the fractionated polymers, confirming that the polymer is almost purified. So, this is the ceramic yields, because this mostly polycarbosilanes are called as ceramic precursor polymer. You can see that after purification of the polymer, the material loses only 30% of the weight, overall weight, saying that the 70% of the mass remains with the original material. So, it shows very high ceramic yield. So, similarly, the DSC curve also you can see the low molecular weight polycarbosilane shows onset temperature at 136.62 and onset at 180 with peak temperature of 140 degrees Celsius. If you go to purified polycarbosilane at 5 degrees Celsius per minute, this is under argon atmosphere. You can see that the curve is, melting curve start around 280, saying that the polymer has got the higher molecular weight. So, these are my summaries and conclusions. Selective solvent fractionation method of purification and segregation of unsynthesized polycarbosilane through an extended pyrolysis have been performed successfully using several solvent pairs. The effect of fractionation using several solvent pairs on the molecular weight distribution, melting point, class transition temperature, thermal decomposition and chemical structure of carbosilane were investigated. And FTR and NMR data says that due to fractionation, there is no structural change or modification in the basic structure of carbosilane. And also, we have confirmed that because of the purification, average molecular weight of the polycarbosilane has increased. So, thermal data indicated that the ceramic yield of asynthesized polymer was more than the fractionated carbosilane. So, we have also done some rheological studies. So, considering the time available, I will not include those things. So, these are our overall summary and conclusion, and these are some of the publications in this. For past 5 years, we have got so many publications, and I think that is the technology is available for commercialization. If anybody is really interested, you can contact our director CSR renewal, Dr. Vasilkar. You can communicate with them. Any question?
So anybody want to see? Yeah. Here.
Sir, very nice presentation. I have like one question where why can't we synthesize the polycarbosilane of more than 10,000 molecules? What is the challenges associated?
Yeah, this forming silicon carbide bond, no? It is very, in polyolefins, no? C double bond C, this you can easily make that free radical polymerization and build a high molecular weight polyolefins. But whereas in this case, this is silicon and carbon. Establishing silicon and carbon bonding requires more energy to break the bond and make it in a chain form. That's it.
Okay, thank you.
So how are the solvent pairs selected? And is there a way to rationally?
Yeah, exactly. It's a very good question. You know that solubility parameter?
Right.
So hexane is a good solvent for polycarbosilane. So how to say carbosilane, polycarbosilane, and this is a very, these kind of data are not at all available in the open literature. So you have to choose a particular solvent and non-solvent pair with respect to the polymer. Suppose a polymer has a solubility parameter of X value, the X value should be close to the solubility parameter of the solvent. Then it is considered as a good solvent. Okay?
So maybe there is a way to like rationally do it as well. Like as in, you know, you ask the program that, hey, what will be the best solvent pair for it, rather than sort of choosing it manually.
That's what I am telling. No, suppose you say how do you say polyolefin or polystyrene is highly soluble in xylene? How do you say that? You know solubility parameter. The solubility parameter value. Say suppose xylene has a solubility parameter of 235. So it should match with the solubility parameter of polystyrene. So it should be close to that, not exactly same. Maybe it is 220 or 260. So that way you can select it. Okay.
So thank you, sir.
Thank you.
On behalf of organizing team, small memento.
Yes, thank you.
Thank you so much, sir. Beautiful words, insightful session, and a lot of knowledge you shared with all of us, sir. Thank you so much for your presence. Thank you, sir.
Thank you.
So before we conclude this session, I would like to thank our chairperson, sir, that you conducted this session, and I would request Dr. Goyal, CIPET Ahmedabad, to present a memento to the chairperson. Let's experience some energy from CIPET students at least. You all have tea break, you are going to have a lunch. At least have a good round of applause. Thank you so much, sir. So all the speakers are requested to go to Principal Director's office to share their feedback about the conference. And now we will be having a lunch break for 20 minutes, and we will be joining back for the further session. Thank you. the chairperson of this session. Kindly address him and welcome him with a round of applause. Dear students, kindly take your chair, sir. And I would request Dr. Sushant to kindly welcome him with the badge. Dr. S.V.R. Shastri has more than 20 years of teaching and research experience. He is B.Tech Gold Medalist from NIT Jalandhar, M.Tech Silver Medalist from IIT Delhi, and got Best PhD Thesis Award from JNTU Kakinada. He has authored 12 patents, 22 international books in the area of renewable energy, unit operations and heat transfer. He has published more than 64 papers and presented papers in more than 60 international conferences. He has also been awarded the Outstanding Reviewer status by Elsevier US. Also, he is an editor of 5 international journals, and presently he is working as an Associate Dean, Research and Development at HBTU Kanpur. With such esteemed profile, I welcome you to the dais, sir, and to further conduct the session, it's over to you, sir.
Thank you, madam. So, welcome once again to the post-lunch session. So, our first invited speaker is Dr. Saeed Asgar Hussein Rizvi. He is working as subject in charge and assistant professor at the Department of Mechanical Engineering, Khwaja Moinuddin Chishti Language University, Uttar Pradesh Government University, Lucknow. He obtained his B.Tech in Mechanical Engineering from Uttar Pradesh Technical University, Lucknow in 2011. M.Tech in Manufacturing Science and Technology from Bundelkhand University, Jhansi in 2014, and his PhD in Mechanical Engineering from Integral University, Lucknow in 2021. His PhD dissertation topic was Studies on Performance Improvement of Electro-Discharging Machining of AISA 4340 using copper tungsten electrode. He has more than 10 years of experience in the field of academics, a member of Institution of Engineers, and has been recognized as a Chartered Engineer, Mechanical Engineering from IE. He has written several books and book chapters in the field of mechanical engineering. His research area is advanced manufacturing processes. He has published around 38 research papers in various SCI, Scopus and UGC Care Index journals. He has published 2 patents on facial recognition based artificial intelligence and AI based health monitoring car seat. He has also been awarded the Best Faculty of Mechatronics at the World Education Congress 2023. So now over to you, Dr. Saeed Hussein Rizvi, for your invited talk.
Thank you, sir, for your welcome. Hello, one and all present in the hall. I am Dr. Saeed Asgar Hussain Rizvi, and I am working as an assistant professor in KMC Language University, Lucknow, as sir has introduced me. And the topic for today's lecture is subsurface damage and migration of material post electro-discharge machining. Next slide. Pointer.
This for forward, this for previous, and this is for laser pointer.
Okay. Looking at the content of my lecture, it will be the basic introduction of the topic, and further it will discuss the principle of machining through spark erosion, and we will also discuss the assessment of the residual stress that is developed during machining on EDM, and we will discuss the micro cracks that are developed during EDM. Further, we will also assess the effect of the residual stresses on subsurface and on subsurface damage, and finally we will see the migration of the material from both the electrodes. All of you are from the mechanical or related field, na? So I can communicate well. EDM, as you know, is a advanced manufacturing process. It is a non-traditional machining processes that is used in industries nowadays, and it has been used from near about 2-3 decades, and the research is getting intense day by day. And we know that in this process the machining is obtained by removal of material through the sparks that is transferred from the anode to the cathode. And there are many things that we see while machining on EDM. It generally requires a medium to transmit the spark from anode to the cathode, and we use dielectric fluid to transfer the spark, and the spark strike the surface of the workpiece and the workpiece is dislodged, and the flush of the dielectric removes the debris from the gap between the workpiece and the tool. This is the basic principle of EDM. You can see here, this is the electrode and this is the workpiece. These are the sparks, and we flow the dielectric for better transfer of the spark from the electrode to the workpiece. This is an image during my experiment. You can see the sparks. This was the arrangement. This is the tool, this is the workpiece. This is the clamp on which the workpiece was held. This is the tool holder. I was talking about the migration of the material that we will discuss later on. First, I would like to show the transfer of the ions during the process of EDM. Tool transfers the negative ions towards the workpiece, and workpiece transfers the positive ions towards the electrode during the process of machining on EDM. Furthermore, when we are machining on EDM, as soon as the tool tries to insert into the workpiece after machining a little bit, it also transfers the spark on the walls of the hole or the part it is machining. So the hole also get oversized during EDM. The radial overcut or the oversized hole was measured using scanning electron microscopy, and these were the images obtained. The linear measurement technique was used to measure the size of the hole. Later on, we have also assessed the white layer that was deposited after the solidification post machining, and there was also a heat affected zone due to the thermal influence of the spark. It was also calculated by the scanning electron microscopy, SEM. You can see the extent of white layer deposition on the surface of the material is shown here. Like the white layer is deposited on the workpiece, there is a black layer that is deposited on the surface of the tool that hinders the transfer of spark onto the surface of the workpiece. You can see a deposited black layer that is shown here, black layer deposited on the tool surface during the machining process on EDM. This is due to the thermal decomposition. These were the specimens that we have taken. AISI 4340 was used, EN24 as the workpiece, and copper tungsten was used as a tool. The EDM parameters that were selected for the study were peak current, pulse on time, voltage and pulse duty factor, and their ranges are like this, and these range were selected by initially conducting initial set of experiments so that we can decide the range of experiments, and we have also gone through various literatures to see that under which limit the better machining is obtained. This is the composition of material AISI 4340. The residual stress was assessed using XRD machine, and X-ray diffraction was used. This is Malvern Pan-Analytical XRD machine that was available at BSIP. This is basically the procedure through which we assess the residual stress that is developed in the workpiece post machining. Basically, it depends upon the Bragg's law. You all know Bragg's law? You all know Bragg's law, no? The students behind, I'm delivering a lecture, are you interacting with me or not? Are you getting what I am telling? आप लोग को पहुंच रहा है जो मैं बता रहा हूं? Are you getting what I am telling? No. Actually, you know EDM, electro discharge machining. हाँ? तो EDM में post machining there are some residual stresses that are developed, that are रह जाते हैं, and we have to assess those residual stresses. So we assess या calculate them using Bragg's law. This diffraction is calculated by XRD and the lattice displacement is calculated by XRD. Each lattice displacement is compared with the unmachined surface and we calculate the strain using this method. The strain will be ds minus du upon du, where ds is the stressed lattice spacing and du is the unstressed lattice spacing. जो हमारा वर्कपीस पोस्ट मशीनिंग जो मशीन होने के बाद उसमें जो लैटिस का डिस्प्लेसमेंट आया दैट विल बी ds एंड एक सैंपल वी विल टेक वन सैंपल that is unmachined and we will calculate the lattice displacement of that sample and that will be du, and we will calculate the strain by this formula ds minus du upon du. After getting the strain we can calculate the residual stress by this formula. You know this residual stress is equals to E into epsilon upon mu, where mu is the Poisson's ratio, epsilon is the strain and E is the elastic modulus, and the material that we are using as workpiece is AISI 4340 and it has elastic modulus of 196 GPa and the Poisson's ratio for AISI 4340 is 0.3. So we will solve the equation and we will calculate the residual stress for all the specimen that we have machined. You can also see the graphs that we have obtained through XRD machine. These are the graphs. This is for the unmachined surface and this is for the machined surface. You can easily see that the D spacing, the diffraction value for unmachined is this and for the machined surface is that 2.02304. So we will compare these values that is obtained by XRD and we will formulate or find the value of residual stress developed in the machined surface. Here I am showing the SEM machine and the EDS machine on which we have taken the micrographs of at microscopic level. As I have told you, there are several micro cracks that are developed on the surface of machined AISI 4340. You can see here there are voids, there are cracks and there are voids. Small, this is crack free surface. This surface has wider cracks. Further you can see there are more wider cracks, there are small voids. These are the type of surface that we obtain after machining on EDM when the stress level is high. This is caused only due to the internal residual stress which breaks the surface and develops the crack. It is not going backwards. Here is the description of what the images are showing. It is saying that using the scanning electron microscopy we have assessed the micro cracks that are developed on the EDM surface, and the development of the internal tension generated during the machining is the primary factor that results in the cracks formation on the surface. And furthermore, a significant emphasis on crack intimation is also placed on the spark discharge energy. The discharge energy also is also considered as an important factor for the crack formation. And the thermal tension that are formed during the work machining are the basic cause for resulting the cracks on the surface, and wider cracks are resulted when we have chosen higher level of pulse on duration. These are the graphs that are showing the relation of machine parameters that we have earlier chosen as current, pulse on time, voltage and duty factor with the residual stress that is developed in the machine surface. You can see that with current, when we are increasing the level of current, the residual stress is decreasing, and with pulse on time it is also decreasing, but with voltage the residual stress is increasing, and duty factor does not have a much influence or impact over the residual stress. I have already shown you these SEM images showing the voids and the cracks. A wider cracks are observed at higher level of pulse on time. This is also a SEM image of 2K magnification, 2000 times magnification. You can see the crater here and you can see the cracks. Okay. Larger cracks are seen here. This slide shows the effect of residual stress on subsurface damage, and here it is saying that the development of the internal stresses generated during machining is the primary factor contributing the formation of cracks. That means the residual stress that is developed in the surface generally results in crack formation, and crack appearance depend upon the EDM setting and the parameter that we are considering for machining. And furthermore, a significant emphasis of crack intimation was due to the discharge energy, and the thermal stresses have caused the micro cracks, and the machine surface opens as a result of residual stresses due to uneven temperature distribution. Due to uneven temperature distribution, the surface open wide and the cracks are formed. These are the EDS image. Now we are showing the deposition of the tool material over the workpiece. You know that we have used tungsten copper as the tool, and the workpiece material was AISI 4340. उसमें क्या क्या था 4340 में? We have iron, we have silicon, we have magnesium, we have silicon. So you can see here downwards, silicon, copper, chromium, oxygen and iron, carbon and electron. Where does the copper have deposited on the work surface? कहाँ से आ गया? It was due to the transfer of the negative ions from the tool. उसके साथ साथ it was carried away with the negative ions and it impinges on the surface of the workpiece. Here in the EDS image you can see, the presence of copper on the surface of the workpiece. This is the EDS image. Similarly, जो हमारा cylindrical tool था, the cylindrical tool was also put under the scan and scanning electron microscopy, and uski image में भी we have seen that it was silicon, iron, oxygen, copper, tungsten, carbon. You can see these are the materials. We only have copper and tungsten as the major constituent of the tool, but you can see silicon, iron, oxygen, these are also present on the surface of the tool. From where? From the positive ions that are striking back on the surface of the tool. And oxygen is due to the oxidation that is carried out, that is developed at higher temperature. You can also see a black layer that I was earlier talking about that was deposited on the surface of the tool. This is the black layer, and this is due to the presence of carbon. You can see here the carbon is present, and this black layer is formed due to the carbon. Okay. So here we can see the migration of the material between the electrodes from the tool to the workpiece and from the workpiece towards the tool. You can see that the EDS spectroscopy reports that the migration of the element of the work superficially and vice versa. दोनों में they interchange the material during the process of EDM, and high discharge energy resulted due to elevated temperature make the electron element loosen. At high temperature, the elements get loosened and they get transferred with the ions, and the migration is caused by the positive and the negative ion upon the respective surface. The impact of these ions will impinge the element of the opposite electrode. As we have seen in the EDS images, only copper was reported to be catabalt. We have copper and tungsten both in the tool, but only copper was noticed to be transferred from the tool surface to the workpiece, which was later discovered to impinge on the superficial layer of the work. During the material removal process, we have seen that iron and silicon have migrated from the workpiece towards the tool. The presence of oxygen was due to oxidation at elevated temperature, and among the electrical parameters, the duty factor was governing the relocation of the material. Thank you. Thank you. Any questions? Any questions from the audience? I think no questions. Thank you, sir. Thank you.
Okay. Thank you, Dr. Said, for your wonderful lecture. So on behalf of the organizers, we request you to please come over for felicitation.
Thank you so much, sir. It was beautiful, insightful presentation. Thank you for your valuable words and coming across here in CIPET Lucknow, attending this international conference. Thank you so much, Chairman, sir.
So the next speaker is Dr. Sunil Kumar, if he is available online.
So one of our speaker will be joining online, and rest few speakers, Professor Dave, Dr. Nikhil Prakash, and are requested to kindly provide their presentation to the technical team. Thank you.
Yes. So let me introduce our next speaker, Dr. Sunil Kumar. He is a principal scientist, scientist E2, and associate professor at CSIR National Metallurgical Laboratory, Jamshedpur. He holds PhD in chemical engineering from IIT Delhi and specializes in molecular dynamics simulation, density functional theory, simulation, and phase field simulations. His previous roles include senior scientist E1 and assistant professor and as scientist C at CSIR NML Jamshedpur. Additionally, he worked as a postdoctoral researcher in the physics department at Indian Institute of Science, Bangalore. He has also published several research papers in international journals. So with this introduction, I hand over the session to Dr. Sunil Kumar. Please continue, sir. Sir, you can unmute yourself. We are not able to hear you. Please unmute. Yes.
Yes. Am I audible?
Yes, you're audible.
Okay. Thank you for introduction. Please share my presentation if possible. My slides is visible?
Yes, visible, visible.
This is front slide. Is it okay? Hello. 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 Title of my presentation is a domestic simulation for the water-induced iron corrosion and prevention mechanism. So, in this work, we will discuss about importance of corrosion prevention in steel objectives, results and conclusions. In result, we will discuss about atomistic simulations like molecular dynamic simulation, DFT simulations, and how to choose various kinds of corrosion inhibitors for the iron. So, corrosion of steel is a significant issue across various industries, including construction, transportation, infrastructures, and manufacturing. Preventing corrosion is crucial for several reasons, like structural integrity, safety. And structural integrity means corrosion weaken the steel structures, leading to potential failure in bridges, building, pipeline, and industrial equipment. It has various economic impact also. Corrosion leads to high maintenance and repair costs, significantly increasing the life cycles cost of steel structures, and environmental productions, energy efficiency and resource conservation, industrial and technological advancements. Our these are selected objectives for our work: the computational design of efficient corrosion inhibitors for mild steels, understanding the corrosion prevention mechanism of steels. So during atomistic simulation, we have employed reactive molecular dynamics simulations and density functional theory simulations. In reactive molecular dynamics simulation, we have to provide initial position vectors. Position vectors means positions of atoms like x, y, z coordinates and their velocities. And after positions, we have to calculate various kinds of interaction potentials like van der Waal, Coulombic interactions, angle informations, torsion informations, and many other things. And after calculation of forces, we have to calculate their positions, their new positions, and we have to carry out multiple steps of energy minimizations. And during energy minimization, we have to record their path, and then we can do we can bring out multiple kinds of conclusions and trajectories. And during position, am I audible?
Yes, you are audible.
Hello?
Please, yes, you are audible. Please continue.
My slide is moving or not?
It's moving. We are in slide number 5 now.
Okay, thank you. During reactive molecular dynamics, we have to monitor how atoms is moving, and governing equations for the movement of atom is a Newton's equation of motion, which consists of velocity Verlet algorithm, Nosy-Hoover thermostat to control temperature and pressures, and reflective boundary condition we have applied. So for this simulation, we have used large-scale atomistic simulators like LAMPS, and for the visualization, we have used Ovito softwares. And in density functional theory simulation, we have carried out very small number of calculations in this works. So we don't want to explain most of this thing. However, we have used quantum expressor softwares and Derive software as a visualization tools. So in our work, we have considered multiple simulation systems. In first simulation system, we have considered iron atoms. Iron means only Fe, and water molecules. We have placed water molecules over iron slab and applied a electric field. And in next simulation system, we have initially placed iron and applied a corrosion inhibitor coating over that. And in third simulation system, we have placed water molecules over the coated iron surface. So we will discuss in detail about system first. So before simulation, we have prepared a system consisting of iron and water. And during simulation, equilibration simulation, it is observed that water molecules physically adsorb on the iron surface in the very early phase of simulations, and the large difference in this is due to a large difference between atomic charges and energy between the water molecules and iron atoms causes many water molecules to be dissociated. So during dissociation, water molecules forming bond with the iron or iron and it forming multiple kinds of ions like H plus, OH minus, H3, O plus ions at the interface, initiating the corrosion process on the ions. And other byproduct H and O diffuses into the bulk, and a few H2 molecules are also observed. So we can see that at interface uh, we can find out, we can visualize that large number of iron compounds. This is a very complex reactions type reactions and various kind of product is forming. So along with the visualization, we have found that how number of bonds increases. So red color bond is a FEH, red color lines is FEH, and blue color lines this is a FEO. So we can see a large number of bonds forming, which indicating that there is various kinds of Fe2O3, FeO, and various complex compound is forming at interface. So, and during reaction, we can see that how atomic charge is changing at the interface. We can see that black color is the atomic charge of the iron, and green color is the charge on the hydrogen atoms, and red is the charge on the oxygen atoms. So we can see that during reaction, during corrosion, the atomic charge at interface of the iron atom is increases slightly, and this is coming out from the hydrogens. So we can see then just some overlapping region at the interface. So we can see that most of the charge contribution from the hydrogen is happening at the interface. So, and further we can see some this is a formation of a coating, a corrosion layer over this is iron surface and inner layer and diffusion layer. So here is a very this is a color coating of the different atoms in the surface. At the bottom we can see some light yellow is the positive charge of the iron, and at interface is mixed colors. And next is a selection criteria of efficient corrosion inhibitors. So for the selection of the corrosion inhibitor, we have used density function theory. In density function theory, HOMO-LUMO basically used for the selection of the chemical compound for the coating on the iron surface. The HOMO-LUMO calculation is providing information related to electron distribution in the molecular orbital, which affect reactivity and their effectiveness as inhibitors. A higher HOMO indicates stronger electron donation, and lower LUMO means better electron acceptance. So delta E, energy gap is delta G. Higher values of delta E implies low reactivity with metals, and lower values of delta E leads to higher reactivity and good absorption over the surface. So for the effective corrosion inhibitor, we should have higher HOMO and lower LUMO and lower delta E. So on this basis, we have selected multiple kinds of corrosion inhibitors. Also we have used Mulliken population analysis. In Mulliken population analysis, the provides insight into the electron density distribution within the molecules. Atoms with higher Mulliken populations are typically more electron rich, and while those with lower population are more electron deficient. So using Mulliken analysis, we can identify which atomic site is most probability to react with the iron. So we will discuss in later how Mulliken populations is applied using the corrosion inhibitors. So using DFT simulation, we have selected some corrosion inhibitors like anthracene, anthron, xanthone. So using DFT we have calculated HOMO, LUMO, and we found that xanthone molecule have lowest delta. So we assume that this is a very effective. This will be very effective corrosion inhibitors. So using reactive molecular dynamic simulation, we have verified these data. So from reactive molecular dynamic simulation, we have created a system in which iron. We have taken an iron system and placed some xanthone molecules over there, and during simulations we have found that xanthone make a coating over the iron surface, and in which we can see that some sulfur atoms, sulfur atom is a yellow color, and red color is oxygen atoms, and blue color is the carbon atoms. So we can see that yellow color atom is sulfur, which is reacting with the iron surface, iron atoms. We can see that here we can see that multiple sulfur atoms forming bonds with the iron. So in this snapshots, first we have placed water molecules over xanthone coated iron surface. During simulations, we can see that water molecules absorbing over the coated iron surface, and also we can see that xanthone coating significantly protecting the iron from the corrosion, means water unable to penetrate the coating, and forming a strong layer over that. So this is a effect of different kinds of coatings over the iron surface. So first is anthracene coatings, and anthrone coating, xanthene, xanthone, and xanthone. So here we can see some oxygen molecules is penetrating within the iron surface, but in case of xanthone, no any oxygen able to go inside the iron surface. So this is some magnified image at the interface. This is a coating of the anthracene molecules. So we can see some gap inside the during gap between the coating. So we can see that some water molecules going inside the iron surface and forming some iron oxide. So we can see that anthracene is not a good corrosion inhibitor. So yes, we can see that here this is a arrow showing that the iron water molecules penetrating inside the iron surface through gap within the coating. This is coating of anthrone molecules. Here we can see some effective way to some water molecules also penetrating inside the iron surface through gap in the coating, and this is a coating of the xanthone molecules. So here we can see that no any external oxygen atoms or water molecules atom able to go inside the iron surface. Some oxygen atom reacted with the iron. This is oxygen coming from the xanthone molecules, but this is a very effective xanthone molecules. And simultaneously for the quantitative analysis, we have calculated number of FeO bonds. FeO bond means oxygen coming from the water. So we can see that Fe without coating showing large number of FeO bonds, which indicating that corroded iron corrosion. This is a maximum corrosion without coating. However, xanthone molecule is showing a very less number of FeO bond, which is indicating that xanthone is successfully preventing the iron from the corrosion. And other molecules like xanthene, xanthone, anthracene, which is effective, but compared to xanthone is very less.
Dr.
So
Sunil,
this is
may
a
we
number of,
request, Dr. Sunil, may we request you to wind up in 3
yeah.
minutes, 3 more minutes? 3 minutes.
Yes, yes, sure.
Thank you.
Sure, sure. Uh, the next figure is FES, number of formation of number of hydrogen bonds. So we can see that Fe code without coating shows large number of FES bond, which is indicating high corrosion in the metal surface. But a xanthion coated is showing very less FES, means that is indicating that xanthion molecule is able to protect the iron surface. Also, radial distribution function is indicating that xanthion coated Fe shows the very small peak, which small first peak. It is indicating that iron is without corroded, and large peak is showing that iron is fully corroded. So xanthion is able to protect iron from the waters. So this is a water reactions. This is a further we have calculated what is the reason behind the corrosion process. So we have calculated potential energy of each atom in xanthion coated iron surface. So some yellow color atom, this is a sulfur, this is yellow color dot is depicting the sulfur atom of inhibitor molecules. So we can see that sulfur potential energy of iron and sulfur is overlapping, which is indicating that potential energy of the system minimizes through the corrosion inhibitors. That means here we can see that corrosion inhibitor layer, means xanthion layer, is reducing most of the system energy, which is that means which is able to protect the reaction between water and oxygen. So here we is confirming that xanthion molecule is a good inhibitors, and also sulfur atom of xanthion is playing a major role. And this is a molecular population analysis in which we can see that large variations in molecular population analysis, MGAP, which is some charge fluctuations, large fluctuations in charge indicating their reaction with the iron atoms. So also here we can see that oxygen atoms of the xanthion have large fluctuation, which leads to reaction with the iron. And so similar thing, however, anthracene molecules don't have any heteroatoms like sulfur, oxygen. So here mechanism of corrosion inhibitor is something different. Okay, so because here is a triple carbon ring and without any heteroatom, so here interaction of anthracene with iron is a directly van der Waals interaction. Van der Waals means graphene means benzene ring of anthracene directly absorb over the iron surface without any chemical bonding. And during reactive simulation, we have observed that how electron density is interacting with the iron surface. We can see that some pi interactions here, and this is from the reactive simulations. And further, we have carried out large number of experiments from our team members. So for the experiment, we have used potential states to electrochemical test. So for the anthron coating, we can see that some enhancement of the corrosion protections. So in this case, we have considered 100 ppm is showing improvement than blanks, and 50 ppm, 500 ppm as well as within, and 80 to 85% efficiency. And this is some weight loss experiment. So here we can see the anthron is also supporting for the prevention of corrosion coating. And further, we have carried out large number of salt spray testing. So we can see that anthracene is also supporting for the prevention of the iron corrosions. So conclusion is that reactive molecular dynamic simulation carried out to observe the corrosion mechanism of mild steel in presence of water. Formation of iron oxide, iron hydride, and other minor compound deposited at mild steel surface. Xanthium molecule is found to be good corrosion inhibitors. Selection criteria for efficient model established using TFT simulations. And thank you.
Thank you, Dr. Sunil, for your wonderful presentation. We wait for the audience for any queries or questions. Any questions from the audience? Okay, so it was an interesting presentation, therefore audience didn't have any question. All of them heard everything very nicely. Thank you very much, sir, for being there with us as invited speaker. So this ends the invited talks in this session. So we have contributory presentations. So the next contributory presentation is by Dr. Pranav Chaudhary from HBTU Kanpur. He will be speaking on generative AI-driven polymer innovation, trends, challenges, and future perspectives. Over to you, Dr. Pranav. Dr. Pranav, you can please unmute yourself and share your presentation. So we'll be waiting for a few minutes. He'll be logging in again.
Yeah, sorry for the technical issue. I think there was some issue in the, because this session is being recorded. So there was some permission which was required to, it is still showing, because it is being recorded, I'm not able to share it through this, okay, entire screen opens. Sorry, I'm very sorry because of this device. Is there any other person waiting in the queue? That person can start because there is some technical issues coming up in my system.
So actually, you are the last speaker.
Okay, so then in that case, I might have to log in through my mobile. Let me just say this is saying something. The Google Chrome would like to record this computer audio. If I'll say deny, sorry. Grant access to this application privacy, and this has never come. Let me try with the Google this Safari. Just a minute. Sorry.
Dr. Pranav, hello. Dr. Pranav, if you are facing any issues, if you can kindly send a presentation you can share with them, the organizers, and they will put it from here.
I think, yeah, this is allowing me to share a screen, share entire screen. Yeah. Now I think this will be visible. Is it visible?
Yes, visible. Go ahead.
Okay. I use presenter. Is it visible in a slide mode or in presenter view?
it is in the slide mode. Full screen is not coming.
So let me start. Thanks and sorry for the technical issues. The title of the talk is Generative Artificial Intelligence Driven Polymer Innovation, Trends, Challenges and Future Perspective. I am Dr. Prav Chaudhary, Assistant Professor at HBTU Kanpur in Department of Chemical Engineering. So let's start my presentation I want to illustrate the evolution of the research paradigms in material science, emphasizing the key milestones. It all started with the experimental driven paradigms. As you can see that the Madame Curie won the Nobel Prize for the discovery of radium and polonium, and that she had done through experiments, through trial and error. The next paradigm happened, that was theory-driven paradigm. That was the direct equations which describe the existence of positron and quantum spin Hall effects. Then the computational driven paradigm happened, as the last presenter was discussing about the molecular dynamics, and then he has found out a new polymer structure in the coating which helped the corrosion. So that was all computational driven paradigm, and obviously we have to do the experimental validation. But to find out that material, the computational driven, the DFT calculations, all those helped a lot. So that was the third paradigm. And now recently the fourth paradigm has come, that is the AI driven paradigm that showcase the recent breakthroughs in the artificial intelligence, including the AlphaFold, GPT-4, AI accelerated material discovery, signaling the frontier in the research in this field. So with this introduction, I want to discuss that how the modeling was helping to accelerate, the existing modeling was helping the finding out new molecules. So what we were doing some modeling, and in that we were able to find out if the structure looks like this and its process for formation is might like this. Then we go for the simulation and we check the properties, and then it says that yes, it's worth making. Then we do the experiments, we make it, and then we have to characterize it, find out whether that has been that properties has obtained or not. So the inner circle represents the existing scenarios, but then when the information is being accumulated, why can't it be used for use it in the artificial intelligence, use that information which is being generated through those experiments, through those molecular simulations. So there using the information, here it comes the artificial intelligence. So as we can also look at as what we were doing till now, that we were trying to screen good molecules. This represents the molecular fitness in terms of some property, let's say high glass transition temperature, high tensile strength, or whatever the property is there. This represents that if the molecule, the property gives at the higher fitness, we select it. So this is the way, the usual way of screening the molecules, that if the molecule fitness is high, we select it. So this is what we were doing. Can we do the inverse design, where we can find out the proper molecules for the required properties? So that is where the generative AI comes into picture, directly designing the molecules based on the property. This is an inverse design. So to discuss that, we have to discuss that the generative models, how does it work? So it actually generates the structure from scratch, but still before generating the structure from scratch, we have to make it learn to the existing knowledge. Once it learns, then only it will be able to generate new structures. I want to give one example of that, like in generating the very good, like Avatar movie, everyone might have seen. And to make the Avatar 2, James Cameron has to go for 10 years to let the technology evolve, so that whatever his imagination was there in his mind would be made possible in the video generation. But now with the AI generation, because we can generate images and videos from scratch, all those things which were being done on a very high computational computer, now it can be done at a very, very cheap cost. So it is on the similar pattern, we can also remove the cost in doing the experiment, molecular simulations, and use the generative AI. So that is the inspiration. And how do we do that? So thing is that we have to make the neural network understand the structure. How do we convert the structure into to the language of our neural network? The easiest way is the SMILES token, that is known as Simplified Molecular Input Line Entry System. This is how we convert that complex molecular structure into some tokens, into some text. Because as these transformer models, the GPT 1, 2, 3, they are able to understand the text input. So we also have to convert the molecular structure into text. So that is done by SMILES token. And the graphs, for graphs also there are different form of SMILES token that has been designed, and in 3D structure also point clouds are being made. So what are there are many different methods through which we can design the molecule from scratch. So the main three categories are variational autoencoders that are known as VAEs, then generative adversarial networks, GANs, then the transformer models. This is very recent. The first two are the outcome of the deep learning. The next version of the deep learning, that is a neural network. But the third one is the transformer model, which is the very, very recent one. That is, transformer means the GPT. T comes for the transformer based model. And then there are diffusion based model. The inspiration of all these models have actually come from image generation. So these models were being used for image generation. Now they are being used for molecules generation. So let's start with the first one, that is variational autoencoders. It actually, this is the first step to understand. This is just a neural network. It cannot do the generation, but it can classify. We can give the code, the SMILES code of that polymer. It can understand it through its neural network, and this is known as latent space, where it can understand in its own terms, in the deep learning, the neural network terms. And that type of deep learning were being used in classifying or regression, that whether this molecule is good or bad. That is the first step. Now the second step of this deep neural network is generating new molecules from the latent space. So this has the generation part. This is in fact the structure of an autoencoder. This actually first converts the SMILES code or code of the molecule compound into a latent space, and then the latent space again generate the molecule, the same molecule. But the first stage is to train this neural network. We train this neural network, the weights and bias of this neural network through supervised learning. We give some molecular structure, we check whether the output is getting the same structure or not, and in that process we give millions of molecular structures, and in that process it gets trained. Once it gets trained, then the next stage is to generate new structure. But this is just replicating. How do we make it to generate new structures? We create some noise through sigma and probability distribution in the latent space. So we create some noise in the latent space, and then again we try to make it this whole neural network very robust to this noise. And once this network gets trained to that noise also, now it can easily find out the new molecular structure in vicinity to the already trained structure, and that we can do it within the latent space. Okay, so just to show it with an example, this is one of the example that this is the structure which has been proposed by molecular simulation, MD simulation, and then it has been coded through the token was generated, and then it was through ANN and graph neural network. So this is the latent space. This is just a representation. This is not how it looks, but this is just a representation in the latent space that this molecule comes here, this molecule comes here, this molecule comes here. So this is how it we can visualize that there's a latent space, and then from there we are training it whether it is generating the same image or not. Through that, the latent space has been created. Now, from latent space, we check the fitness, as I had discussed in the third or fourth slide, that we want to reverse engineering. So we create the fitness level at the latent space, and then we try to find out the closer points to the vicinity of the existing structures, and from there we generate that the decoder, the next part comes into picture, and then that generate the new polymer, and then we do the validation through either MD or through experiments. And this is one of the actual example which has been done on MD this variational VAEs, variational autoencoders. The applications are, some of the applications are to design.
Dr. Pranav, please, may we request you to wind up in 2 minutes, please? 2 more minutes.
Okay. Yeah.
Thank you.
Sure. So this is just an example that how the research is going on to generate new molecules from scratch for high temperature polymer design. And people have done with the identified candidate were shown that the temperature were more than 300, glass transition temperature was more than 300 degrees Celsius. Similarly, in the biodegradable polymers, in conductive polymers, the people have done using the VAEs, we can generate new molecules, and these are all very recent papers. And the next is the GAN, which I'll skip. This is another neural network based method to generate new molecules. Now this also has some actual examples of designing drug delivery hydrogels, then gas separation membranes, and self-healing elastomers. And the result has shown that in all these cases, the actual molecules which has been generated from this GAN method were able to perform quite well. And these also we can see very recent papers. And this is the transformer based model. This is the recent one, the most recent one. This is the GPT type, the transformer based model. It actually does the embedding through the query key and value matrix, and this is a very it needs quite a lot of time to make you understand, but in short, it is just a transformer based model. It needs a lot of computation power and as well as training also, but then it has very easy. We can ask these type of models that this is what we want, and we don't have to talk to it in technical words. Any layman, if it is trained properly, then any layman, any user can ask that this is the property we are looking for, and this can generate. So this is the future which is going to come, and some of the examples have been like real life example has been shown that sequence control copolymers have been generated, then recycled thermosets have been generated, and these have shown quite a good results. These are all 2023 research papers. So this is a new paradigm which is at a very nascent stage. And then I have worked on the strength and what they are best for, then their challenges, the research gaps, and what are the solutions. The solution is that for data scarcity, how we can standardize the polymer database through high throughput experimental for consistent data. So the biggest issue is the data scarcity in this. So we have to convert the existing information in the form which can be used for training transformer-based models. And the synthetic feasibility and representation challenges, all these are challenges, and there are solutions also. And as to conclude this whole presentation, we can say that generative AI is going to revolutionize the polymer science, and not only polymer science, every field of life, and accelerating new discoveries, design advanced materials. It enables tailored design for sustainable, high performance and specialized polymer applications. Current challenges are there, which includes data quality, ensuring chemical realism, because it also hallucinates, and bridging the computational experimental validation gap. So that is also a very important thing. Then overcoming these barriers requires enhanced data set, interdisciplinary collaborations, because it has the power of emergence. Means the research which has been done in different area can easily be, that inspiration can easily be taken and to implement it in different field. That is the power of this transformer based models. So interdisciplinary collaboration is very much required, and improve the interpretability of the AI models. Whatever it gives, that interpretability is also a very important thing. And future progress is generative AI driven polymer innovation holds promise for addressing the global sustainability, material and technological challenges. So this is the generative AI is going to solve, and this is just very, very starting phase of this field. As we have seen that molecular dynamics has started it around 1980s, and now it is in like very advanced stage. So this is at a very nascent stage where we can create new molecules from scratch based on our requirement. So that is the power. That is the power it has. Thanks.
Thank you, Dr. Pranav, for your excellent presentation. So we just wait for any questions from the audience. Any questions? So one question from me, because we had to evaluate. So how this generative AI-driven system can be used in the field of polymers and plastics?
Yeah. See, actually, the whole idea has been taken. It has started from the image generation, and now that is also that there are two stages in the artificial intelligence also. One is the deep neural network, the neural network. For that, it has been already proven that the generative models, which are the neural network based, are able to produce molecules of required structures. But the transformer models, which are a much more advanced models, that is going to help the people in much more easier way, because it can, anyone can, like we can talk to a GPT and it can generate the code. Similarly, if we want that this type of molecule we want, it will create that molecule. So the actual implemented things have also been done, and that I had shown that for 3 or 4 applications that has generated new molecules. These are very at very recent stage, and the molecules which it has been produced were actually showing those properties. But the only thing is that the cost, computational cost, and the data scarcity, because that to train that model, people have used specific data from that field. So that is, the data scarcity is very important challenge.
Thank you. Wonderful. Dr. Pranav, thank you very much once again for your excellent presentation. So we'll just wait for any other questions from the audience? Okay. Thank you. Thank you very much. So here we come to an end to this session, post-lunch session in Hall 1 of the auditorium. So thank you very much to the organizers for giving this opportunity. So we conclude the session here. Thank you.
Sir, before we conclude this session, I would like to request Dr. Sushant, so kindly give him a memento as a token of appreciation. Thank you so much, dear Chairperson, sir, for holding the session beautifully. So dear all academicians, dignitaries and participants, as we are reaching towards the end of this technical session of day 3 in hall 1, as we all have experienced these 3 beautiful days, and it has been a beautiful journey where we got to hear from luminous academicians from international universities like Michigan University of State, Lille University of France, many national institutions of national importance like IITs, IIM, NIT, CSIR, chief scientist from CSIR, and many more luminous stars of academic world. So it has been a beautiful journey in 3 days in APM 2025. I thank all the delegates from industry, all the people from academic world, all the professors, and all the participants who made this session possible. Although we are closing technical session in hall 1, but in simultaneous halls, presentation is going on, so you can join there. For having more of the APM 2025. But do not forget to join us at 4 o'clock for the valedictory session here in auditorium, where the best posters and best papers will be announced. So I am Prachi Shrivastava, faculty of CIPET Lucknow, has been with you last 3 days. Hope we could made this session important and valuable and memorable for all of us. So we'll see you at 4 o'clock. Looking forward for your presence. Thank you, everyone.
पीपीटी चौदह मार्च 2024 में अहमदाबाद में जब हमारी 15वीं APM हुई थी, तब एक बीड़ा वहाँ से सीपेट लखनऊ ने उठाया कि वर्ष 2025 में APM कराने की जो जिम्मेदारी है वो सीपेट लखनऊ निभाएगा। एक वर्ष का समय का चक्र उल्टी गिनती के साथ प्रारंभ हुआ, कहानी महीनों में आई, उसके बाद सप्ताहों में आ गई, उसके बाद दिनों में आ गई, घंटों में आ गई और अंततोगत्वा दिनांक 8 मार्च को हमने अपनी इस अंतर्राष्ट्रीय सम्मेलन का गरिमामय तरीके से आगाज किया था। 2 पूर्ण दिवसों में हमारे बीच जितने भी विद्वजन आए, विभिन्न राष्ट्रीय अंतर्राष्ट्रीय संस्थानों से एमिनेंट प्रोफेसर्स थे, रिसर्च स्कॉलर्स थे, परम सम्माननीय, परम भूषण, परम पद्मश्री से अलंकृत हस्तियां हमारे बीच उपस्थित हुईं, जिन्होंने अपने अनुभव हम सभी से साझा किए। आज तीसरे दिन भी हमारा जो पहला सेशन था वो पूरे तरीके से समर्पित था। हमारे पास नंबर ऑफ स्पीकर्स ज़्यादा थे, जिसके चलते हमने सेशन प्रीपोन किया था, तब जाकर के हम अपने यथा समय में समापन समारोह प्रारंभ करने की स्थिति में पहुंचे हैं। आज के समापन समारोह में अत्यंत हर्ष के साथ मैं आप सभी को सूचित करना चाहता हूं कि आज हमारा यह समापन समारोह आदरणीय श्री अवनीश कुमार अवस्थी जी, जो कि वर्तमान में माननीय मुख्यमंत्री उत्तर प्रदेश के मुख्य सलाहकार हैं, के मुख्य आतिथ्य में संपन्न होने जा रहा है। जोरदार तालियों से मैं चाहूंगा कि आप उनका अभिनंदन करें। आदरणीय अवस्थी साहब का जन्म 1962 में हुआ था। आपने 1985 में इलेक्ट्रिकल इंजीनियरिंग में IIT से अपना बीटेक किया था और 1987 से आप भारतीय प्रशासनिक सेवा में शामिल हुए और वर्ष 2022 तक आपने सतत अपनी सेवाएं देश के राष्ट्र के विकास में समर्पित करी हैं और अपनी सेवानिवृत्ति के उपरांत ज़्यादा सक्रिय तरीके से प्रदेश की उन्नति में योगदान दे रहे हैं। माननीय मुख्यमंत्री आदरणीय योगी आदित्यनाथ जी के साथ आप मुख्य सलाहकार की भूमिका में हैं। हमारे लिए अत्यंत गर्व का विषय है कि ऐसी विशिष्ट हस्ती हमारे बीच उपस्थित हैं। एक और बड़ा सुनहरा अवसर है कि आप की जो श्रीमती हैं, आपकी जो बेटर हाफ हैं, जिन्हें हम सभी इस प्रदेश की नहीं अपितु पूरे देश की और विश्व में जिनका नाम विख्यात है, उत्तर प्रदेश के फोक सिंगर के रूप में परम पद्मश्री से अलंकृत सम्माननीय श्रीमती मालिनी अवस्थी जी हैं। मैं चाहूंगा कि उनके सम्मान में भी आप सभी लोग जोरदार तालियां बजाएं। इस प्रकार हमारे बीच जो हैं आदरणीय अवस्थी सर उपस्थित हुए हैं, अपना कीमती समय लेकर के हमारे बीच उपस्थित हैं। हम सभी के प्रेरणा स्रोत, मार्गदर्शक, जिनके बारे में हम रोज चर्चा करते हैं, लेकिन नित नया एक सोपान हमारे सामने होता है। उनसे जब भी चर्चा करो तो कुछ ना कुछ सीखने को मिलता है। पैटर्न की भूमिका में रहते हुए जहां जहां हम फिसले, हमें लगा कि शायद गिर जाएंगे, लेकिन आपने थाम करके आगे बढ़ाया और जैसे तैसे हम लोगों ने अंततोगत्वा इस APM के एक शानदार आयोजन को पूर्ण किया है। मैं चाहूंगा हमारे जो आज के दूसरे अतिथि, तो मुझे कहना उचित नहीं लगता है, हमारे मार्गदर्शक, हमारे वरिष्ठ आदरणीय प्रोफेसर शिशिर सिन्हा साहब महानिदेशक सीपेट आज मंच पर उपस्थित होंगे समापन समारोह में। चाहूंगा कि जोरदार तालियों से दोनों अतिथिद्वय का अभिनंदन करें और सीपेट लखनऊ के संयुक्त निदेशक मिस्टर विवेक कुमार से मैं अनुरोध करूंगा कि आप अतिथिद्वय को मंच में लेकर के आएं। जैसा कि हम सभी जानते हैं कि हमारे बीच अतिथि आए या हमारे वरिष्ठ आए तो हम उनका सम्मान करते हैं हमारी परंपरा के अनुसार। वास्तव में वो सम्मान जब हम करते हैं तो हम स्वयं को भी गौरवान्वित महसूस करते हैं। मैं अनुरोध करूंगा आदरणीय प्रोफेसर शिशिर सिन्हा साहब से कि वे हमारे आज के मुख्य अतिथि श्री अवनीश कुमार अवस्थी सर का हमारे पारंपरिक पटके से और पुष्पगुच्छ से अभिनंदन करें। बहुत बहुत शुक्रिया सर। मैं अनुरोध करूंगा श्री विवेक कुमार जी से, संयुक्त निदेशक एवं प्रमुख सीपेट लखनऊ, कि आप आदरणीय प्रोफेसर शिशिर सिन्हा साहब महानिदेशक सीपेट का पारंपरिक पटके एवं पुष्पगुच्छ से सम्मान करें। बहुत धन्यवाद सर। आप सभी जैसा विगत 3 दिवस से हम लोग चर्चा करते आ रहे हैं, कई महीनों में हमारी यह 16वीं एपीएम जो एपीएम रही है ये ऐतिहासिक रही है। 16 वर्षों के इतिहास में कभी भी इतने पेपर्स एक साथ नहीं आए हैं। छोटी सी जानकारी मैं आपके समक्ष प्रस्तुत कर रहा हूं कि लगभग 267 कॉन्ट्रीब्यूटरी पेपर्स हमारे पास आए थे, जिनमें से स्क्रूटनी करने के बाद 198 पेपर जो हैं उनको स्वीकार किया गया था, जिसमें पोस्टर 135 थे और ओरल प्रेजेंटेशन 64 थे। इसके अलावा 92 हमारे पास स्पीकर्स थे, जिसमें प्लेनरी सेशन हमारे 13 स्पीकर्स के थे, कीनोट में हमारे पास 11 स्पीकर्स थे, इनवाइटेड टॉक्स में 68 हमारे पास स्पीकर थे। इस तरह से ये एक एग्जॉस्टिव एंड वन ऑफ द लार्जेस्ट गैदरिंग ऑफ एमिनेंट पर्सनालिटीज था। निश्चित तौर पे ये हमारी जो तकनीकी समिति बनी थी इस कार्य के लिए, उनके अथक प्रयासों और परिश्रम का ये परिणाम था कि रात में 2-2 बजे तक बैठ करके भी करेक्शन कराया गया, स्क्रूटनी की गई और अंततोगत्वा हम शुभारंभ के दिन उस प्रोसीडिंग्स का विमोचन करने के काबिल हुए थे। मैं और समय न लेते हुए आदरणीय प्रोफेसर शिशिर सिन्हा साहब को आमंत्रित करता हूं कि वे आज के समापन समारोह में हम सभी को संबोधित करें और 3 दिवसीय हमारी जो ये अंतर्राष्ट्रीय सम्मेलन रहा है इसका क्या आउटकम रहा है, इसके बारे में उनके जो अनुभव है वो हम सभी से साझा करें। सर।
नमस्ते आदरणीय अवनीश अवस्थी सर, समस्त गणमान्य अतिथि यहाँ पर, छात्र। जब भी एक हम लोगों ने जैसा बताया कि 14 मार्च 2024 को एक यात्रा लखनऊ सीपेट के लिए शुरू हुई थी, जो अब अपने पड़ाव में, अंतिम पड़ाव नहीं कहना चाहूँगा क्योंकि इसके बहुत सारे आउटकम हैं, बहुत सारी ऐसी चीज़ें हैं जो चीज़ें संभवतः हम लोगों को एक लंबे पथ पर ले जाएंगी, जो कि अभी सर के साथ भी चर्चा हो रही थी। और समय समय पर जो भी आगंतुक या जो भी हमारे गणमान्य अतिथिगण आए थे यहाँ पर, जिन्होंने इस महासम्मेलन में, सम्मेलन नहीं महासम्मेलन में प्रतिभाग किया, तो उनसे चर्चा हुई। तो ये आज जो इस एपीएम का जो अंतिम जो
सेशन है उसमें कुछ चीज़ें सर मैं आपके साथ साझा करना चाहता हूँ। इस कॉन्फ्रेंस में चूँकि मेरा आईआईटी से पुराना नाता रहा है, आईआईटी में मैंने पीएचडी करी, उसके बाद आईआईटी में नौकरी करी, वहाँ पर बहुत सारे सम्मेलन देखे हमने और यहाँ पर बहुत सारे जो अतिथिगण आए उन्होंने उनके भी अपने अनुभव थे, क्योंकि उनके बाद हमने फीडबैक लिया तो ऐसा अभूतपूर्व आयोजन जो है संभवतः कहीं नहीं हुआ, जिसके लिए आयोजन समिति को मैं हृदय से धन्यवाद देता हूँ। और ये किन मायनों में ये अभूतपूर्व है, इसलिए चूंकि आप तो सर एक टेक्नोक्रेट रहे हैं, प्रशासक भी रहे हैं, वो इसलिए कि इस समारोह में माननीय हमारे जो रसायन उर्वरक मंत्री हैं उनका स्वयं का जो है सहयोग रहा उस पे, और वो भी उन्होंने विगत 1 माह से इसकी जो है गतिविधियों के बारे में जानकारी वो लेते रहे और उनको इस विषय की जो विकसित भारत था और साथ में उसमें सिपेट का क्या योगदान है उसके बारे में, इसके साथ साथ इसमें विभिन्न जो क्योंकि जो हम लोग आजकल डाइवर्सिफिकेशन और आउट ऑफ बॉक्स थिंकिंग के बारे में बात करते हैं, उसमें बहुत सारे ऐसे जो प्रशासक भी आए, बहुत सारे एकेडमिशियन भी आए और बहुत सारे पर्यावरणविद भी आए। और इसमें मैं एक कॉल सर आपको इन ए वेरी लाइटर नोट बताना चाहता हूं कि एक देश के प्रख्यात इन्वायरमेंटलिस्ट हैं श्री डॉक्टर अनिल प्रकाश जोशी, पद्म भूषण। पिछले वर्ष वो हमारी अहमदाबाद एपीएम में आए थे और उन्होंने प्लास्टिक जो कि हमारा कोर है उसमें के खिलाफ बहुत सारी चीजें कहीं। और आज जब ये 2 दिन पहले यहां पर आए और उन्होंने जब हमारा उद्घाटन समारोह हुआ उन्होंने भूरी भूरी उसकी प्रशंसा करी, तो ये मैं सिपेट का संपूर्ण योगदान मानता हूं कि उन्होंने एक व्यक्ति को जो नो प्लास्टिक का ध्वजवाहक था उसने KNOW प्लास्टिक के बारे में जानकारी करी। दूसरी बात जो मैं यहां पर कहना चाहता हूं कि हम लोग चूंकि विकसित भारत के क्षेत्र में जा रहे हैं सर, 2047 में हमें जो है विकसित भारत का लक्ष्य है, तो बिना बच्चों के और बच्चों की कल्पनाओं को आत्मसात किए हम आगे नहीं बढ़ सकते। क्योंकि मैंने अपने उद्बोधन में यह बात कही थी कि संभवतः 2047 में जब देश विकसित होगा तो हम उस समय संभवतः बहुत सारे लोग इस जगत को छोड़ चुके होंगे, लेकिन इसी परिकल्पना के साथ हम लोगों ने छोटे बच्चों की प्रतियोगिताएं इसमें शुरू करी कि वो देश के बारे में या स्पेशली हमारे कोर सेक्टर के बारे में क्या सोचते हैं। तो क्लास 6 से लेकर क्लास 12 तक हमने यहाँ प्रतियोगिता करी और हमें हर्ष है कि यहाँ बच्चे आए जो उसमें विजेता रहे। तो सर ये कुछ और ऐसी उपलब्धि और भी है कि मैंने भी अपने पूरे आईआईटी के कार्यकाल में बहुत सारी कॉन्फ्रेंसेस करी। हम लोगों को पेपर्स इकट्ठा करने में बड़ी जो है दिक्कत होती थी, स्पॉन्सरशिप इकट्ठा करने में बड़ी दिक्कत होती थी। आपके पीछे सर जो है ये लगा हुआ है जिसमें आप ये देखिए कि उद्योग जगत के लोगों ने कितना सहयोग दिया और जिनसे हम कल्पना नहीं कर सकते थे कि ये लोग हमको जो है वो सहयोग देंगे, उन्होंने आगे बढ़ कर किया। और हमारे सहयोगी विवेक जी को बाद में मना करना पड़ा कि अब हम उस स्थिति में नहीं है कि हम आपका जो है सहयोग स्वीकार कर सकें। तो ये भी इस कॉन्फ्रेंस की प्रतिष्ठा और जो इसकी थीम है उसका परिचायक है। नंबर ऑफ पेपर्स के बारे में हमारे सहयोगी ने बताया, उसका एक रिगरस ये हुआ। और जो लोग एकेडमिक जगत के हैं वो ये जानते हैं कि 2 पब्लिशिंग हाउस एल्सवेयर और स्प्रिंजर, ये जो विश्व के सर सबसे बड़े पब्लिशिंग हाउस है जो रिसर्च जर्नल्स वगैरह छापते हैं, पहली बार पूरे देश में संभवतः ऐसा हुआ है, दोनों एक साथ आए और दोनों ने पुरस्कार दिए। तो ये कुछ मायनों में ये कॉन्फ्रेंस जो है ये सर बहुत अलग सी रही और बहुत अच्छा जो है समाज के हर जो भी स्टेक होल्डर है उनका सहयोग रहा। और मुझे ये आशा है कि अगली बार जब ये कॉन्फ्रेंस हम जयपुर में करेंगे तो ये और उन्नति के पथ पर जाएगी। इन्हीं शब्दों के साथ सर मैं अपनी वाणी को विराम देता हूं। और मैं अपने अच्छा हाँ, हमारे सहयोगी नितेश जैन साहब सर एक कह रहे हैं कि संभवतः आपकी ये पहली सिपेट की विजिट है, तो ये उपयुक्त होगा कि हम सिपेट के बारे में एक संक्षिप्त जो है प्रेजेंटेशन दें, जो कि हम हर जगह देते हैं। तो आपकी अनुमति तो हो तो इसमें शुरू करिए। कहाँ चालू है, कहाँ है? कुछ डिस्प्ले तो हो इस पे, कहाँ है? नहीं, पीपीटी जो सिपेट के बारे में है, सिपेट की पीपीटी जो था ना, ये तो सर को शेयर कर देंगे, पीपीटी सिपेट की। No, about सिपेट। सर सिपेट जो है, मैं तब तक जब तक ये पीपीटी लोड होती है मैं थोड़ा आपको बता देना चाहता हूँ। सिपेट की स्थापना 1968 में हुई थी। तत्कालीन केंद्रीय उद्योग मंत्री आर वेंकटरमन जो भारत के राष्ट्रपति बने, उन्होंने गिंडी चेन्नई में सिपेट की स्थापना करी थी यूएनडीपी के एक प्रोग्राम के तहत। और उसके बाद लगभग 57 वर्षों में सिपेट उत्तरोत्तर प्रगति करता रहा और आज की तारीख में सिपेट जो है वो स्टार कॉन्सेप्ट पर बिलीव करता है, जिसमें कि स्टार स्किलिंग, टेक्निकल सपोर्ट सर्विसेज, हमारे एकेडमिक पोर्टफोलियो में बहुत सारे कार्यक्रम हैं जिसमें कि जिसके बारे में मैंने कुछ आपको बताया, और 3 हमारे जो है अति उत्तम रिसर्च सेंटर हैं बेंगलुरु, चेन्नई और भुवनेश्वर में। तो हम लोग जो है इसमें हमारा जो बेसिक थीम जो स्टार को हम लोगों ने चेंज किया है, उसमें सस्टेनेबिलिटी कॉन्सेप्ट को जो है उसमें ऐड किया। और समय समय पर माननीय प्रधानमंत्री जी जो है सिपेट के प्रशंसा करते रहे हैं और जितने भी हमारे नए केंद्र हैं उसमें अधिकतर केंद्रों का जो उद्घाटन या शिलान्यास माननीय प्रधानमंत्री जी ने किया। सिपेट की सर जो है वो पैन इंडिया प्रेजेंस है। हमारे कुल 48 केंद्र हैं जो 34 विभिन्न शहरों में है और हमारे 3 वर्टिकल्स हैं। 3 में हमारा जो मेन जो वर्टिकल है वो इंस्टीट्यूट ऑफ पेट्रोकेमिकल टेक्नोलॉजी है जो देश में 9 जगहों पर है। लखनऊ भी उसमें से एक है और अभी नया हमारा नवीनतम कुछ 1-2 महीने में शुरू हो जाएगा बिहटा में, बिहार में। क्या वो चालू नहीं हुआ? हाँ, ये सर जो है प्रधानमंत्री जी ने अक्सर जो है ईज ऑफ लिविंग के लिए सिपेट को कई बार जो है साधुवाद दिया है। तो हमारी जर्नी सर जो शुरू हुई थी 1968 जैसा मैंने बताया, और ये अलग अलग डायमेंशंस को चेंज करते हुए 2018 में हमने अपने नाम में प्लास्टिक को हटाकर पेट्रोकेमिकल किया डाइवर्सिफिकेशन के लिए। और स्टार में हम स्किल डेवलपमेंट में पाइनियर है। हर साल लगभग जो है 75,000 के करीब हम लोग स्किल डेवलपमेंट ट्रेनिंग मैन पावर प्रोवाइड करते हैं। टेक्नोलॉजी सपोर्ट सर्विस देश में यूनिक है प्लास्टिक के क्षेत्र में। अब हम केमिकल और पेट्रोकेमिकल के डोमेन में चले गए हैं। एकेडमिक में जैसा मैंने बताया, मैं थोड़ा आगे और विस्तार से आपको बताऊंगा कि NSQF के हमारे 1 से 10 तक के सारे फ्रेमवर्क में और देश की एकमात्र संस्थान ऐसा है। रिसर्च में बहुत सारे हम लोगों ने इंडिजिनाइजेशन किया है। तो अब हम लोग चूंकि जैसा मैंने आपको बताया था कि सिपेट एक आत्मनिर्भर संस्थान बन चुका है और आत्मनिर्भरता तभी आती है जब हमारे अंदर आत्मविश्वास हो। तो हमने पूरे विगत कुछ वर्षों में पूरे सिस्टम को इंटीग्रेट किया ताकि हमें पता लगे हमारी कोर स्ट्रेंथ क्या है और उसके बाद हम शोकेसिंग करें। यही एक कॉन्फ्रेंस उसकी एक परिणति है। तो इसीलिए हमने इसको एक दूसरा नाम दिया, सस्टेनेबिलिटी थ्रू असेसमेंट एंड रीडिजाइनिंग। ये हमारी पैन इंडिया प्रेजेंस है। मैंने जैसा बताया था कि आपको कि हम हमारे जो 3 मेजर वर्टिकल्स हैं, इंस्टीट्यूट ऑफ पेट्रोकेमिकल टेक्नोलॉजी, 9 CSTS जिससे कि सेंटर फॉर स्किलिंग एंड टेक्निकल सपोर्ट सर्विसेज 32 है जहां पर हम डिप्लोमा देते हैं। साथ में टेक्निकल सपोर्ट जो उद्योग जगत से, क्योंकि देश का ऐसा एक यूनिक संस्थान है जहां पर उद्योग जगत का इतना हमारे सामंजस्य है कि उसके बिना प्लास्टिक उद्योग या पेट्रोकेमिकल उद्योग आगे आने वाले समय में कल्पना नहीं कर सकता। 3 रिसर्च सेंटर हैं, स्कूल फॉर एडवांस रिसर्च इन पेट्रोकेमिकल, और कुछ हमारे सब सेंटर्स हैं जो कि किसी न किसी सेंटर के सहयोग से काम करें जहां पर उद्योग की जगत की डिमांड होती थी। इसके अलावा सर आपको जानकर यह भी प्रसन्नता होगी कि हमने, चूंकि प्लास्टिक वेस्ट मैनेजमेंट जो है एक बड़ा भारी इशू है, तो उसको हमने समय रहते समझा और साथ में देश की जनता को और उद्योग जगत को उसके बारे में जानकारी दी जाए, उसके लिए हमने जो है 4 डेमोन्स्ट्रेशन सेंटर प्रस्तावित किए। 3 शुरू हो गए हैं, चौथा सानंद में शुरू होने जा रहा है और इसको हम लोग एक नया नाम दे रहे हैं प्लास्टिक वेल्थ मैनेजमेंट। इस वजह से क्योंकि ये वेस्ट ही किसी चीज का जो है रॉ मटेरियल है। कुछ और नए सेंटर प्रस्तावित हैं और उनको हम भविष्य में देखें। सर ये एक मेजर एसेट है सिपेट की, टोटल कितना हमारा लैंड एरिया है, ह्यूमन एसेट्स के। यहां पर मैं आपको एक बात बताऊं कि सिपेट जो है डिजिटल इंडिया कॉन्सेप्ट में बड़ा अच्छा बिलीव करता है। तो जो भी आपके पास फिगर है सर, ये पूरे ऑथेंटिक फिगर हैं। यदि मैं ये कहूं कि अगर हमारे यहाँ रेगुलर एम्प्लॉयज 866 हैं तो 866 हैं। तो ये आप ये देखिए कि डेटा मैनेजमेंट, डेटाबेस मैनेजमेंट के लिए ये एक बड़ा यूनिक चीज हुई है। ये टोटल हमारी प्रेजेंट स्ट्रेंथ है जो कि हमारा, जिनको 2 भागों में बांटा गया है। ये सर सिपेट की एकेडमिक जर्नी है। 1969 में हमने सर्टिफिकेट कोर्स से शुरू करते करते 2004 में डॉक्टोरल प्रोग्राम शुरू किया और 3 हमारे केंद्र, आपको ये अर्थ होगा कि 3 हमारे केंद्र जिसमें सिपेट आईपीटी लखनऊ भी शामिल है, ये NIRF रैंकिंग में आ चुके हैं। तो एकेडमिक्स चूंकि हमारा कोर है, इस पर हमारा काफी ध्यान। ये हमारा सर एकेडमिक और स्किलिंग पोर्टफोलियो है। आप देखिए कि हमारे जितने भी रैंकिंग फ्रेमवर्क में सब में हम फुलफिल करते हैं। स्किल डेवलपमेंट ट्रेनिंग प्रोग्राम टोटल 37 है, जिसको कि इस वर्ष हम लोग 100 के करीब ले जा रहे हैं। अभी हमारी स्किल मिनिस्ट्री से भी जो है उन्होंने हम पर जो है वो हमसे कहा है, साथ में और भी बहुत से जो उद्योग जगत के। और सिपेट एक ऐसी यूनिक संस्था जिसके बारे में मैंने बताया कि हम अवार्डिंग एंड असेसिंग बॉडी दोनों हैं। तो और हमारे 4 जो प्रोग्राम हैं वो NBA एक्रेडिटेड हैं। इसके अलावा बहुत सारे PG, डिप्लोमा, अंडर ग्रेजुएट प्रोग्राम हैं। यहाँ पर एक जो पहलू है वो ये है कि हमारे जो बीटेक के और MTech के प्रोग्राम हैं वो रिस्पेक्टिव टेक्निकल यूनिवर्सिटीज के साथ एफिलिएटेड हैं, जो कि मैंडेटरी है उसके हिसाब से। ये हमारे कुछ स्किल डेवलपमेंट के कोर्सेज, जैसा मैंने आपको बताया कि 75,000 के करीब हम लोग जो है, और इसमें हमें एक मैंडेट भारत सरकार ने दिया है कि 2029 तक हम को 1,20,000 प्रतिवर्ष करना है और उसके लिए उत्तरोत्तर हम आगे बढ़ रहे हैं। ये हमारे जो एकेडमिक्स का टोटल जो पोर्टफोलियो की डिग्री डिप्लोमा में सेग्रीगेशन कितना, हर वर्ष कितने एडमिशन्स होते हैं और कितने एवरेज सैलरी, और पूरा ये स्टैटिस्टिकल इंफॉर्मेशन है। यहाँ पर ये जो स्टूडेंट्स की स्ट्रेंथ, यहाँ पर आपको देख के हर्ष होगा कि 90% और 85% ये रिस्पेक्टिवली डिप्लोमा और डिग्री में हमारा प्लेसमेंट है। और इसमें यह भी है कि अगर जो 10% या 15% बचे, ये बहुत सारे जो हमारे छात्र या तो एंटरप्रेन्योरशिप पे चले जाते हैं या हायर डिग्री में चले जाते हैं। ये हमारा प्लेसमेंट का सिनेरियोस और स्टैटिस्टिकल इंफॉर्मेशन को जिसको हम लोगों ने चार्ट में दिया, जिसमें 88 to 91% ऑन एन एवरेज इसमें जाते हैं। एल्यूमिनाई सर किसी भी क्षेत्र का, किसी भी संस्थान का एक की फैक्टर होता है। इसमें आज से कुछ वर्ष पूर्व इस पर बहुत ज्यादा जो है एम्फेसिस नहीं हुआ था। आज हमारे बास्केट में सर 35,000 के करीब जो है एल्यूमिनाई हैं, जिनसे कि हम दिन प्रतिदिन जुड़े हुए हैं और बहुत सारा सहयोग उन्हें हमें उनका मिलता रहता है विभिन्न एक्टिविटी में। और एल्यूमिनाई कनेक्ट और एल्यूमिनाई स्पीक प्रोग्राम हम लोगों ने शुरू कर रखा है। एक और हमारा आयाम है टेक्नोलॉजी सपोर्ट सर्विसेज का। और ये जितने भी प्लास्टिक, अब तो ये थोड़ा सा हम लोग इसको डाइवर्सिफाई कर रहे हैं पेट्रोकेमिकल सेक्टर और केमिकल सेक्टर में, क्योंकि जब विकसित भारत का हमको ले जाना है तो उसमें ये हमारे अभी एक हमको मैंडेट मिला है कि 75% जो स्पेशलिटी केमिकल है वो चाइना से इंपोर्ट होते हैं। तो उनको कैसे किया जाए, क्या सिपेट उसकी एक नोडल एजेंसी बन सकती है? तो इसमें बहुत सारी चीजें हैं सर, जैसे स्टैंडर्डाइजेशन की बात होती है, इसमें जो रॉ मटेरियल की बात होती है, इसमें प्रोसेसिंग की बात होती है, वो सारी चीजें। तो उसके लिए सिपेट अपने आप को नर्चर कर रहा है और वन स्टॉप सोल्यूशन के कॉन्सेप्ट पर हम लोग आगे बढ़ रहे हैं। ये हमारे सर कुछ कोर एरिया हैं जिनको पे हम लोग इस समय फोकस किए हुए हैं। ये निस्संदेह प्लास्टिक से रिलेटेड है, लेकिन धीरे धीरे करके हम लोग पेट्रोकेमिकल पर जा रहे हैं और इंजीनियरिंग एस्पेक्ट को हम आगे की तरफ ले जा रहे हैं। ये यहां पर बताना सर महत्वपूर्ण होगा कि आज की तारीख में हमें 2 चीजों पर बहुत ध्यान, जैसे कि कभी भी एक कॉमन मैन के पर्सपेक्टिव में वो बड़ी महत्वपूर्ण होती है। एक तो स्टैंडर्ड्स, हर आदमी सोचता है कि BIS स्टैंडर्ड, IS स्टैंडर्ड है कि नहीं, FSSAI स्टैंडर्ड है कि नहीं। तो इस पर तो यहां पर हमारी जो 26 लैब हैं टेस्टिंग लैब, वो NABL एक्रेडिटेड है। 12 लैब जो कि बायोपॉलीमर, बायोकम्पोस्टेबल, बायोडिग्रेडेबल पॉलीमर पर है, वो CPCB से रिकॉग्नाइज्ड है। और कैलिब्रेशन के लिए जो है वो हमारी अभी वर्तमान में 2 लैब है, और आपको जानकर हर्ष होगा कि सर लखनऊ में तीसरी लैब खुलने वाली है, शायद संभवतः एक महीने के अंदर जो है वो खुल जाएगी। और NABCB की जो है ये टाइप A इंस्पेक्शन बॉडी है। TSS चूंकि हमारी एक मेन सोर्स है रेवेन्यू का, तो उसमें हम जो है मैं हर वर्ष जो है नए प्रतिमान लेते हैं और कितने हम असाइनमेंट करते हैं, और हर वर्ष करीब 10 से 15% हम जो है इस पर उत्तरोत्तर प्रगति करते हैं। R&D सेक्टर हमारा एक कोर सेक्टर, जैसा मैंने बताया कि 3 हमारे मुख्य R&D सेंटर हैं। 3 उसमें हमारे जो मेन जो R&D सेंटर के फोकस हैं वो सोशियो इकोनॉमिक फैक्टर पर है कि उसका इकोनॉमिक जो एनर्जी, इन्वायरमेंट और इकोनॉमिक्स इसका क्या जो है प्रभाव है उस पर है। उसके आधार पर हम फॉर्मुलेशन, टेक्नोलॉजी ट्रांसफर और कारपोरेट सेक्टर में हम बहुत सारी जो है चीज़ों को इसमें करते हैं। ये कुछ एरिया है जिस पर कि हमारी R&D होती रहती है। ये हमारी जो प्रगति है R&D के क्षेत्र में, क्योंकि R&D का जो मुख्य जो पैरामीटर्स हैं वो यहाँ पर इनलिस्टेड है कि आइदर वो रिसर्च पब्लिकेशन में हो, या पेटेंट्स में हो, या जो है टेक्नोलॉजी ट्रांसफर में हो, या रेवेन्यू जनरेशन में हो, तभी आपकी जो है स्वीकार्यता बढ़ती है। तो उसमें अभी हम दिन प्रतिदिन उत्तरोत्तर प्रगति कर रहे हैं। कुछ चीज़ों को हम लोगों ने सर आत्मनिर्भर भारत के तहत जो है बनाया है, जिसमें कंपोजिट्स हैं, हमारे एयरक्राफ्ट स्ट्रक्चर्स हैं, एडहेसिव्स हैं, ड्रोन सेल्स हैं, सोलर सेल्स है, इको फ्रेंडली चीजें हैं। इन सब के बारे में जो आपको डिटेल में आपको भेजूंगा सर। ये एक बड़ा कोर सेक्टर है सर। यहां पर हर वर्ष जो है भारत सरकार हमारे लिए एक टारगेट सेट करती है। तो विगत वित्तीय वर्ष में हमारा टारगेट था कि हमारा जो टर्नओवर टोटल होना चाहिए वो 330 करोड़ का होना चाहिए। हमने टोटल रेवेन्यू जनरेट करी 347 करोड़, एक्सपेंडिचर हमारा 302 करोड़ हुआ, और 45 करोड़ का पोस्ट डेप्रिसिएशन हमने लाभ अर्जित किया। तो ये सर जो, और इसका हमने एक कॉर्पस बनाया हुआ है जिसके में जैसा कि आपने देखा कि उसी का ही एक परिलक्षित है कि हम लखनऊ केंद्र को इतना सुसज्जित कर पाए। हमारे कुछ फ्यूचर की चीजें हैं जो कि कुछ स्टडीज हैं जो कि संभवतः ये आगे के लिए बहुत ज़्यादा उपयोगी होंगी, जिसके डायरेक्शन में हम सिपेट को अगले 5-10 साल में ले जा सकते हैं। इसको कॉन्सेप्ट दिया विनिंगली फ्यूचर इंडिया का। माननीय प्रधानमंत्री जी हमेशा बार बार कहते हैं कि हम 5 ट्रिलियन इकोनॉमी के बारे में बात करें। 2034 में प्रोजेक्टेड जो इकोनॉमिक ग्रोथ है वो हमारी 10.4 ट्रिलियन डॉलर की है। इसमें किन सेक्टर्स में हमको काम करना चाहिए, इसके बारे में 10 सेक्टर को जो है हम लोगों ने एनालाइज किया। ये 10 में से 6 सेक्टर यहां पर है जिसमें कि हमेशा सिपेट जो है ग्रोथ कर सकता है। हेल्थ केयर में, मेडिकल डिवाइसेस में, आप किसी भी मेडिकल इक्विपमेंट की परिकल्पना बिना प्लास्टिक के नहीं कर सकते आज की तारीख में। इसी तरीके से मैन्युफैक्चरिंग सेक्टर, रिटेल सेक्टर, पावर सेक्टर, एजुकेशन सेक्टर, एग्रीकल्चर सेक्टर, बिना प्लास्टिक के, बिना पेट्रोकेमिकल के आज की तारीख में जो है कल्पना नहीं कर सकते। तो इनको सेग्रीगेट करके और किन किन एरिया में हमको सिपेट के 48 केंद्रों को ले जाना, उसमें थ्रस्ट एरिया डिफाइन करने। अर्बनाइजेशन में, फाइनेंशियल सर्विसेज में, डिजिटल कनेक्टिविटी में, फिजिकल कनेक्टिविटी, आज कोई भी मोबाइल सेट बिना प्लास्टिक के या बिना पेट्रोकेमिकल प्रोडक्ट के, क्योंकि प्लास्टिक भी अल्टीमेटली जो है पेट्रोकेमिकल का ही एक प्रोडक्ट है, तो उसके बिना हम कल्पना नहीं कर सकते। और ये सारी जितनी भी गतिविधियां हम लोग अगले 10 वर्षों के लिए डिजाइन कर रहे हैं, ये 2 मार्कर्स हैं हमारे, विकसित भारत 2047 और नेट जीरो 2070। क्योंकि समग्र रूप से अगर हम जाएं तो समग्र रूप में हमको यही चीजें देखनी पड़ेंगी कि कैसे हम आगे चलें। ये हमारे कुछ फ्यूचर प्लान हैं। चूंकि हमारा कोर एकेडमिक्स है तो इसमें हमें जो है अप स्ट्रीम, डाउन स्ट्रीम में बहुत सारे कोर्सेज को हमने नई शिक्षा नीति के तहत डिजाइन किया हुआ है। इसमें नए एकेडमिक स्किलिंग प्रोग्राम किए हैं जिसमें मेजर जो थ्रस्ट दिया सर्कुलर इकोनॉमी, प्लास्टिक वेस्ट मैनेजमेंट, और इसी के तहत हमने जो है 4 प्लास्टिक वेस्ट मैनेजमेंट सेंटर की स्थापना करी। अप स्ट्रीम, डाउन स्ट्रीम में जो भी आम आदमी से रिलेटेड चीजें हैं उनको हमने यहां पर समावेशित किया है। कुछ नई चीजें जो हम लोग करने जा रहे हैं, जैसे सिपेट के में टूल रूम फैसिलिटी, सिपेट आईपीटी चेन्नई में हमारी प्राथमिकता है। सिपेट अहमदाबाद चूंकि जो है वो वहाँ पर जगह का अभाव है, इसलिए हमने वहाँ पर स्पेशलाइज्ड टूल रूम फैसिलिटी को स्क्रैप कर दिया। यदि यहाँ पर हमारे यहाँ लखनऊ में हो जाता है जगह की तो हम ये स्पेशलाइज्ड टूल रूम फैसिलिटी वहाँ से स्थानांतरित यहाँ पर करेंगे। इसी तरीके से टेस्टिंग फैसिलिटीज़ के बारे में हम उत्तरोत्तर प्रगति कर रहे हैं। सिर्फ टॉय टेस्टिंग, जो कि मैंने आपको चर्चा करी थी कि जो भारत सरकार ने टॉय इंपोर्ट पर रिस्ट्रिक्शन लगाया है, उसमें बहुत सारी टेस्टिंग, बहुत सारी संभावनाएं हैं। उसके लिए यहाँ औरंगाबाद में शुरू हो चुकी है और लखनऊ में भी संभवतः अगले माह से शुरू हो जाएगी। एडिटिव मैन्युफैक्चरिंग, जो 3D प्रिंटिंग के बारे में मैंने बात करी, 3D प्रिंटिंग चेन्नई में हमारी स्टेट ऑफ आर्ट फैसिलिटीज़ है। यदि आपको अवसर मिले तो कभी आप जरूर उसको देखिए, वो बहुत अच्छी सुविधा हम लोगों ने की। सिमिलरली हम लोगों ने जो लिथियम आयन बैटरीज के सब्स्टिट्यूट के तौर पर बहुत सारे बैटरीज के जो सब्स्टिट्यूट हो सकते हैं उस पर हमने रिसर्च किया। हम पैकेजिंग कंपोजिट R&D फैसिलिटी या तो लखनऊ या कानपुर में R&D सेंटर के में प्रस्तावित करते हैं उसमें। इसी तरीके से हमारे जो बहुत सारी टेस्टिंग प्रोसेसिंग जो कि हमारी रेवेन्यू शेयरिंग उस पर हैं, उस पर हम डिफरेंट सिपेट सेंटर्स पर ले जाते हैं। ये कुछ नए कोर्सेज प्रस्तावित किए हैं हम लोगों ने इसमें, जो कि हर क्षेत्र से रिलेटेड हैं। हम उसके संदर्भ में ह्यूमन रिसोर्स को, अपने लोगों को उच्च शिक्षा के लिए प्रेरित कर रहे हैं, साथ में उनको ट्रेनिंग भी दे रहे हैं ताकि आगे के समय के लिए ये आ सकें। कुछ इनिशिएटिव्स लिए इसमें सर हम लोगों ने, और ये कुछ इनिशिएटिव्स जो हैं वो बहुत अच्छे इनिशिएटिव्स रहे जिससे सिपेट को विगत वर्षों में फ़ायदा हुआ। इंडस्ट्री इंस्टीट्यूट, इंटरफेस प्लेटफॉर्म, बहुत सारी चीज़ें ऐसी रही जिसपे कि इंडस्ट्री का हमें जो भी कोर्सेज आपने देखे या जो भी नई चीज़ें देख रहे हैं वो इंडस्ट्री का, क्योंकि इंडस्ट्री कॉमन आदमी से ज़्यादा जुड़ी हैं, उससे जो है वो हमने उनका फीडबैक लिया। आउटरीच, सोसाइटल चीज़ों में, सोसाइटल रिस्पॉन्सिबिलिटी की, लोगों को नो प्लास्टिक को बैन करने की अपेक्षा उसको समझने के, इस पर एक मुहिम चलाई हम लोगों ने। नो प्लास्टिक से KNOW प्लास्टिक के बारे में अभी रिसेंटली जो है हम लोगों ने केमिकल सेफ्टी ट्रेनिंग प्रोग्राम, जो मेजर एक्सीडेंटल हैजार्ड यूनिट्स भारत में तो तकरीबन 2400 हैं, उनको ट्रेंड करने के लिए 5 साल का एक मिशन शुरू किया। 8 ट्रेनिंग प्रोग्राम ऑलरेडी इसमें हो चुके हैं। हमारी सारी गतिविधियां लगभग जो डिजिटाइज हो चुकी हैं। ऑलरेडी हम लोगों ने जो नई एजुकेशन पॉलिसी है, जो राष्ट्रीय शिक्षा नीति है, उसको यहाँ पर अपने कोर्सेज में, डिप्लोमा कोर्सेज में इम्प्लीमेंट कर दिया। हमने बहुत सारे ऑनलाइन ऑन साइट कोर्सेज जो है इंडस्ट्रीज के स्किल डेवलपमेंट में किए। हमारा कोच्चि सेंटर इस मामले में पायनियर है, उन्होंने इस पर किया। हम वन स्टॉप सोल्यूशन जो इंडस्ट्री के लिए, कि आपकी कोई भी समस्या हो उसको आप हमारे पास आए, हम उसका समाधान करेंगे सेक्टर में। हमने जैसा आपको बताया कि एल्यूमिनाई कनेक्ट, एल्यूमिनाई स्पीक प्रोग्राम शुरू किया, जिसमें 35,000 का जो है एल्यूमिनाई डेटाबेस क्रिएट किया। एक मेंटरशिप प्रोग्राम भी शुरू किया है जो कि चेन्नई में इस समय हमारा चल रहा है, जिसमें इंडस्ट्रीज के बड़े लोग जो है हमारे छात्रों को जो है मेंटरिंग कर रहे हैं, जो कि बहुत जरूरी है उसके लिए। और इसमें हमारा ने एक नई थीम दी है कि विश्व हमको देख रहा है, और हमारे पास बहुत सारे टूल्स हैं, चाहे स्टार्टअप इंडिया, मेक इन इंडिया, डिजिटल इंडिया, इन सब करके हम इसको आगे बढ़ते हैं। इसी के साथ में धन्यवाद सर।
आपके उद्बोधन के लिए बहुत बहुत धन्यवाद सर, बहुत बहुत आभार। अब मैं अनुरोध करता हूं हमारे आज के मुख्य अतिथि आदरणीय अवनीश कुमार अवस्थी साहब का कि वो आए, हम सभी को संबोधित करें, अपने आशीर्वचन प्रदान करें।
आज मुझे बहुत जोर शोर से और खूब एनर्जी के साथ और इस एनर्जेटिक एनवायरनमेंट में फैकल्टी, स्टूडेंट, स्पीकर्स के बीच में सिपेट के लखनऊ के इस सेंटर में आमंत्रित करने के लिए सर्वप्रथम मैं प्रोफेसर सिन्हा साहब का विशेष आभार व्यक्त करना चाहूँगा, ताली बजवाना चाहूँगा आप लोगों से कि आपने कई महीनों से मुझसे संपर्क में रहे और आपने कहा कि आना ही है, और मैंने कहा आना ही होगा। और मुझे इस बात की खुशी है कि आज इस महत्वपूर्ण मौके पर वैलेडिक्टरी फंक्शन में मैं यहाँ पर हूँ। आपकी धर्मपत्नी जी और आपकी दोनों बेटियां यहाँ हैं, उनका भी मैं स्वागत करना चाहूँगा। यहाँ पर विवेक कुमार साहब हैं जिन्होंने पूरा कैंपस अभी हम लोगों को दिखवाया, उनको मैं उनका स्वागत करना चाहूँगा। और यहाँ पर जितने फैकल्टी मेंबर्स हैं, स्टूडेंट्स हैं, और भी जो यहाँ पर इस कॉन्फ्रेंस में आए हैं उनसे जो है आज यहाँ पर फेस टू फेस होने पर निश्चय ही मुझे खुशी हो रही है। मैंने बहुत पास ही, इस सेंटर के पास ही जो है पिपरसंड गांव है, और पिपरसंड गांव में मैंने एक नया इंस्टीट्यूशन शुरू किया जिसका नाम है फॉरेंसिक इंस्टीट्यूट। और अगर आप कभी उस कैंपस को जाकर देखेंगे तो निश्चय ही आप लोगों को एक अच्छा लगेगा। और मुझे इस बात की खुशी है कि ये जो पूरा एरिया आ रहा है, और अभी आपने जो आईडीपीएल की जमीन का जिक्र किया, वहाँ बैटरी का ही और पूरी इलेक्ट्रिक व्हीकल्स का, बसेस का एक प्लांट अशोक लेलैंड का आ रहा है। तो ये पूरी बेल्ट ही धीरे धीरे डेवलप हो रही है। मुझे इस बात की भी खुशी है कि यहीं बगल में जो है डिफेंस कॉरिडोर को भी स्थापित करने का मुझे मौका मिला। और आज डॉक्टर बीएम जोशी जो वहाँ के हेड हैं ब्रह्मोस के, उन्होंने ब्रह्मोस मिसाइल का प्लांट जो निर्माणाधीन है वो भी मुझे आज दिखाया। और इस बात की खुशी है, जब पहली बार मैं बंटवारा गांव आया था तो हमें लगा नहीं कि ज़मीन मिल जाएगी, लेकिन मुझे इस बात की खुशी है कि वहाँ ज़मीन भी मिली, अलॉट भी हुआ, और ब्रह्मोस मशीन भी मई महीने तक जो है बड़ी बड़ी मिसाइल्स जो है, बड़ी बड़ी चीज़ें वहाँ शुरू हो जाएंगी। तो एक पूरा एनवायरनमेंट लखनऊ में और प्रदेश में आ रहा है। मुझे इस बात की भी खुशी है कि यहाँ आपने मुझे बताया कि डिप्लोमा के छात्र भी हैं, शॉर्ट टर्म कोर्सेज के छात्र भी हैं, आपके जो है डिग्री छात्र भी हैं, और पोस्ट ग्रेजुएट के साथ साथ जो है पीएचडी के छात्र भी यहाँ पर हैं। मुझे जानकारी करनी थी कि कितने छात्र हैं, जरा हाथ खड़ा करिए। जो स्टूडेंट्स हैं यहाँ के, जरा हाथ खड़ा करके बताइए कौन कौन स्टूडेंट्स हैं। वेरी नाइस। कितने स्टूडेंट्स ऐसे हैं जो मेहनत से पढ़ाई करते हैं, जो अपने देश में अपना नाम करना चाहते हैं? ऐसे कौन स्टूडेंट्स हैं? हैं, काफी है, पीछे बीच में लड़कियां भी हैं। कितने ऐसे स्टूडेंट्स हैं जो अपने माँ बाप का नाम करना चाहते हैं आगे बढ़ के? ये बात देखिए, आज की तारीख में मैं, कई चीजें हैं मेरे सामने और बहुत डिटेल्ड आपने एक प्रेजेंटेशन दिया, तो कई पॉइंट्स में नोट कर रहा था। और मैं भी चूंकि पढ़ने में स्टूडेंट अच्छा हूं तो मैं पूरा क्लास लूंगा आपकी, और उसमें कहीं पीछे हटूंगा नहीं। और मैं आईआईटी कानपुर का छात्र हूं, पीएचडी भी आपने आईआईटी कानपुर से की है, और आप आईआईटी रुड़की से हैं जहां मेरे छोटे भाई ने जो है वहां के इंजीनियरिंग की है। तो हर तरफ से जो है इंजीनियरिंग और इंजीनियरिंग से जुड़े हुए सेक्टर्स, टेक्निकल सेक्टर्स, जो आपका पूरा क्षेत्र है वो बहुत ही स्पेसिफिक सेक्टर है। आपने इसको पहले प्लास्टिक्स तक सीमित किया था, लेकिन आज पेट्रोकेमिकल्स तक आप ले जा रहे हैं, और सिपेट को सेंट्रल इंस्टीट्यूट ऑफ पेट्रोकेमिकल इंजीनियरिंग एंड टेक्नोलॉजी का नाम पूरा दिया हुआ है। तो मैं आपसे कह सकता हूं कि प्लास्टिक इज पार्ट ऑफ एवरीथिंग इन लाइफ। देयर इज नथिंग इन लाइफ विच इज नॉट, आप इस कमरे में देखें तो ऑलमोस्ट एवरीथिंग इज रिलेटेड टू प्लास्टिक। चाहे वो पीछे की स्क्रीन ही क्यों ना हो, चाहे वो मेरा माइक्रोफोन ही क्यों ना हो, चाहे जिस कुर्सी में बैठा क्यों ना हो, और आज की तारीख में बहुत सारा फर्नीचर ही क्यों ना हो, और अगर हम आगे चलेंगे तो हमारे कपड़े भी लगभग प्लास्टिक के हो जाएंगे। और बहुत हाल ही में, पिछले साल, 1.5 साल पहले, आदरणीय प्रधानमंत्री जी को जो हरदीपुरी साहब है, उन्होंने पूरी प्लास्टिक से वेस्ट से बनी हुई जैकेट भेजी थी, और फिर वही जैकेट जो है आदरणीय योगी जी को भी जो है उन्होंने भेंट की, और उस जैकेट का एक कंपोनेंट मेरे पास भी आया था। तो हर चीज में चूंकि प्लास्टिक और पेट्रोकेमिकल जुड़े हुए हैं, तो निश्चय ही ये बहुत बड़ा सेक्टर है। लेकिन मैं जानना चाहूंगा, और ये चूंकि यहां पर इस सेंटर पे आया हूं, कि कितने हम लोग ने पेटेंट्स बनाए, क्योंकि हमारा जो टारगेट है, अभी आपने जिक्र किया, हमारा टारगेट यह है कि क्या हम चाइना से कॉम्पीट कर पाएंगे, हमारा टारगेट है यह है कि क्या हम वर्ल्ड ओवर जा पाएंगे। आप में से कितने लोग स्टैनफोर्ड के बारे में जानते हैं? स्टैनफोर्ड यूनिवर्सिटी के बारे में कितने लोग जानते हैं? कहाँ है, कोई बता सकता है? कहाँ है स्टैनफोर्ड, कहाँ है? कोई भी छात्र खड़ा होकर बता दे। हाँ जी, आप बताइए, स्टैनफोर्ड कहाँ है? बताइए, कोई बता सकता है स्टैनफोर्ड कहाँ है? छात्र बता दे, कोई बता दे। हाँ जी, खड़े होकर बताइए, घबराइए नहीं। अरे हाँ, मैं बहुत सख्त टीचर हूं। हाँ, कैलिफोर्निया में है। तो मैं लगभग 2 साल पहले स्टैनफोर्ड गया था, मुख्यमंत्री जी ने हम लोगों को भेजा था कि हम पूरे विश्व में जगह जगह जाकर इंडस्ट्री को इनवाइट करें। मेरी जो अपनी भतीजी है वो स्टैनफोर्ड में पढ़ती भी है, अभी इस समय पढ़ रही है, मेडिसिन कर रही है और वो डॉक्टर बनने की तैयारी कर रही है, लंबी पढ़ाई वहाँ होती है। और स्टैनफोर्ड में चूंकि औपचारिक रूप से, सरकारी रूप से हमको अपने वित्त मंत्री जी के साथ जाने का अवसर मिला, तो वहाँ एक इंस्टीट्यूट ऑफ बायो डिजाइन में हम लोग गए और आपको जानकर खुशी होगी कि इंस्टीट्यूट ऑफ बायो डिजाइन में पहली बात तो आधे से ज्यादा लोग इंडियंस ही थे, उसका जो हेड था वो भी इंडियन था। सेकंड, जितने भी उसमें प्रोफेसर्स और वहां फैकल्टी थी वो लगभग सभी के इंटरनेशनल पेटेंट्स थे और उनमें से 1 या 2 मुझे बताया गया बिलियनियर भी थे। तो ये जो वेल्थ क्रिएशन और वैल्यू क्रिएशन है, ये जब हमारे इंडियंस विदेश में जाकर वैल्यू क्रिएट कर सकते हैं तो इंडिया में रहकर क्यों नहीं कर सकते हैं? ये प्रश्न अब हमको पूछना पड़ेगा और ये प्रश्न अगर हम नहीं पूछेंगे तो हम आगे नहीं बढ़ेंगे। मुझे इस बात की खुशी है कि आप तो आईटी के बैकग्राउंड से हैं, मैं भी आईटी में, आज की तारीख में मैं आईटी कानपुर के इनोवेशन हब का मैं डायरेक्टर भी हूं, मैं उनके बोर्ड में भी हूं। आज की तारीख में आईटीज ने जोर पकड़ लिया है और बहुत सारा इनोवेशन, बहुत सारा रिसर्च आईटीज में हो रहा है। लेकिन आपका जो एरिया है प्लास्टिक्स का, पेट्रोकेमिकल्स का, इस एरिया में तो कोई और इंस्टीट्यूशन है ही नहीं। तो आपके इस एरिया में जो भी रिसर्च हो रही होगी वो आप ही के थ्रू होगी, फैक्ट्रीज जो है, जो कंपनीज लगी हुई वो आप ही के थ्रू होगी, टेस्टिंग होगी तो आप ही के माध्यम से होगी और जो नए छात्र तैयार किए जाएंगे वो भी आप ही के माध्यम से होंगे। मेरा एक सुझाव ये है कि आपके यहाँ बहुत सारा जो है कार्य हुआ है, लेकिन पेटेंटिंग पर और इस पर जो है विशेष रूप से आपके पास सरप्लस भी है। एक अलग रिसर्च के लिए आपने 3 इंस्टीट्यूशंस ऑलरेडी खड़े कर रखे हैं। रिसर्च के प्रति भाव को आगे बढ़ाते हुए, पेटेंटिंग पर विशेष ध्यान देते हुए एक पर्टिकुलर पूरा एक फोकस ग्रुप उस पर बनाइए और जरूरत पड़े तो इंटरनेशनल पार्टनर्स को भी लीजिए। जायका आपको ऑलरेडी पार्टनर रहा है, आप और भी आगे इंटरनेशनल यूनिवर्सिटीज को पार्टनर्स लीजिए, क्योंकि बहुत सारी इंटरनेशनल यूनिवर्सिटीज के पास मैन पावर नहीं, आइडियाज उनके पास होंगे लेकिन मैन पावर नहीं। तो आप पार्टनरशिप में अगर आप आएंगे तो हमारे स्टूडेंट्स, हमारे जो फैकल्टी है उनको आगे बढ़ाकर आगे ले जा सकेंगे। तो मेरा पहला बिंदु तो यह है। दूसरा बिंदु, आपने कहा कि आप अपने सिपेट लखनऊ को और एक्सपैंड करना चाहते हैं। मैं निश्चय ही आपको बताना चाहूंगा कि इसमें जो भी सहयोग होगा वो हम लोग प्रोवाइड फॉर करेंगे और बहुत जल्दी शिशिर सिन्हा साहब ने अपने प्रस्ताव बनाकर देने के लिए कहा है, उसमें जो भी संभव सहायता होगी वो हम देंगे। आईटी कानपुर को जोड़ने के लिए हम लोगों ने जो है हम जिस संस्था को चला रहे थे, यूबिडा, जो एक्सप्रेसवेज बनाती है, हम लोगों ने 12 करोड़ रुपया जो है एक सेंटर ऑफ एक्सीलेंस के लिए आईटी कानपुर को ड्रोन्स के लिए दिया है। अगर हम आपकी पॉलिसी जो स्टेट गवर्नमेंट की है हम उनको देखेंगे, अगर आपके सेक्टर में भी कोई सेंटर ऑफ एक्सीलेंस बन सकता है तो स्ट्रेट फॉरवर्ड, अगर एआई इन प्लास्टिक्स आपको यूज कर रहा है तो मुझे ऐसा लगता है कि इसके सेंटर ऑफ एक्सीलेंस के लिए आप मूव कर सकते हो। और हमारी स्कीम ही है प्रदेश सरकार की, जिसमें वो नेशनल इंस्टीट्यूट्स जो भारत सरकार के इंस्टीट्यूशंस हैं, नॉन एकेडमिक इंस्टीट्यूशंस हैं, उनको सेंटर ऑफ एक्सीलेंस के लिए 10 करोड़ रुपए तक दे सकते हैं। तो मेरा सुझाव आपको होगा कि एक बार हमारे साथ बैठिएगा, हम लोग पीछे पड़ेंगे। आज ही सुबह मुख्यमंत्री जी से बात हो रही थी, हाई एंड एरियाज के लिए निश्चय ही जो है हम लोग उस पर काम करेंगे और इसमें सफलता अवश्य मिलेगी। हमारा टारगेट यह है कि 3 महीने में आगे बढ़ जाए और 6 महीने में उसमें कहीं ना कहीं आगे उसकी जो है सफलता तक आगे बढ़े। तीसरा जो है प्लास्टिक वेस्ट मैनेजमेंट का एक मेजर इशू है, इसमें सेंटर ऑफ एक्सीलेंस आपका हो सकता है और इसमें अर्बन डेवलपमेंट डिपार्टमेंट के साथ कैसे आप सेंटर ऑफ एक्सीलेंस बना सकते हैं, सोचिएगा। आईटी कानपुर ने भारत सरकार से जो एआई का 10,000 करोड़ का फंड है, उसमें अर्बन डेवलपमेंट के लिए एआई यूज करने के लिए, प्लानिंग ऑफ अर्बन एरियाज के लिए फंड लिया है। तो सिपेट भी अगर किसी रूप में आर्टिफिशियल इंटेलिजेंस के क्षेत्र में काम करना चाहेगा तो इस एरिया में भी हम लोग स्टेट गवर्नमेंट की कम से कम स्कीम से आगे बढ़ा सकेंगे। एक चौथा एरिया जो आपने कहा है उसमें मैं सीधे जुड़ा हुआ हूं। हम लोगों ने एक नई कंपनी गठित की है स्टेट गवर्नमेंट में, उस कंपनी का नाम है प्रमोट फार्मा, वो सेक्शन 8 कंपनी है। आप में से कितने लोगों ने बायरैक के बारे में सुना है? किसी ने सुना है बायरैक? क्या है बायरैक, बताइए। बायरैक क्या है? यस एग्जैक्टली, बैठिए। डिपार्टमेंट ऑफ बायोटेक्नोलॉजी की भी एक सेक्शन 8 कंपनी है। जितनी भी वैक्सीन आपको देश में लगी है, चूंकि वैक्सीन किसी विभाग के माध्यम से नहीं बांटी जा सकती थी, जो हमारे प्राइवेट पार्टनर्स थे उनकी वैक्सीन बायरैक जो एक संस्था सेक्शन 8 की बनी है उसके थ्रू जो है भारत सरकार ने बांटी। और उसी प्रकार की एक एजेंसी प्रमोट फार्मा हम लोगों ने स्टेट गवर्नमेंट में भी बनाई है। तो इसमें मेडिकल डिवाइसेस को आगे बढ़ाने के लिए जहां प्लास्टिक्स का इस्तेमाल होता है, इस पर भी हम लोग विचार करेंगे। लगभग 90 से ज्यादा यूनिट्स को मेडिकल डिवाइसेस के लिए यमुना एक्सप्रेसवे में जो है जमीन अभी आवंटित, हम लोग ने उसको पुश किया था, वो हुआ है। तो निश्चय ही इस कार्य में भी कैसे मेडिकल डिवाइसेस में प्लास्टिक्स का इस्तेमाल हो सकता है, इसको भी हम लोग देखने की आवश्यकता होगी और हम लोग इस पर काम करेंगे। मुझे इस बात की खुशी है कि आपके यहाँ डिप्लोमा में और डिग्री में लगभग 90% और 85% लोग जो है प्लेसमेंट इनका हो रहा है। दिस इज अ वेरी गुड थिंग। बट मैं ये आपको कहना चाहूंगा कि आपके 35,000 एल्यूमनाई हैं। किसी भी एल्यूमनाई को छोड़िए मत कि कम से कम लाख, 2 लाख, 3 लाख, 4 लाख रुपए का वो कंट्रीब्यूशन ना करे। मैं आईटी कानपुर का एल्यूमनाई हूं, तो मुझसे 5 लाख रुपया वो ले चुके हैं और आगे भी लेने के लिए फिराक में है। और मेरे फादर आईटी बीएचयू के हैं, तो उनकी डेथ के बाद जो है मैंने भी 15 लाख रुपए, मैं और मेरे ब्रदर ने वहां के मेटलर्जी डिपार्टमेंट जिसमें वो थे, उसके जो टॉप मोस्ट जो भी स्टूडेंट था उनके नाम से जो है हम लोग ने 15 लाख रुपए जमा कराए हैं। हर साल 1 लाख रुपए जो वहां का टॉपर होता है उसका मिलता है। तो बहुत सारे तो लोग इसलिए भी फंड कर देंगे कि अपने माता पिता के नाम से या अपने खुद के नाम से भी जो यहाँ के स्टूडेंट रहे हो वो अपने नाम से या अपने माता पिता के नाम से अच्छे स्टूडेंट्स को साल में स्कॉलरशिप दे सके। इस तरह से भी जोड़िए। एल्यूमनाई के लिए भी एक बहुत ही मजबूत सेल बनाइए। आईटी कानपुर का एल्यूमनाई ने बहुत अच्छा कार्यक्रम अभी 40 इयर्स का मेरा कराया है। हमारे आईटी कानपुर का एल्यूमनाई जो है आईएम का चेयरमैन है, अलग अलग बड़ी बड़ी कंपनीज के चेयरमैन है, और ये लोग 500 करोड़ का एक जो है कंप्यूटर वहां लगाने जा रहे हैं। आप सोचिए इस तरह के भी एल्यूमनाई है। तो मैं केवल ये बताना चाहता हूं कि वन कैन थ्रू द ऑर्गेनाइजेशन वर्क वेरी हार्ड टू फाइंड आउट हु आर द एल्यूमनाई जो विदेश में है, वो विशेष रूप से अपने देश में आकर वापस कुछ देना चाहते हैं। और इसमें कहीं ना कहीं आप लोगों को और लगने और जुटने की आवश्यकता है, लेकिन फुल टाइम लोगों को लगाइए जो इसी काम में लगें। मुझे इस बात की भी खुशी है कि आज आपने जो ये 3 दिन की वर्कशॉप की है, 16th इंटरनेशनल कॉन्फ्रेंस APM 2025, और अगले साल आप राजस्थान में 2026 करने जा रहे हैं, और इसमें आप विकसित भारत की सोच रख रहे हैं। मैं आपको बताना चाहूंगा कि केंद्र सरकार प्रधानमंत्री जी के मार्गदर्शन में 5 ट्रिलियन के लक्ष्य को आगे बढ़ा रही है, और संभवतः 2 साल में 5 ट्रिलियन का टारगेट पूरा हो जाएगा। लेकिन उत्तर प्रदेश सरकार भी जो है अगले 2-3 साल में 1 ट्रिलियन तक पहुंचने का लक्ष्य योगी आदित्यनाथ जी ने, हमारे माननीय मुख्यमंत्री जी ने रखा है, जिसके कमेटी के मैं अध्यक्ष हूं। तो इस कार्य में भी हम लोग जुटे हुए हैं, और इस कार्य को जोड़कर आगे बढ़ने के लिए आप जैसी बड़ी बड़ी संस्थाएं जो है, जो पूरे देश में विकसित हैं, आपका सहयोग प्रदेश के विकास में भी आवश्यक होगा। तो निश्चय ही आपका सहयोग हम लोग लेते रहेंगे, जिससे कि हम विकसित भारत के प्रधानमंत्री जी के सपने को हम आगे ले जा सके। R&D के क्षेत्र में मैं केवल यही कहना चाहूंगा कि आप कम से कम अपने प्रॉफिट का 20% R&D पर जरूर लगाइए, क्योंकि ये जो है एक एरिया ऐसा है जो ग्रो करता चला जाएगा। पूरे विश्व में आज की तारीख में जितना यूथ इंडिया में है उतना यूथ कहीं नहीं है, और जितना यूथ ब्राइट आइडियाज के साथ इंडिया में है कहीं नहीं है। तो आपके भी यूथ में से कुछ लोग अगर स्टार्टअप्स में जा रहे हैं तो मुझसे सीधे संपर्क कराइए। 10 ऐसे यूथ को इस साल टारगेट कर लीजिए, लड़के हों लड़कियां हों, उनको हम स्टार्टअप्स के माध्यम से निश्चय ही कोई ना कोई आगे कार्य कराएंगे। जो आपके डिप्लोमा होल्डर्स यहाँ से निकल रहे हैं उनको अभी बहुत जल्दी ही आदरणीय मुख्यमंत्री जी ने 5 लाख की एक योजना शुरू की है जिसमें 0 इंटरेस्ट का ऋण दिया जा रहा है। ऐसे स्टूडेंट्स जो आगे खुद व्यवसाय करना चाहेंगे, स्टेट गवर्नमेंट की स्कीम से भी जोड़ने का निश्चय ही हम लोग प्रयास करेंगे। डॉक्टर अनिल जोशी जी मुझसे जुड़े हुए हैं, तो वो एक नया कॉन्सेप्ट लाए हैं। आप ग्रॉस डेवलपमेंट प्रोडक्ट जीडीपी की बात करते हैं, वो ग्रॉस एनवायरमेंट प्रोडक्ट की बात करते हैं कि हम अपने पानी को स्वच्छ रखें, हम अपनी मिट्टी को स्वच्छ रखें, हम अपनी हवा को जो है स्वच्छ रखें और अपने फॉरेस्ट को बचाए रखें। तो ये भी बहुत बड़ा एक कार्य है। तो प्लास्टिक वेस्ट और वेस्ट मैनेजमेंट एक एरिया है जो उनको निश्चय ही उनके दिल को छुएगा। तो इस बार आपकी तारीफ उन्होंने की है, तो बड़ी अच्छी बात है कि आपकी उन्होंने तारीफ की है, लेकिन बहुत भले और जानकार इंसान है, तो उनका भी मैं जो है स्वागत अपने ओर से करना चाहूँगा। मैं पुनः ये कहना जरूर चाहूँगा कि आप में से जितने भी स्टूडेंट्स यहाँ हैं, अगर आने वाले समय में आप में से कितने लोग ऐसे हैं जो 5 घंटे काम करते हैं, 5 आवर्स मिनिमम 5 आवर्स, 3 ही हाथ खड़े हो रहे हैं, अरे बाप रे बाप। कितने लोग 10 घंटे काम कर रहे हैं? लड़कियां कुछ खड़े होकर नहीं बता रही, कितने घंटे काम करती हैं? खड़े हो जाइए आप, ब्लू दुपट्टे में जो है खड़े हो जाइए। हाँ, खड़े हो जाइए। क्या नाम है अपना बताइए और क्या आपका कोर्स है बताइए। व्हाट इज योर नेम? वैशाली। अच्छा ये बताइए कितने घंटे आप पढ़ रही हैं, काम कर रही हैं, वर्क कर रही हैं? 8 आवर्स पर डे। वेरी गुड, ताली बजाइए इनके लिए। देखिए मेरा मानना यह है कि अगर किसी भी क्षेत्र में कहीं भी आप हैं, तो अगर आपने 10 घंटे कम से कम काम नहीं किया और छुट्टी भी बहुत मिनिमम नहीं ली, तो आप लोग निश्चय ही आगे बढ़ पाएंगे। मैं केवल इतना जरूर कहना चाहूंगा, चूंकि मैं एक टीचर के रूप में और काफी वरिष्ठ टीचर के रूप में हूं, आप में से कितने लोग सोशल मीडिया पर हैं? हाथ खड़ा करिए जिनके ट्विटर और बाकी अकाउंट्स है। तमाम सारे लोग हैं। कितने घंटे आपके सोशल मीडिया पे जाते हैं? हाँ, खड़े हो जाएगा, घबराइए नहीं, दिस ऑल विद इन द रूम। 1 to 2 आवर्स, 1 आवर से ज्यादा मत करिए। अगर आपने सोशल मीडिया 1 आवर से ज्यादा किया तो निश्चय ही आपका कैरियर ऐसे जाने की बजाय या ऐसे जाने की बजाय ऐसे आ जाएगा। ये हमारे सामने बहुत बड़ा चैलेंज है कि वी आर नॉट फोकस्ड ऑन व्हाट वी आर ट्राइंग टू डू, एंड दिस इज वेयर I keep, whenever I meet students, I keep telling them that अपना सोशल मीडिया कम से कम पढ़ते समय जो है अलग कर दीजिए, अपना काम करते समय अलग कर दीजिए, नहीं तो आगे आने वाले समय में सबसे बड़ा चैलेंज यूथ के लिए हमारे देश में अगर है तो ये जो सोशल मीडिया का डाइवर्जन है, और इसके लिए आपको बहुत मेहनत करनी पड़ेगी। आई एम वंस अगेन थैंकफुल कि यहाँ आज शिशिर सिन्हा साहब के पास मैं आया हूँ। Within 3 to 6 months we will come back to this institution। कोशिश करेंगे कि हम अपने माननीय मुख्यमंत्री जी का भी मार्गदर्शन जल्दी इसके लिए प्राप्त करें। हम जरूर आपसे कहना चाहेंगे कि ये इंस्टीट्यूशन एक ऐसी जगह है उत्तर प्रदेश में जहां एक मजबूत एरिया में, लखनऊ में है, तो निश्चय ही इसको जो भी लाभ दिया जा सकता है वो लाभ हम लोग देने का पूरा प्रयास अपनी ओर से तो करेंगे, आगे आने वाले प्रदेश से भी इसमें सहयोग अपना प्रदान करेंगे, लेकिन ऐसे इंस्टीट्यूशन देश को आगे ले जाएंगे, ये हमारा निश्चित विश्वास है। आपको बहुत 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 बधाई, धन्यवाद, और मुझे आज यहां बुलाने के लिए विशेष आभार। धन्यवाद।
आपके प्रेरणादायी उद्बोधन के लिए बहुत बहुत आभार सर। संबोधन की श्रृंखला से आगे बढ़ते हुए अब हम आते हैं उस सबसे महत्वपूर्ण कड़ी की ओर, जिसका बड़ी बेसब्री से हमारे सामने बैठे हुए युवा और बच्चे इंतजार कर रहे हैं। सर, जैसा कि समारोह के प्रारंभ में चर्चा हुई थी कि 16वीं एपीएम हमारी जो हुई है ये कई मायनों में खास है। सामान्यतः इस तरीके के अंतर्राष्ट्रीय सम्मेलन जब होते हैं तो इनमें जो शिक्षाविद होते हैं, शोधार्थी होते हैं, इनके रिसर्च पेपर और वो एक्सपर्ट डिस्कशन में ही मामला जो है सीमित रहता है, लेकिन इस बार कुछ नवाचार किया गया है सीपेट लखनऊ के द्वारा, और जिसमें हमने कोशिश की है कि ज्यादा से ज्यादा अवेयरनेस हम स्प्रेड करें लोगों में, स्पेशली बच्चों में। जैसा कि सर ने अपने संबोधन में बताया था, माननीय महानिदेशक महोदय ने, कि हमने एक अभियान शुरू किया है नो प्लास्टिक से नो प्लास्टिक। उसके चलते इस बार एपीएम में पहली बार हमने स्कूल के बच्चों को शामिल करते हुए कुछ प्रतियोगिताएं कराई थी जो कि दिनांक 5 मार्च 2025 को संपन्न कराई गई थी। कक्षा 5 से लेकर के कक्षा 8 तक के बच्चों के लिए सिंगल यूज प्लास्टिक और प्लास्टिक्स वेस्ट मैनेजमेंट के ऊपर प्रश्न मंच का आयोजन किया गया था, जिसमें काफी, चूंकि ये परीक्षा का माह है, इसके बावजूद काफी संख्या में विभिन्न विद्यालयों से बच्चों ने भाग लिया था। मैं इस मंच से जो प्रतिभा, वैसे तो सारे ही बच्चे विजेता हैं, क्योंकि कहा गया है किसी महान व्यक्ति के द्वारा कि जीतना महत्वपूर्ण नहीं है, भाग लेना बहुत महत्वपूर्ण है। तो मंच पर हमारे जो अतिथि उपस्थित हैं, मैं उनसे अनुरोध करूंगा कि वे अपने स्थान से हमारे विजयी बच्चों को पुरस्कार प्रदान करें। कुछ कंपटीशन में तीसरा स्थान प्राप्त किया था स्प्रिंगडेल कॉलेज से कनिष्मा, प्यारी बेटी कमिश्नर, 3rd प्राइज। मैं अनुरोध करूंगा कमेटी से कि इनका प्रमाण पत्र जो है अतिथि तक पहुंचाएं और उनका तोहफा। इस प्रतियोगिता में द्वितीय स्थान पर स्टेला मैरी इंटर कॉलेज लखनऊ से अक्षत खाटिल ने द्वितीय स्थान प्राप्त किया है। जोरदार तालियों से अभिनंदन करेंगे। इस प्रतियोगिता में पहला स्थान प्राप्त करने वाला बच्चा भी स्टेला मैरी इंटर कॉलेज लखनऊ से है। तालियों के साथ स्वागत करें अथर्व सिंह। इसके बाद कक्षा 9वीं से कक्षा 12वीं तक के बच्चों के लिए पोस्टर कंपटीशन का आयोजन किया गया था, जिसका विषय था डिजाइन फॉर सस्टेनेबिलिटी एंड सर्कुलर इकोनॉमी। इसमें 3rd प्राइज जो है, इसमें 2 लोगों ने तृतीय स्थान प्राप्त किया है। मैं आवाज देना चाहूंगा शर्मिला निषाद, HPSD कन्या इंटर कॉलेज गोरखपुर। तृतीय स्थान पर ही जो दूसरे प्रतिभागी हैं जिन्होंने तृतीय स्थान प्राप्त किया है, मॉन्टफोर्ट स्कूल रुड़की से सयूरी सिन्हा। पोस्टर कंपटीशन में दूसरा स्थान प्राप्त किया है नंदिनी गर्ग, शिक्षा स्टडी सेंटर लखनऊ। ये नन्हे मुन्ने बच्चे हैं, युवा पीढ़ी की तरफ अपना पथ प्रदर्शित कर रहे हैं और इनकी जो इमेजिनेशन होती है यही हमारे आने वाले भविष्य की तस्वीर गढ़ेगी। हम जो लगातार विकसित भारत 2047 की बात कर रहे हैं, उस रूपरेखा को यथार्थ कराने में इस पीढ़ी का कहीं ना कहीं सक्रिय योगदान रहेगा। जोरदार तालियां बजनी चाहिए। इस प्रतियोगिता में पहला स्थान प्राप्त किया है पुनः मॉन्टफोर्ट स्कूल रुड़की से प्यारी बिटिया सिन्हा ने, माफ कीजिएगा, सयोना सिन्हा। इसके बाद एक और हमने प्रतियोगिता आयोजित की थी जिसमें हमारे अखिल भारतीय स्तर पर जितने भी आईपीटी सेंटर्स हैं वहां से जो बच्चे आए थे उनके लिए डिजाइन फॉर सस्टेनेबिलिटी एंड सर्कुलर इकोनॉमी विषय पर ब्रेनस्टॉर्मिंग सेशन रखा गया था और इस पे समस्त आईपीटी सेंटर्स जो हमारे थे उनके बच्चों ने भाग लिया था।
और इसमें तृतीय स्थान प्राप्त किया है सीपेट रायपुर से अभिनव मिश्रा और आरती ने। इस प्रतियोगिता में द्वितीय स्थान प्राप्त किया है सीपेट आईपीटी मुरथल ने शुभम कुमार, हर्ष गंभीर। और इस सेशन में पहला स्थान प्राप्त किया सीपेट आईपीटी चेन्नई ने शक्तिवेल जी और एसआर हयागुरथवन सीपेट चेन्नई से, लेकिन चूंकि इनकी ट्रेन थी तो ये चले गए हैं। तो प्रतिनिधि के रूप में मैं अनुरोध करूंगा संस्थान के मुख्य प्रबंधक डॉक्टर सैयद अमानुल्लाह सर से कि वो आकर के इन बच्चों के बिहाफ में उनके प्रमाण पत्र और उनके तोहफे प्राप्त करें। इसके बाद जो पुरस्कार की कड़ी है उसकी मैं यहां से घोषणा करता हूं। मैं मंचासीन अतिथि से अनुरोध करूंगा कि वे अपना स्थान ग्रहण करें मंच पर। जो दो सर ने जैसी चर्चा करी थी कि हमारा जो ये अंतर्राष्ट्रीय सम्मेलन होता है इसमें दो भाग हमारे होते हैं, ओरल प्रेजेंटेशन के होते हैं और पोस्टर प्रेजेंटेशन के होते हैं, जिसमें प्रतिभागियों ने भाग लिया था। और इस बार बड़ी प्रसन्नता का विषय है कि एम्स्टर्डम नीदरलैंड्स के जो पब्लिशर हैं, जो वर्ल्ड वाइड नोन हैं, इन्होंने $100 पर स्टूडेंट स्पॉन्सर किया है 5 बेस्ट पोस्टर प्रेजेंटेशन के लिए, जिनके नाम मैं मंच के माध्यम से अनाउंस करने जा रहा हूं। ये है अनुराधा बिस्वाल VSSUT ओडिशा से, तालियां बजती रहनी चाहिए। KM मानसी आदित्य IIT जम्मू, मल्लिका सिंह HBTU कानपुर, पंकज लोचन सारंगी सीपेट IPT भुवनेश्वर, पायल मैती IIT खड़गपुर। इसी कड़ी में बेस्ट ओरल प्रेजेंटेशन में जो है इनके लिए स्प्रिंजर ने अपने पब्लिकेशन जो है के कूपन इनको दिए जाएंगे, उन्होंने स्पॉन्सर किए हैं 5 बेस्ट ओरल प्रेजेंटेशन के लिए। और ये खिताब हासिल किया है, ये 5 नाम है, मिस्टर बिमल त्रिपाठी MNNIT इलाहाबाद, पंकज कुमार लोधी HBTU कानपुर, डॉक्टर हरेंद्र कुमार सीपेट IPT मुरथल, हरिओम शरण गुप्ता IIT रुड़की, डॉक्टर पराग ठाकुर SBNIT सूरत। ये हमारे पोस्टर और ओरल प्रेजेंटेशन में जो 5 बेस्ट परफॉर्मर थे उनके नाम मैंने मन से अनाउंस किए हैं। इनकी जो पुरस्कार राशि है और कूपन है वो इन तक सीपेट लखनऊ के माध्यम से पहुंचा दिए जाएंगे। 3 दिन हम सभी लोग यहां पर रहे, विभिन्न हमारे सेशन यहां पर चले और हर सत्र में हमारे अलग अलग तरीके के अनुभव रहे। हमारे मंच के माध्यम से तो जितने हमारे स्पीकर्स थे, वक्ता थे, सभी को अपने विचार रखने का पूरा समय मिला और हम सब ने उनको सुना। आज चूंकि हम इस निचोड़ के लिए बैठे हैं कि आखिर में हमने क्या हासिल किया या हमारे अनुभव कैसे रहे, तो वैसे तो जो मुझे जानकारी मिली है मेरी तकनीकी टीम से, आप सभी लोगों ने आपको जो फीडबैक फॉर्म दिए गए थे वो आपने भर करके वापस कर दिए हैं। लेकिन बड़ी प्रसन्नता होगी मंच को भी कि यदि आप लाइव अपनी जो 3 दिन आपने जो यहाँ समय गुजारा है उसमें आपने जो महसूस किया हो वो यदि हम सबसे संक्षिप्त में साझा कर पाए। तो मैं मेरे साथी प्रवीण जी से अनुरोध करूंगा कि माइक लेकर के और ऑडियंस में चले जाएं। जल्दी से 5-7 लोग जो हैं वो अपना फीडबैक अगर देना चाहें तो आपका स्वागत है।
Good evening, sir. Myself, Dr. Nitish Kumar, from the CIPET IPT Vita. सर मैंने इसके पहले 10 से 12 कॉन्फ्रेंस मैंने अटेंड किया था, बट मैंने देखा कि इतने ज़्यादा फैसिलिटीज़ और इतने ज़्यादा प्रोबेबिलिटी जो है कहीं नहीं मिला सर। मैंने IIT में भी बहुत सारे कॉन्फ्रेंस अटेंड किए, NIT में भी किए, बहुत से रिप्यूटेड यूनिवर्सिटी वहाँ भी किए, बट ऐसा मैंने कहीं नहीं देखा सर। सो थैंक यू फॉर ऑर्गेनाइजर एंड थैंक यू फॉर द सिस्ना सर। थैंक यू सो मच फॉर दिस टाइप ऑफ द कॉन्फ्रेंस। आई वांट टू अगेन अटेंड द नेक्स्ट कॉन्फ्रेंस ऑल्सो सर। थैंक यू।
Sir, I am Dr. Parag Thakur from SUNIT Surat, and it is a really great opportunity for young faculties like us to meet the very famous personalities in our field, and thank you for this opportunity. And the panel discussion that happened yesterday, that was very insightful, and we are very thankful for the hospitality, and to the coordinators, all the coordinators, they have done very good job for taking care of the participants. So thank you for this opportunity.
जयपुर वाला अभी नहीं, जब बोलूँगा।
हेलो सर, आई एम निशान जोशी फ्रॉम IIM अहमदाबाद। जैसे पिछले साल भी मैं APM में था सर, तो मैंने सर को बोला था कि ज़्यादातर APM में टेक्निकल सेशंस ही होते हैं, तो इस बार अगर आप थोड़ा नॉन टेक्निकल पार्ट भी लाएंगे तो APM में और भी ज़्यादा इंक्लूसिवनेस का अप्रोच आएगा। तो सर ने वो बोला था, तो इस बार मैं तो इंटरनल ऑडिटर हूँ IIM अहमदाबाद में, तो R&D तो होती है लेकिन पैसे का भी उतना ही महत्व रहता है। तो फाइनेंस अप्रोच कैसा रहना चाहिए R&D के साथ, तो ये मिलाप इस बार सर ने किया है तो बहुत ही अच्छा लगता है। तो उसके लिए मैं सर का धन्यवाद कहना चाहता हूँ, और आगे और भी फील्ड इसमें जोड़ी जाए तो मैं उसकी भी दरख्वास्त सर से कहना चाहता हूँ। बाकी इतना अभूतपूर्व रिस्पॉन्स मैंने ये APM में पहली बार देखा हुआ है कि जो बच्चों को मिल रहा है कि इतनी बड़ी बड़ी एमिनेंट पर्सनालिटीज़ जो इतने नज़दीक से देखने को मिल सकती है, वो बाहर जाके आपको कहीं नहीं मिलेगी, जो इस APM में मैंने देखा हुआ है। सो थैंक यू सो मच।
और कोई हमारा साथी कुछ कहना चाहे तो? कार्यक्रम को आगे बढ़ाते हुए मैं अनुरोध करूंगा आदरणीय महानिदेशक महोदय से और CIPET जयपुर की टीम से कि APM 2026 का विधिवत उद्घोषणा मंच के माध्यम से की जाए और उसका बैनर डिस्प्ले हो, और हम सभी लोग CIPET जयपुर को बधाइयां दें, अग्रिम बधाइयां दें कि आने वाले वर्ष की हमारी जो APM है वो इससे भी और विस्तृत, बृहद और शानदार हो। मैं अनुरोध करूंगा CIPET जयपुर से पधारे हुए प्रतिनिधियों का कि वे मंच पर आएं। सो जो बैटन हमने रिले रेस में उठाया था अहमदाबाद से, वो हम ससम्मान हस्तांतरित करते हैं CIPET जयपुर को।
धन्यवाद महानिदेशक श्री शिशिर सिन्हा सर। चौधरी सर ने एक मैसेज दिया था, वो हम बोलना चाह रहे हैं कि चौधरी सर ने बोला है कि हमारे महानिदेशक साहब को कि उन्होंने जयपुर को इस लायक समझा, उसके लिए हम धन्यवाद देते हैं। वहाँ 2 लाइनें बोल देना कि हम लोग आपके संरक्षक में और APM 2026 में भी अच्छा करेंगे। थैंक यू सर।
बहुत बहुत धन्यवाद CIPET जयपुर टीम का। हम कार्यक्रम की अगली कड़ी की ओर बढ़ते हैं। मंच पर हमारे बीच मुख्य अतिथि के रूप में एक हस्ती मौजूद है और जब हमारे बीच हमारे ऐसे बुजुर्ग होते हैं जिनके आशीर्वचन हमें मिलता है, जिनका मार्गदर्शन हमें मिलता है, ऐसे समय में हम उनका सम्मान करके, उनका अभिनंदन करके स्वयं को गौरवान्वित महसूस करते हैं। और सीपेट में हम सभी के प्रति जो आज इस अभूतपूर्व पल की स्मृतियां आपके हृदय में सदैव अंकित रहें, इस कामना से एक छोटा सा स्मृति चिन्ह माननीय मुख्य अतिथि महोदय को प्रेषित किया जाएगा। मैं माननीय महानिदेशक महोदय से अनुरोध करूंगा कि वे हम सभी की ओर से हमारे मुख्य अतिथि महोदय को एक स्मृति चिन्ह प्रदान करें। अब सर 10 मिनट का समय और आपसे सर चाहूंगा मैं, सभी 10 मिनट का समय चाहूंगा सर। आज की शाम के और यूं कहें इस एपीएम की सबसे खास, मैं उसे अवार्ड कहूं, मैं उसको सम्मान कहूं, मुझे शब्द नहीं मिल रहे हैं, मैं बयान करता हूं, आप स्वयं निश्चय कर लीजिएगा कि आप क्या शब्द देना चाहते हैं। 1993 में बीटेक की डिग्री HBTU, वन ऑफ द ओल्डेस्ट इंस्टीट्यूट ऑफ द कंट्री से बीटेक केमिकल इंजीनियरिंग में वो करते हैं। 1995 में एमटेक नहीं करना करते हैं और हमारे बीच आज महानिदेशक के रूप में मौजूद है। और आपके ही संरक्षण में हम लोगों ने इस एपीएम के सफर को पूरा किया है। अविश्वसनीय सफर था और कहीं ना कहीं हम जब डगमगाए, हिले, परेशान हुए, लगा कि अब चीजें हमारे हाथ से निकल जाएंगी, वहां आपने एक बड़वृक्ष की तरह खड़े होकर के हम सभी को पूरी ऊर्जा दी, हमें ये प्रेरणा दी कि हम समझ जाएं, आगे बढ़ें। और उसका सुखद अनुभव है कि आज हम लोग यहाँ पर इस मुकाम पे खड़े हैं कि जिसका आगाज हमने किया था 3 दिन पहले, आज उसके एक शानदार समापन की ओर हम हैं। लेकिन इस किसी भी कार्यक्रम में, किसी भी आयोजन में बहुत सारे ऐसे लोग होते हैं जो पर्दे के पीछे होते हैं, कुछ पर्दे के सामने होते हैं, कुछ परोक्ष होते हैं, कुछ प्रत्यक्ष होते हैं। हर स्तर का व्यक्ति जब इन्वॉल्व होता है तब एक कार्यक्रम जो है वो पूर्ण होता है, संपन्न होता है, सफलतापूर्वक किया जा सकता है। इसीलिए जितने भी लोग इस एपीएम के आयोजन में शामिल रहे हैं उनके प्रति आभार प्रकट करने के लिए आभार प्रदर्शन हेतु मैं सीपेट लखनऊ के संयुक्त निदेशक श्री विवेक कुमार जी से अनुरोध करूंगा कि वे आए और आभार प्रदर्शन करें।
धन्यवाद नीतीश जी। धन्यवाद तो आपने बीच बीच में सभी को पहले ही दे दिया और जो मेरा ये मौका था वो भी आप बीच बीच में चुराते रहे। ये बात सही है कि ये इस कार्यक्रम का आज समापन होने जा रहा है, लेकिन अगर आप मेरे मन की बात मैं कहना चाहूँ तो शायद इसका हो सकता है मैं इमोशनल भी हो जाऊँ, क्योंकि इतनी मेहनत, इतनी टीम वर्क और इतना हार्ड वर्क जो सीपेट लखनऊ ने किया, हमारे आदरणीय महानिदेशक प्रोफेसर डॉक्टर शिशिर सिन्हा सर के सानिध्य में, और दिन रात उन्होंने जो हमें प्रेरणा दी। सीपेट अहमदाबाद में जब ये निश्चय हुआ कि लखनऊ में 2025 की ये कॉन्फ्रेंस, इंटरनेशनल कॉन्फ्रेंस एपीएम 2025 होगी, उस दिन से लेकर और आज तक शायद ही कोई दिन गया होगा जब उन्होंने पूछा नहीं होगा कि भाई क्या चल रहा है, कैसे होगी, क्या तैयारी है, कैसे आप करेंगे, क्या इंफ्रास्ट्रक्चर डेवलप करेंगे। दिन रात उन्होंने जो प्रेरणा दी है, मैं उनका बहुत बहुत आभार व्यक्त करता हूं। आज इस कार्यक्रम में अवस्थी सर आए और जो शब्द और जो प्रेरणा उन्होंने हमें दी और जो पॉइंट्स जिन पे ऑलरेडी सर से डिस्कशन होता रहता है, हमारे निदेशक महानिदेशक आदरणीय सीसी सिन्हा सर जो बार बार हमसे बोलते रहते हैं कि सेक्शन 8 कंपनी के बारे में सोचिए, एआई के बारे में सोचिए, नई नई कोर्सेज के बारे में सोचिए, ऑनलाइन कोर्सेज के बारे में सोचिए। आज वही चीजें अवस्थी सर ने भी रखी। तो सर मुझे धीरे से बोल रहे थे कि ये तो मैं तुम्हें कह ही रहा था, तुमने करी नहीं। तो एपीएम की अगर मैं बात करूं तो हमारी लखनऊ टीम जिन्होंने इतने अथक प्रयास से इसको सफल बनाने का बेड़ा उठाया था, आज ये देखकर बहुत खुशी हो रही है कि जितने भी लोग यहां उपस्थित हैं, जिन्होंने भी रिसर्च पेपर यहां प्रेजेंट किए हैं, वो हमारी छोटे से इस प्रयास से खुश होकर जा रहे हैं। जो टीम इसमें लगी हुई थी, मैं उन सभी टीम का धन्यवाद देना चाहता हूं, चाहे वो हमारी इवेंट टीम हो, चाहे वो हमारी टेक्निकल टीम हो, चाहे वो हमारी ट्रांसपोर्ट टीम हो, चाहे वो हमारी फूडिंग एंड कैटरिंग टीम हो, चाहे इस पूरे इंफ्रास्ट्रक्चर को डेवलप करने में लगी हुई टीम हो। नाम बहुत हैं, इस मंच से लेने तो समय काफी बीत जाएगा, लेकिन मैं सभी को बहुत बहुत धन्यवाद देना चाहता हूं। मैं उन लोगों को भी धन्यवाद देना चाहता हूं जिन्होंने इस प्रोग्राम को स्पॉन्सर करने में अहम भूमिका निभाई, और ये स्पॉन्सरशिप के जो मार्गदर्शक रहे वो भी डायरेक्टर जनरल साहब रहे, क्योंकि उन्होंने पर्सनल लेवल पे जिन लोगों से हमें मिलवाया और हमारा मार्गदर्शन किया कि भाई आप जाइए, इनसे मिलिए, इनसे स्पॉन्सरशिप की बात करिए, इनको बताइए सीपेट के बारे में। तो उससे दो फायदे हुए, एक तो सीपेट का प्रचार करने का वहां मौका मिला, और दूसरा उन्होंने जो स्पॉन्सरशिप हमें प्रोवाइड करी है उनके सबके लोगो आपके सामने हैं। उसके बिना ये संभव नहीं था। तो मैं चाहूंगा कि जोरदार तालियों के साथ सर का मैं धन्यवाद देना चाहता हूं। इसमें बहुत सारे स्पॉन्सर्स हैं, मन से नाम लोगों वाले सर 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 जी जी सर, थैंक यू सो मच फॉर योर गाइडेंस सर। डेफिनेटली नेक्स्ट टाइम वी विल डू दिस ऑल्सो। I also take the opportunity to express my sincere gratitude all the senior officials from state government and central government, PSUs, जिन्होंने अपना सहयोग दिया, मार्गदर्शन दिया, फैकल्टी मेंबर्स एंड आवर सीपेट एलुमिनाई जो यहाँ आए इस प्रोग्राम में, उन सभी का धन्यवाद। I would also express my sincere thanks to friends from media, press, social media, सभी का मैं धन्यवाद देना चाहता हूं। और एक स्पेशल थैंक्स उन लोगों के लिए, मेरी उस टीम के लिए जिसका मार्गदर्शन हमारे महानिदेशक सर ने दिया था कि भाई आपको अगर ऐसा लगता है कि आप जो आपकी टीम लखनऊ में है वो बिजी हो सकती है अपने डेली बेसिस के काम में जो डेली उनको करने पड़ते हैं, तो उन्होंने एक टीम हमें बोली कि अगर आपको अदर सीपेट सेंटर से भी मदद चाहिए तो आप ले सकते हैं, क्योंकि सीपेट एज अ होल फैमिली। सो वहां से मैं उनके मन से नाम लेना चाहता हूं, क्योंकि उन्होंने दिन रात यहां रह करके जो सहयोग दिया, और कुछ लोग ऑनलाइन जुड़े, उसमें डॉक्टर केपी भुवना, जोरदार तालियों के साथ उनका मैं धन्यवाद देना चाहता हूं। डॉक्टर वीएच संगीता फ्रॉम बेंगलुरु सेंटर, डॉक्टर पीयूष फ्रॉम जयपुर सेंटर, और पिछले 3 से 4 दिन मंच को संभालने वाले नीतीश कुमार जैन फ्रॉम सीपेट रायपुर सेंटर, अनुपम फ्रॉम हाजीपुर, हेमंत फ्रॉम हेड ऑफिस, सुशांत कुमार सामल फ्रॉम बेंगलुरु, आशीष फ्रॉम जयपुर, अविनाश फ्रॉम हेड ऑफिस। सो ये और भी लोग हैं, बट इतना अथक प्रयास इन लोगों ने सहयोग दिया, उनके लिए बहुत बहुत धन्यवाद। और अंत में स्पेशल थैंक्स टू आवर डायरेक्टर जनरल कि उन्होंने हमें इस योग्य समझा, और आज जो एक अभूतपूर्व चेंज सीपेट लखनऊ में देखने को मिल रहा है, और जो यहाँ पे जिस तरीके से पूरा सेंटर जगमगा रहा है पिछले 3 से 4 दिन तक, जो ऊर्जा इसमें आई, जो यहाँ पे एक एनर्जी का वातावरण बना, चाहे वो लोग जब यहाँ घूम रहे हैं, आ रहे हैं, जा रहे हैं, तो मन लग रहा है कि कंटिन्यूटी में ये चलता रहे। और मैं रिक्वेस्ट करूंगा कि आगे भी मैं सर से इस मन से रिक्वेस्ट करना चाहूंगा कि कोई भी कार्यक्रम सर आप आगे भी भविष्य में अगर सोचें तो हमें उसका एक तरीके से मतलब हम रिक्वेस्ट करेंगे कि हमें दिया जाए, हम उसके लिए दोबारा से उसको करना चाहेंगे, क्योंकि इससे जो मुझे जो पर्सनली फील हो रहा है कि जब लोग यहाँ आते हैं, सेंटर को देखते हैं, तो खुशी मिलती है और सेंटर की भी प्रगति होती है। तो इसके लिए सर आपका बहुत बहुत आभार, बहुत बहुत धन्यवाद। थैंक यू सो मच।
तीन दिन के इस अंतर्राष्ट्रीय सम्मेलन में चली मैराथन चर्चाओं का, प्रेजेंटेशन का खूबसूरत लम्हा साथ में हृदय में संजोए हुए आज के समापन समारोह के साथ हम APM 2025 से विदा लेते हैं। उम्मीद करते हैं कि अगले वर्ष इन्हीं दिनों जब हम सीपेट जयपुर में होंगे तो ज़्यादा स्वस्थ होंगे, ज़्यादा मस्त होंगे, ज़्यादा व्यस्त होंगे। इन्हीं शब्दों के साथ हम इस आज के समापन समारोह को विराम देते हैं। जैसी कि हमारी परंपरा है, कार्यक्रम के अंत में मैं आप सभी से अनुरोध करूंगा कि आप सभी अपने स्थान पे राष्ट्रगान के सम्मान में खड़े हो जाएं। फिर जल्द ही मुलाकात होगी इस वादे के साथ। आप सभी से बहुत बहुत नमस्कार। तब तक हंसते रहें, मुस्कुराते रहें।